this module, we're going to give you an overview of the Azure platform as a whole. These are some of the fundamental things you just need to be aware of before you hit some of the subsequent modules. In particular, we're going to cover the following: the cloud models that you need to be aware of that you may have heard about already in the industry, Azure's core infrastructure, including Azure regions and what you need to know about resource groups, which we'll use throughout the course, networking, virtual machines, and then we'll talk app and DB services, as well as some of the other services available to you in Azure. Finally, ending off with the Azure portal itself and how you can get around the portal and access Azure. Let's begin by taking a look at the cloud service models. And if we look at the traditional way, this is what we would deploy in our data center. And this is the stack that we basically have to manage. So from networking through storage, servers, and we often have a virtualization layer in the last 10 years. An operating system we might deploy, and then we have to run some middleware on top of it, runtime, data applications, etc. But all of this, you get the point, we would manage and maintain in the data center. Well, cloud came along, after virtualization, built upon that idea and gave us additional models. The first one being infrastructure as a service, also known as IaaS in the industry. The big difference being is that we no longer manage those bottom four pieces of the stack. So that takes away networking, storage, servers, and virtualization. In the Azure world, Azure will manage all of those for us. We don't have to go and physically plug any cables in. We don't have to, rack storage arrays and servers, and we don't even have to maintain our own virtualization layer like you often would previously with VMware or Hyper-V. You do, however, in this model, still need to manage the operating system up the stack itself. But then there were other options that came along, notably platform as a service. This is the common one that's gaining traction in the industry. You hear the term PaaS when people talk about this one. And this takes away things like the operating system, middleware, and runtime from you. You still have to manage your applications and data that run on top of there. But now in many cases, and all platform as a service services differ slightly in what they offer, but perhaps you don't need the OS anymore and using web apps, which you'll hear about a little bit later on. Or perhaps, you've got a database service that's readily available to you. You don't need to manage the SQL engine or anything anymore. That's all managed for you by a database service. And finally, we have software as a service. This is fully managed. These are SaaS-based services, typically things like ServiceNow or other hosted services. Think of things like even Dropbox and things like that as well. These are completely hosted services for you. In some cases, you're still going to manage your application that runs on top of those, but you're not really supporting any of the plumbing at all, really. You're just kind of working and configuring the application. Then we've got things like Azure regions. And this is very important. Think of that traditional model. When we wanted to build a data center, it's a lot of work, right? We would have to typically put it in one location. Often it's the building that your company, is housed in. And, when you want to expand, it's very, very difficult because you'd have to go and build another entire data center, maybe somewhere else in the world. Well, Azure gives us over 50 regions worldwide. It's available in over 140 countries. And as you can see, there's a mixture there of available regions, announced regions, and some regions now have what they call availability zones. So this is a region, say, for example, in central US there, we see there's availability zones present. Well, the region is there, but there's actually individual data centers inside that region that you can choose to place your workloads into so you can get additional availability. But you can just see the global coverage. So if you want to deploy your application and have it closer to your customers, you can do that. If you've got data sovereignty rules that you need to adhere by, that also allows you to keep data perhaps in the country of origin much more easily. There's another concept as well that goes with this, which is region pairs. So when Microsoft Azure built the regions, they paired them up. So that way, when they patch them and do their maintenance, you can know that only one region in the region pair will be, susceptible to maintenance at a particular time. So just a good thing to know as well. But if you're choosing a second region, often a lot of customers have a primary region and they have a second region for failover. Well, knowing which one is paired is very, very important. One of the fundamental concepts you do need to know about are Azure resource groups, because Azure resource groups are where you put all of your different objects. They're essentially a container that you can put your web apps in, your virtual machines, databases, any service that you see us deploy in the course, we will often deploy in a resource group. The good thing is it's very easy to manage, but just be aware of this too. When you delete the resource group, every single thing in there is destroyed. It's helpful because it allows us to just take away all the components and associated components of applications that share the same lifecycle very easily, but you just need to be careful with it. And there are things like resource locks and things that you'll see throughout the course, so you know how you can use them wisely. Now let's take a look at some of the fundamental networking features you need to be aware of. Well, first of all, there's this fundamental concept of a VNet that you can see on screen right now. And within our VNet, we have subnets. This is the networks that we can ultimately connect our virtual machines to. So virtual machines will connect to a subnet, which has a subnet range, and that's what gives it its IP address. Much like, your home machine on your home network, it's an IP address from a subnet that you've defined in your home router. Same thing here, you can define multiple subnets out in Azure inside of your same VNet. So you essentially connecting it into the VNet, and more specifically choosing a range from that subnet. One thing to note is that VNets are isolated, so there's complete isolation between them unless you choose to connect them using some of the other things we'll talk about a little bit later on. In addition, you do have internet access available to you. By default, all the machines you put in the subnet can talk out to the internet unless you put any additional rules and things on top of there. And you can talk in, but you need a public IP address to be able to do that as well. In addition, you can put pretty much any of the Azure resources that you want into a VNet. And so when you connect, whether it's web apps or VMs or other services, there'll be specific options to connect them into the specific network that you want. So you can mix and match services in those virtual networks. And they can be a mixture of PaaS or IaaS services as well. In addition, you can connect VNets to other VNets. There's a concept known as VNet peering, as well as connectivity to on-premises using a variety of VPN gateway, express route, and other technologies that are available. Finally, you have something on there called a traffic filter. That's what the NSG is. There's certainly ways to do things like IDS, IPS, that's intrusion detection, intrusion prevention, for anyone not familiar with those terms. You can route traffic through to devices like Palo Alto and Checkpoint, or you can use this built-in traffic filter, which is an NSG, also known as a network security group, to restrict traffic. But as I said, you can also do routing as well. So there's default routing behavior. So by default, all those machines in subnet A, subnet B, they can all talk to each other. If we pair a VNet with another VNet, the VMs or services in that VNet can talk to the other one, but that's the default routing behavior. If we want to change it and redirect the routes, like I said, through like a Palo Alto or a Checkpoint or one of the other services out there, that's available to you as well. The other big thing to have a fundamental knowledge in are virtual machines. And we start off with our hardware platform on screen there. And think of your hardware just like the traditional way. We would have a CPU, we would have memory, we would have disk, and often when we're doing this on premises, we would have an operating system, so Windows or Linux, and then we would install our application. And that's the old way we did things. That's still the way when we have a machine at home. We have a physical machine with our hardware, CPU, memory, disk. We put our Windows machine or our Mac OS on top of it, and then we load all our applications on top of that. Well, virtual machines changed the game when that came along, because what happened was you still have CPU, memory, disk that goes into a set of hardware, but another layer was added in between called a hypervisor. So things on premises like VMware or Hyper-V were the common ones that were out there. And then on top of that, you would couple up your app and OS together into what is ultimately known as a virtual machine. And these are your VMs, and they allowed us to basically, oversubscribe those hosts, because often what would happen was you weren't using all of that CPU and memory on those machines. Every time an enterprise would stand up a new application, they'd buy a whole host of new hardware, but a lot of it went to waste. So by putting lots and lots of OSs and apps on the same set of CPU, memory, and disk, you were able to get a lot better consolidation and value for money and a return on your investment there. Now, in addition to the virtual machines and networking, which are really some of the core infrastructure things you need to know about, there's a number of app and DB services. These are the PaaS services we talked about earlier. And in particular, under app services, we've got something called web apps. This is a PaaS service that allows us to take applications that traditionally we might deploy on IIS, Internet Information Server, like ASP.NET applications, and run them directly on the PaaS service known as web apps without us having to manage that OS and install the IIS server, etc. In addition, there's mobile apps or mobile device backends. That's another service that can also run in the same app service environment, as well as serverless functions such as functions and logic apps. So both these are a little bit different. Azure Functions are really serverless pieces of code that you would write, and then they will execute on a compute node that Azure has available for you. So instead of you writing your code and then kind of deploying it all on a single virtual machine or operating system, this now you write the code and it just places it on a machine to run for you. In addition, you've got logic apps, very similar, but these are not really code heavy. These are more about connecting different services, on the internet or between different Azure services, and you'll hear more about those, like I said, throughout the course. The other big one, though, is containers, and more specifically, Azure Container Service, also known as AKS. Often, people call it Azure Kubernetes Service because it's predominantly now Kubernetes is the main standard that people are going for in the container world. And you'll hear more about this as well, but this allows us to couple up and deploy and essentially containerize applications. So this concept of build, ship, and run. So an app developer can build the application, build it into a container, ship it off to a container repository, and then run it on a container host when the time comes. In addition, we've got those database services. So we've got things like SQL. In particular, we've got Azure SQL in there, as well as SQL managed instances. These are currently in preview, so they're not covered specifically in the course. Neither is Azure SQL, but it's good to know that those are out there as well if you're going to be using Azure, because you don't necessarily have to spin up a VM and then deploy SQL on top of it. You've got this PaaS service available to you. In addition, there's Azure Database for PostgreSQL and Azure Database for MySQL or other hosted database services available as well. Finally, there's another one which is Cosmos DB, and this is a pretty interesting one because for global scale, and if you're trying to use things like MongoDB, you can run that on top of Cosmos and it can kind of scale out geographically. So again, not specifically covered in the course, but just know that it's out there as well. From a storage perspective, there's some other services that we need to talk about there. So if we look at storage, we've got blob storage. This is covered in detail in the course itself. And you just really need to know that a lot of people used to traditional file systems, whether it's on premises or Windows file shares, etc. And a blob store essentially is just a container of storage where we can store binary large objects. So these could be images, videos, things like that that we just want to keep out there. In addition, there's tables. There's files, that's your typical kind of file share, and there's messages as well that you can put up in Azure as part of their storage services. There's also a whole host of other services out there as well. So things like machine learning and AI, as well as things like cognitive services. So things like facial recognition, translation for speech, you can automatically do closed captioning and things like that. And we'll hopefully circle back and do a video on that sometime soon, because that's something we like to do for the course, is to actually, record the course. And then when we want to add the closed captioning, we can put it through something called Video Indexer, takes these videos, takes the audio, and turns it into, English closed captioning. And then I can choose to translate that. Results vary by language and how it translates, but pretty interesting services that are out there, as well as things like IoT as well. So IoT is around, devices that I might run, things like you might have your fridge might be connected to the internet. You might have cars connected to the internet. In the manufacturing community, this is very, very big right now, as well as things like farming and other things like that, where you can have devices out there that need to check in and send messages. And IoT, again also known as Internet of Things, is very powerful there. There's also services that are key, and these are covered predominantly in the course. Things like identity, so that's Azure Active Directory. You've probably already seen that by now. Even if you're using Amazon Web Services, a lot of people use Azure AD as their single identity source. It's a fully, managed identity platform for you, and has a whole host of security features in there, which brings me on to operations and security as well. And a lot of these are covered in the course. So these are things like log analytics for searching across all of your different services that you've connected into log analytics, security center for detecting threats in your environment. There's a whole host of services there, as well as monitoring, alerting, all the usual things that come with that as well. The big thing though, from an access point of view, predominantly throughout the course, we will be in the Azure portal, and we will also do a lot of demos in Azure PowerShell as well. But if we just go to the portal very quickly, it's this link, which is portal.azure.com. And if we select it, this will take us to the portal. Where you'll log in. Again, just make sure you have that trial account already set up, and you'll get a dashboard, typically when you log in, and it'll have a bunch of things on there, like, services you've deployed. There's help and support tabs. There's virtual machines, this one I built earlier, Skylines VM, but just get used to the portal for a little bit. So on the left-hand side, often you'll see we're going to this create a resource section on the top left. If we just want to see all services, we can click this, and then this will bring up all the services available in Azure, and we can filter them. We can search there. You can search right here in the filter. You can also search in this box at the top. This is actually where I go a lot of the time. I simply go straight up here, and if I'm looking for virtual machines, I'll type in virtual machines. Click that, and that will take me to the virtual machine section, where I've got my virtual machine running there right now, just one currently for this demo. But also on the left hand side, you'll see these favorites. So you've got things like, if you want to go back to your dashboard, you can click here. If you want to just see all of the resources running in your Azure subscription, you can click this, and you can see we've got a whole bunch of resources there. If I want to go to those resource groups I mentioned, I can click this, and I can see all different resource groups that I've got in my environment. And then if I want to delete something, I can go into that resource group, delete it, and it will delete all of those objects inside there. So if I go to Skylines Intro as an example, I can click this one. This is where I deployed that virtual machine. This is the resource group, and you can see it contains a whole bunch of things that got deployed along with the virtual machine. And if I want to delete that resource group, I would simply click delete resource group, and it would ask me to type in the resource group name, and then I click delete, and now it will delete that resource group and everything inside of it. Now there is no going back from that, so make sure you've got backups if this is something critical that you might need to get back later on. But for the purposes of the demos and things you go through, we typically create a new resource group for every single module, and then we just delete that resource group when we're done, and then that cleans everything up. In addition, we've got things like the app services I mentioned. So if you want to go in here and deploy those web app services, those are there. I showed you virtual machines from the top, but you can also get to it on the left-hand side. And same with things like virtual networks. They're already there along with storage accounts for you. And you can change this around. You can put your own things in there, but it just helps to get used to the portal itself and make sure you're familiar. In addition, you'll need to know about PowerShell. Now, there's a couple of ways you can do it, and you'll see a few examples throughout the course. In some cases, we will open up PowerShell on our machine, and you can do PowerShell on the Mac. You can do PowerShell on Windows. Just make sure you've installed the Azure commandlets that you need as well. But the easiest way to do it now is actually using Cloud Shell, which is on the top of the screen. There's this icon right here. If we click it, it actually opens up a Cloud Shell for us. And if we select on the left-hand side, we've got Bash there. We can change that to PowerShell. I'm going to click Restart. So I'm going to restart my Cloud Shell with PowerShell, and it's going to restart that. And this will actually open up a PowerShell client inside of the Azure portal for you, already logged in. So it's a much easier, to get in there and actually run your scripts just by using the built-in Cloud Shell. It's a new feature they added recently, and you definitely are expected to know about it for the 7533 exam. And you can see it's come up there. Now I can select PowerShell Windows. It'll ask you to create a storage account. This is where it's going to keep any file shares to persist files throughout. But if I go ahead and click Create Storage, and it will go ahead and now provision that Cloud Shell. Okay, and after a little while, probably 3 or 4 minutes, if this is the first time you're loading up PowerShell, that will connect in and get everything ready for you. And then you can simply go ahead and start running your PowerShell commands just like you would normally in your PowerShell client. Now that brings us to the end of this module, and hopefully you got a good overview of Azure, and it should definitely give you the fundamentals you need to get going, particularly for the certification and just Azure knowledge as a whole. In particular, you learned about the different cloud delivery models. So remember those IaaS models, PaaS models, SaaS models, and the differences there as one of the core infrastructure for Azure. So those are the regions, the VNets, virtual machines, resource groups. Those are key things to know. In addition, you learned about those other service offerings that are available to you in the Azure environment. And finally, we explored the Azure portal. As you get going with the course, make sure that you check out the Azure portal, get familiar with it, make sure you can open up a PowerShell client, whether that's via the Cloud Shell, just via your own one on your laptop, that's fine. Let's begin our journey now by looking at the Azure account hierarchy. And if you're in an enterprise, you will have something that is unique, which is an Azure enterprise agreement. And so you actually have an additional portal that people just maybe swipe in their credit card won't actually have. And that's the Azure Enterprise portal. And that's available at ea.azure.com. And in that portal, you can actually go in and create various departments and then go ahead and create sub-accounts inside of your enterprise. But for a lot of people, you actually start with just the account section. If you're sort of just trying out this course to learn Azure, you've probably used a free trial or you swiped your credit card, you will be at the account portal, which is at accounts.azure.com. And there's a billings and usage link on there, which takes you to the place where you set up your account in itself. And so you will go there to manage your account and your subscriptions underneath. Speaking of subscriptions, once you've created your subscription, you will then want to access the Azure portal to actually put resources inside of it. And you do that at portal.azure.com. So this might get a little bit confusing at first, but just remember, enterprise, we start at ea.azure.com. For my actual Azure account, where I'm going to put things in, I go to account.azure.com. And then for my actual subscriptions, once I've created my subscription in that account at account.azure.com, I go to portal.azure.com, which you'll see throughout all the demos is where we are when we're deploying resources. Following that, inside of subscriptions, I can deploy resource groups, which are essentially containers that I can put my resources in, and I can assign RBAC permissions to them, which you'll learn more about throughout the course. That's how we assign access. And finally, as I mentioned, in the resource group, we have our resources. So multiple layers there. They've also introduced the concept of management groups recently. That's not on the exam yet per se, but that allows you to sort of take your various subscriptions and group them together and group up policy, because what tends to happen in large organizations is as you build lots and lots of subscriptions and resource groups and you want to assign policy and make sure everybody gets the right rights in the various groups and subscriptions, it can get really confusing. So they have brought out management groups, which allows you to kind of group up subscriptions and assign the same permissions and policies to them as well. But for the most part, we'll definitely give you this document as one of the attachments in the course. So if you're just unsure where to go, these are the main links and should clear that up for you. If we go a little bit further and look at the account to subscription relationships, when we have our Azure Enterprise enrollment, we have one-to-many relationship with departments. So I can have many departments inside of my Azure EA, and I don't have to have any departments in there. It's just a way of organizing depending on the way your organization is set up. Within departments, then I can have one-to-many accounts, or I could just have one-to-many accounts to the enterprise enrollment to begin with if I didn't have departments. Following accounts, that's when I create my subscriptions themselves. And it always makes sense to have a plan for your subscription. So what you want to do is know when you're going to add a new subscription. Are you adding it because you have to completely separate out roles from a role-based access point of view? Or you add in subscriptions because perhaps you hit limits? Those are some of the reasons that you would add a new subscription. If we look at the enterprise hierarchy example in a little bit more detail, here's what it might look like. We have our enterprise enrollment. We have department A, B, and C. Maybe this is finance, HR, maybe IT is a general department as well inside of our EA. And then I can have sub-accounts. Maybe I have them for dev, for test, and then within there, I have various subscriptions that I want to manage and put resources in. If you want to see some common scenarios, it helps to look at the major three that Microsoft showcases. One is a functional example where you've got your enterprise at the top. We've got things like finance and IT as our functional departments there. And then we have account owners, and subscriptions in there you can see are based on projects, within those specific departments. So production websites, project one test, project one dev. If we look at something a little bit more business division orientated, so again, I've got departments, but I've got like auto and aerospace now as opposed to like very distinct finance and IT. So we've got business divisions within the enterprise that then perhaps my subscriptions below are based more on the applications themselves. And then another one that does come up a lot is actually geographic. We deal with a lot of global companies, and when we work with them, they have departments in North America, in Europe, in Asia, and then they'll typically separate out that way, then create accounts within there, and then the sub projects as the subscriptions within those accounts. We break down the EA type of accounts for a moment, and we look along the top. We have enterprise admin, department admin, account owner, and potentially a service admin as well. And if we look at the enterprise admin, they have the ability to add other admins, other enterprise admins, department admins, and account owners. They can add and edit departments, and they can add or associate accounts to the enrollment themselves. Can they add subscriptions? Well, no, but they could add themselves as an account owner, and that account owner could then create subscriptions. So if we just quickly move over to the account owner column, you can see there that they can add service admins. They can't add departments, so they're not part of that. They don't have the ability to organize the EA, but they can add subscriptions as you get further down. So again, the account owner can't add more accounts inside the enterprise agreement, but they can add subscriptions. The enterprise admin can create accounts, and they could technically make themselves an account owner, and then they could create subscriptions. But by default, you sort of have this delineation between enterprise admin and account, admin as well. Now, in between that, we can have that department admin. So if I'm using that model where I have departments, the enterprise admin could create some departments, and people in those departments could then create accounts, but only in their specific department. And so that's really, really key there. How much, access do you want to give out? How much, ability to create services do you want to give out to the departments? A lot of it is determined if you trust that department, if you think they have the ability to execute successfully in Azure, and hopefully they're taking training as well. But that's why they have these roles in place. All of them on the bottom, you can see, typically have the ability to view their usage and charges and view and remaining balances. Only the EA can really do that, because that's typically based off like an enterprise commitment that Microsoft sales team and the customer have made together. One of the key items you'll need to get going with Azure is an Azure account. And as you can probably tell by now from some of the previous lectures, there are a number of account options available to you. In this demonstration, we're going to focus on creating a simple trial account to get you going. So we'll start off in our web browser. Okay, and here we are in the web browser, and as you can see, I'm at azure.microsoft.com/en-us/free. You can also just Google that, Azure free account, and it will take you to this page. And the first thing you'll see is it says create your Azure free account today, get started with 12 months of free services. And if you scroll down, you'll see what you get with the free account, which is 12 months of services, but $200 of credit. So all the services that we use throughout the course, and if you're exploring with Azure, will cost a certain amount of money. That will get taken away from your $200 of credit, but some services are always free and they will always be available. So if you haven't already used a trial account, I encourage you to get one because it will save you a bit of money through the course. If you've already used one, then I'm afraid you're just going to have to, swipe the credit card and pay the small fees when you provision services in Azure. But hopefully this will get you underway if you haven't had a trial account yet. Now, if you go ahead and click Start Free, it will then prompt you to sign in with a Microsoft account. And at this point, simply log in with your Microsoft account if you already have one, or if you don't have one, go ahead and click Create One. Type in your email address. Type in a password. And you'll get a code sent to your email address, which you'll need to type in here. So simply refresh your email account, grab that code from there and punch it in here. And then decide if you want to receive the Microsoft promotional emails or not. Go ahead and click Next. And it'll ask you to just type in this prompt to make sure you are a person actually doing it and not a bot, as you've probably seen from other websites, and click Next again. At this point, it also asks you if you want to stay signed in. So this will reduce the number of times you're asked to sign in. This is very useful, otherwise you'll get prompted repeatedly as you sign into different Microsoft services. So click Yes for that. And then at this point, you can see Azure free account sign up, start with your $200 of credit. At this point also, if you already had a free account on that email address, it will take you to a screen to ask you to sign up for a pay-as-you-go and input your credit card details. But at this point, I'm just going to go ahead and continue typing in my information. And after you type in your phone number, you'll hit text me or call me, and it will send a verification code to you, which you also need to punch in here. That's just verifying your phone number. Okay, and then you'll need to enter a credit card for the account as well. So I'm just going to skim through this. And after you've entered the credit card information and click Next, it will then prompt you to accept the agreement. This is the subscription agreement, the offer details that surround the free offer that you're being given, and the privacy statement. So either read through all those, and then when you're done, go ahead and click the box here, and then click Sign Up. Okay, when all that's completed, you'll see you're ready to start with Azure, and you can go ahead and go to the portal. Okay, here we are. Welcome to Microsoft Azure. You can start the tour. That'll give you a tour around everything here, and we can choose maybe later if we don't want to do that now. And then on the top right, you can see this is the account that you've signed into, and it also prompts you to say, hey, you've got $200 of credit remaining. In fact, if we go to all services as well and choose subscriptions, so we can type in subscriptions, or you can just select it on the right here from the general menu. I would favorite this as well to the menu on the left-hand side. So you click the star, that favorites it for you because you'll go to subscriptions a lot throughout the course. Click subscriptions, and you will see in here your free trial that is available. You can click the free trial. And here you can see the subscription. It'll break down all of the different costs, etc. Your free credit expires in 30 days that we currently have here. If I click on Manage, this will then take you to the account page, which is a little bit different to the portal. So what you'll notice, if we click back to the free trial portal that we have here, this is portal.azure.com, and this other page it takes you to is account.azure.com. So the account section is where you'll do things like add payments, set up billing alerts and things like that. And you can see here the subscription status on this one, 30 days left, $200 in credits remaining, which basically aligns to that free trial as mentioned before. But then when we want to go ahead and execute on anything, we just go back to the free trial at this point over here. Now, if we want to give other people access to it as well, so we go down to Azure Active Directory, and you'll also see that you have different users available to you in here. There's only going to be one currently, so if I click users in the default directory, you'll see this is the default user that gets created when we created the subscription. Now I can create new users at this point. I can also create new guest users. So I can invite people with just their personal email address as well and give them access to our Active Directory that's created in here. Now you will see more of Azure Active Directory in future modules, but just know if you're looking to share this account with somebody else that you're studying with, this is where you would go to do that. And then if you go back to subscriptions again, so I'm going to scroll down, you'll see it's in the favorites now because we added it. If I click subscriptions and click this free trial subscription, if I want to give somebody access to this, you'll see the access control section here. So I click access control, and while I do have Azure Active Directory to create users, etc., I do need to assign rights to the subscription if I want somebody to be able to access it and have full administrative rights over it. So I can click add role assignment, and at this point I would select the role. And if I wanted them to be complete owner of the subscription, same as you have by default, you would click the owner role. If I want them to have a lot of rights but not be able to give access out to other people, I would choose the contributor role. And if I just wanted to give them read access rights, I would choose the reader role. Now there's a whole bunch of other role assignments as well. Those are also covered later on in the course, but for now, just know about these three. And if I click owner, what I would do then is assign access to either an Azure AD user, group, or service principal. And if I'd created that user from the Azure Active Directory section I just showed you, that user would appear here, and then I could basically assign them the access. But for right now, it's an empty account, so there's nothing to assign. It's only me, my email address that essentially is in there right now. And so with that, this concludes this demonstration, and hopefully we'll get you up and running, getting your trial account set up so you can continue on with the course. In this demonstration, we're now going to take a look at quotas, cost analysis, and tagging on our subscription. So let's head over to the Azure portal to begin. Okay, in the Azure portal, the very first thing to note is if we scroll down on the left-hand side, you'll see a section called Cost Analysis. Simply select that first. And on the right-hand side, you'll see here the option to go ahead and download a copy of this analysis, and it shows you below the total cost. Like, here's a summary, here's all the items. So you can see this is obviously a demo account, so there's only a few things in here that are generating cost. But on the right-hand side, you will note something called tags, and I can have up to 15 tags per resource or resource group in Azure, and tags allow us to really, drill down and identify and filter that bill more easily when I get it. But I can take this period of time and go ahead and download. So again, you can choose the time span, so past 30 days, current period, past 90 days, custom, period of time, but we'll just do, past 30 days for the moment. Hit apply. You can see the cost went up there because we're going 30 days back now. And now I'll go ahead and click download, and this will download an Excel or CSV file for me that I can then open up. And once it's opened up, you can see, in fact, I'll expand out some of these columns, and you'll see it'll list out the SKU, unique identifier that's being used, the SKU for specific virtual machines, any data transfer in and out that I might have used. But it's a pretty large, spreadsheet of stuff that you've done and when you've done it, etc. So if I scroll back to the top and I'll scroll over to the right, one of the key things I can do is filter on tags. So you can see this particular machine has an owner, it's got its total cost there for that machine, and these are all the sub costs associated with it. But I might have other resources. If I scroll all the way down, here's another one with owner Nick Collier. Scrolling further down, but you can see here like Cloud Shell, is an owner of that one because that's something that's useful when we do PowerShell in Azure. But the biggest problem you might find is if you don't start tagging early on, you will get a lot of resources like a storage account here that perhaps I don't know who actually owns it or what they're doing with it. So it's very, very important to build a tagging structure very, very early for your resources. Well, in the subsequent module here, what you'll see is an artifact we've created, which is a tagging spreadsheet. And essentially, because you're only allowed up to 15 tags, if I scroll down in the sheet, we'll see we've listed up to 12 tags here with room for 3 more, but you can obviously repurpose these as much as you want. But these are some examples of what I see in the industry that people need. Some clear examples are technical tags like environment. Is this dev stage prod? Do I have a maintenance window for my virtual machines? Am I doing some automation based on expiration date or a time window associated with services I deploy? These are common ones. We've divided them up into technical tags, automation tags, business tags, and security tags as well for things like data classification and regulatory compliance. Another really good one is cost center. If you have a cost center, the way your organization is structured, everybody's different, but if you have cost centers there, having that ID is a really good one to have. Then you can decide, are these tags mandatory or optional? And if they're mandatory, you could certainly, put some policy around them, which you'll hear more about shortly. But if they're optional, you could say, okay, this is something, people can choose to enter or not to enter, up to them, maybe some just optional description text, things like that. The next thing is to decide what format you want the tag in. Tags follow a key value pair situation by default. So you've got your tag name and then the value, which could be a string or could be JSON as well. We do a lot of automation around tags sometimes. So a time window, for a server to be shut off and turned on could just be a larger JSON syntax that you put in there. In addition, then decide things like who's responsible for it. Is it applied to the resource group? Is it applied to other resources? Again, you can apply tags to resource groups or individual resources wherever possible. If you've grouped everything together properly in a resource group, just assign it at the resource group. Don't go to the, the headache of tagging every individual nick and everything inside there. Ideally, you can just tag everything at the resource group, but I realize that doesn't work for everyone. And then is there any automation via Azure policy to perhaps enforce the tag? So we give you the spreadsheet as part of the course. I would say first thing is just, get in a room with the people you need to, plan out your tagging strategy, and then that will help you immensely when it comes to getting your bill. So going back to the portal, here is, again, the tags, and you can kind of see them here. They would show up, when you kind of download that bill. If we scroll further down now, the other thing you need to be aware of is usage and quotas for the exam. And this is important because by default, when you create a new account, various things are limited. So, total regional vCPUs is limited, what type of vCPUs from which families you can deploy, how many virtual machines is your maximum. You've got 10,000 there, but you'll be capped by the vCPUs. Now, if you want to increase any of these quotas, all you need to do is simply select request increase, and this will require you to put in a support ticket, and depending on your support level will determine the response you get to that. But you'll basically choose the subscription you want to increase, choose the quota type, so perhaps compute services, a pretty common one, choose your support plan, as I mentioned, basic support, and then just kind of type in your problem as you kind of go through here. So I can choose East US 2, SKU family, I can choose, okay, I want the A series as an example, and I can say, okay, my current limit is 10, I want a new limit of 20, I can save and continue. I don't need to upload a file with additional details, but I could if I wanted to. And then if there's severity, at the top here, minimal impact, moderate, critical, will also determine, how quickly, Microsoft responds to that. On the next page, I'm not going to go any further than this, but you'll simply enter your contact details so they know who to contact. They'll send you an email, and you will converse with a support engineer from Microsoft to get the quota increased. So that's kind of usage and quotas for you there. Finally, the last thing to bring up here is naming standards as well, because we talked about tagging a lot. So let's take a look at another spreadsheet that we give you, which is naming standards. And this has, all the different categories like resource group, compute, storage, etc., and the different naming standards associated with them. So you can see like some of them have different length limitations. There's different patterns for actually filling them out that we recommend. So you might use like your company identifier, the region it's in, the environment, the team, the purpose. Really up to you how you come up with these patterns, but these are just examples for you. So you'll typically come up with your company identifier. You'll come up with like 3-letter acronyms for your server roles. Like some people use like SQL at the end for SQL, app, web, you decide, what you want to call it. And then you kind of whatever little, additional pieces you want to put there so that, every time somebody builds something, they're following, a standard naming convention there as well. And with that, that concludes this demonstration and should get you up and running with quotas, cost analysis, and tagging for the exam. One of the items that Microsoft expects you to know about around subscriptions is billing alerts, and to access these, we'll head over to the Azure portal and then over to the account screen. Okay, so here I am back in my Azure portal, and the first thing I'll do is go over to my subscriptions, which I can access from services, or if you favorited it in the previous demo where we walked through a trial subscription, simply click subscriptions at the bottom in your favorites panel. Click our subscription. In my case right now I'm on the free trial subscription, so I'll select that one. And then I'll go ahead and click manage, which will take me to the account screen now. Okay, and once I'm in my account screen, you can see I've got my subscription status as we discussed when you created the free trial. But if I go ahead and click preview features, and you'll see an option for the billing alert service. Now right now it is a preview feature, so by the time you take the exam it may just no longer be in preview and be a standard service, but they do call it out as a preview feature currently. The billing alert service, if you want to activate it, you simply have to click try it now, and that enables the preview service for you. So we'll go ahead and select that, and that turns it on for us, and it takes a few minutes sometimes for this to activate. After a short while, you'll see that that is activated and it says you are active. So at this point, if we refresh and go back to subscriptions, we should now be able to enable billing alerts on our specific subscription. So there is our free trial subscription if we select it. And now on the top under summary for free trial, you see it says overview, billing history. Well, we also have alerts, which is that preview feature that we activated. And if we click alerts, it takes us in there and you can see that we can add up to 5 alerts. If we click Add Alert, the alert screen will pop up. We can give a name to our first alert. So we'll say, this is when we've spent, say, $10. And this is an alert for the bill in total. You'll see there's other alert options we can do as well, such as monetary credits. So if you've got a credit from, say, a MSDN subscription, you could select this one, and when you hit a certain amount remaining, it can alert you. But otherwise, we'll simply select the bill in total. You choose the amount spent, so when the bill in total hits $10, we can send it to an email recipient, and that is basically all there is to it. If you want another recipient, you can add an extra one there, but we simply click save, and all that's going to happen is when we hit that $10 bill in total for the month, it will send us a billing alert via email to let us know. And if you want to see if the alert's sent, you can come back here and you can go to your summary section again of your subscription, and if you look under alerts, you'll see if we expand this out, this is the specific alert. We can edit it if we want, and we can see that it hasn't sent a notification, and that's because we just haven't provisioned anything yet in the subscription. But if we exceeded the $10, then it would send that out to us. Now if we say we're done with this alert and we don't want to keep getting alerted for the $10 spend, we'll simply click delete, and this will clear it out for us, and we no longer have that billing alert. But that's one of the key ways where you can just get notified in the event that a certain amount of spend is exceeded. In this demonstration, we're now going to shift our attention to subscription policies, which is a mechanism to control what people can do inside of your subscription. So to begin, we're going to head over to the Azure portal. Okay, and here I'm in the Azure portal, and one of the things to note, first of all, in the previous demonstrations, I was using a trial account to kind of show you everything. At this point, I have shifted over to one of my other accounts, so don't worry, everything will still proceed as normal, but you will see from time to time that I'm in different Azure accounts as I'm trying to demo things, but nothing to be alarmed at. You should be able to do everything you want to do in your current account. To begin, though, I'm going to go over to subscriptions, just like you saw when you created your trial account, but in my case right now, I've got Visual Studio Enterprise, and in some other demos, you'll see I have other subscriptions as well. But for right now, I'm going to use my Visual Studio Enterprise account, and I'm going to go in here, and if we scroll down on the left hand side, you'll see a section called policies, and this is where we want to focus this demonstration on. If we click policies on the right hand side, you'll see that currently everything is 100% in compliance, and that's ultimately because I don't have a lot of policies and a lot of resources right now in the subscription. But the key thing at the top here is you can see that I can assign policies. So if I click this box, assign policy, it will prompt me in the next screen to choose my scope. So this is where do I want to assign the policy. In my case, I just want to choose the subscription. I don't need to exclude any specific resources from this assignment. So I'm saying everything in this subscription called Visual Studio Enterprise, I want to apply policy to. Well, again, what is our policy? And this is where you create a definition for your policy, or you use one that's already built in. So you can click the little box to the right, and this will open up all the different policy definitions. In fact, there's 144 right now available to you. You can create these as JSON templates and put them in here as well. This is where Microsoft has massively expanded policies because they've taken all the best practices from lots of enterprises out there. But in your case, let's look at a few of these real quickly. Well, what if I wanted to set a policy on deploy log analytics agent for Linux VMs, making sure that, it's a Well, let's look at a few of these very quickly. If we scroll down, you'll see things like audit VMs that do not use managed disk, something you'll find out about in the virtual machine section, making sure you have log analytics agents for your Windows and Linux VMs, and so on and so on. Things like disk encryption are in here as well for storage accounts, and audit transparent data encryption status for PaaS services like SQL databases. These are all good examples. But if I go back to the top of this and search, if I filter, with built-in, and then choose allowed, you can see a number of policy definitions that are actually quite common. Things like not allowed resource types, allowed storage account SKUs, allowed resource types, and these two are really popular, allowed virtual machine SKUs and allowed locations. So I can say, for example, I only want to allow specific virtual machine SKUs. I don't want to perhaps allow very, very large virtual machines because they could be very costly. So I can choose here, allowed virtual machine SKUs, and click select. The policy definition is filled in. You can see the assignment name, allowed virtual machine SKUs. You can change that if you want to. And if I scroll further down, I can see the description, assigned by, and here is where I put in the parameters for that policy template. So right now, 0 is selected. If I click the drop down, I can now choose the virtual machine SKUs that I want to allow in the subscription. So I could choose, just the basic A0, A1, whatever I want. Maybe I want to choose all the D series. Again, you'll learn more about these in virtual machine section if you haven't already jumped ahead and covered that. But I could choose, D series, which are common, A series, etc. So just go ahead and select the ones that you would want to allow. I can choose also to use a managed identity, which you'll learn more about in the identity section later on as well. But with that, if I'm happy with everything there, I can go ahead and click assign. And now that creates that policy, and now it will only allow me to deploy machines in the subscription that match that specific SKU type. And you'll see later on when you build virtual machines, if I tried to then go and build a virtual machine that was perhaps, an F series or G series, it would simply error out during the build process. And if I wanted to fix it, I would need to go back in here to this allowed virtual machines policy and basically delete that assignment if I wanted to get rid of it, or edit it if I want to just add additional SKU types. Now, this is very important because in the enterprise, you probably want to start off with a certain amount of SKUs that you allow, particularly if you're early on in your Azure journey. Again, maybe the A series, D series, etc. And then as needed, you might allow certain teams access to those very, very large, perhaps the M series giant memory virtual machines. You could then allow them access to them by assigning a policy that allowed them access to them. Perhaps you assign that policy to a specific resource group. Perhaps you don't assign it to a whole subscription. So you get kind of creative as you work through these. The last thing to mention, which isn't strictly covered on the exam scope yet, is the concept of management groups. And all that means is you can take policies that you've assigned to different subscriptions, and instead of going to every single subscription and creating the policy and assigning it, you can essentially assign it to a management group that contains multiple subscriptions. So if you said, okay, I've got 100 subscriptions across my enterprise, and I want the same policy applied, I would then go ahead and use a management group for that and assign the policy that way. So that's future discussion, but just something you need to be aware of as well. And with that, this concludes this demonstration. I highly encourage you to go in here and play with these and then try to provision things against the rules that you have. But just make sure if you don't need that permanently, go ahead here and delete that assignment. Otherwise, you'll run into various problems later on. In order to get started with monitoring for Azure, it helps to understand the way Microsoft looks at monitoring overall. And first of all, we've got monitor and visualize metrics. So this is really two things in itself. One are the metrics themselves that you can get based off things like CPU, disk, all the different services in Azure, and then the visualizations on top of those. So you'll see when we do some demos and we go into the metrics view that you can actually look at metrics and visualize them and see them on charts and things. If you're coming from a VMware background, this is very similar to what you would see in vCenter in, say, your performance tab. The next thing you've got is query and analyze logs. So one of the big features they offer in addition to Azure Monitor is a log analytics. And we have a pretty large section just on log analytics a little bit later on, which shows you how to query and analyze logs and data that's coming in. That could be a mixture of metrics or log data from a variety of sources. And not only can we just, pull the results of those queries, but we can actually visualize on those queries as well if we want to. And then the final one is set up an alert on action. So kind of the first two are more around kind of analyzing the environment, seeing what's going on, troubleshooting performance, etc. The last one is really around, okay, I know the things I want to look at, but how do I actually take action upon them? And so you'll see the concept of action groups and then tying those action groups to various alarms and triggers that go off in the environment. So with that, that's kind of the brief overview. So just always think about it in terms of these three categories, but we'll show you in the subsequent demos how you can go about configuring all of them. In this demonstration, we are now going to take a look at Azure Monitor and Azure Alerts from the Azure portal. And in the portal, there are a couple of ways to access monitoring. First of all, we can access it from our favorites by clicking Monitor on the left, which is there by default. If you don't have it there, simply click All Services. Go ahead and type in Monitor, and that will bring up Azure Monitor for you. So you can click into it here. And while we're in this area, you'll see Monitor and Visualize Metrics, query and analyze logs, set up alert and actions, much like we covered in the previous lecture. But before we dive into it from this point of view, it's also worth noting that if I want to get at it from a specific object, perhaps I've got a virtual machine already built and I just want to look at metrics of that VM without having to go through the monitoring view, I can go over to my virtual machines, select my VM. In my case, I've got a VM that's pre-built here, so VM01. And on the left-hand side, if I scroll down, you'll see monitoring, and we've got alerts, metrics, etc. here as well. So there's a couple of places to get to it, directly from monitor or directly from the object itself. But we will start in monitor first of all. So we'll click monitor, and on the right hand side, let's go ahead and explore metrics first of all, and opens up the metrics pane. Now sometimes it's a little hard to see here in the dark scheme, so you can go to your settings and just change it to a lighter scheme inside of Azure, whatever your preference is. But once we've got that up, now what I need to do is choose the subscription I want to pull my metric from. So in my case, I've just got the one subscription, my Visual Studio Enterprise one in this demonstration, so that's what I'm going to pull my metrics from. I need to choose a resource group, so I'm going to choose the one that my virtual machine is in, which is AZ-demo. I could select all if I wanted to. And then the resource types that I want to pull from as well. So I could narrow this down and choose specific services I care about. Perhaps I just want to look at virtual machines. But in my case, again, the subscription I'm looking at, I don't have much I need to filter on. So I'm going to go ahead and just select everything there and then select our virtual machine, which is right here on the bottom, VM01. And then this will pull up the metrics for that specific object. So in my case, I've got a few things here: CPU credits consumed and remaining. That's specific to B series VMs. So nothing you need to worry about too much right here. But then I've got other metrics like data disk, reads, writes. If I go down, I've got network in and out. I've got queues. I've got a very common one that we want to look at, which is percentage CPU. So I can choose CPU percentage, and you can see already, 0.26%. This VM isn't really doing much. You can see it along the bar here, what it predicted it did in the past, and then what it's doing right now in the solid blue bar on the right. Now I can zoom in a little bit there by saying I don't want to look at the last 24 hours. Well, I just powered this machine on. That's why it's kind of predicting and showing that blue dotted line there, because it doesn't really have history for that area. So I can go and select the last 30 minutes. And then we'll start to see something that makes a little bit more sense, like a virtual machine that's just been powered on. It's still got very low CPU utilization. I can go back in and click this VM% CPU. I can also change the aggregation, so I don't have to just look at the average. I can look at the min, I can look at the max. These are all options available to you. So you can choose how you want to, display that information. You can also choose if you want it to be in a line chart, if you want it to be in, say, a bar chart, so you can just look at the CPU over time. Depending on how you're troubleshooting, perhaps you're in a war room scenario, this is where you can sort of get, different views of that data and present it differently. Now, perhaps I want to put this on my dashboard. Perhaps I really care about CPU on this VM. This is something I'm looking at a lot. Well, I can click pin to dashboard, and I can pin to the current dashboard or select another dashboard. I'm just going to pin it to the current one, and then I'm going to go ahead and click pin to dashboard. I could also click dashboard on the left-hand side here, but this is a shortcut. I just click pin to dashboard, and then here is my dashboard. Again, I can create new dashboards if I want to, but if I scroll to the right-hand side, here is that widget that's now on my dashboard. And if I want to, I can edit this dashboard as well. So I can move this guy around. So I can move him under, this section. I can move this around. It's really just a canvas for you to, ultimately play with and put whatever monitors you care about on there. To create new dashboards, I click this plus sign. That creates my new dashboard, and I can also upload and download dashboards as well, which is really handy for sharing things between colleagues. But that's basically, the dashboard created there. I've got my metric, my CPU metric that I've got there, all very well and good. But what happens if I want to see a little bit more? Well, let's go back over to the virtual machine itself and select VM01. I don't really want to go through monitor every single time, so I'm going to scroll down on the left-hand side here, and I can check metrics directly from in here, and you can see source is already filled in, the namespace already filled in, and I just choose my metric there. Well, going back even further, if I scroll to the top of this area and select the overview for my virtual machine, and this is the same for a lot of other Azure services as well, and I scroll down on the right-hand side, Microsoft has created pre-canned widgets for you associated with the object that it thinks you might want to look at. So, the CPU average, that's the one we just created manually, that's available there. If I want to look at network throughput, that's available to me on the right, and same with disk operations as well. So all of these are available there. And again, if I want it on my dashboard, let's say I want this network one, I can simply click the pin option, and that pins it directly to the dashboard for me as well. Now, what if I want to start alerting on things like that? Well, again, we'll go to the monitoring view. So we'll select monitor, and we'll go in this time and click create alert. So slightly different screen here. What we need to do is create rules first of all. So if I want to create a rule for that virtual machine, perhaps when the CPU exceeds 90%, I will select that resource. So this is the resource I want to monitor first of all. I select to filter, so I can filter on virtual machines. I choose VM01, and I click done. So right now, that is my object that I care about right now. The condition is what do I want to signal on, basically. What signal do I want to alert on? So in my case, it's got some suggested ones for us. I want to choose percent CPU, and then I can choose to show the history over a longer period of time if I want to. Right now, it's just showing the last 6 hours. And if I scroll down, so there's the metric graph, much like we saw if we created the metric monitor that we saw previously. But here is the alert condition. So the condition greater than the time aggregation, same options there as well. So we've got average, maximum, minimum, total for CPU. So I can average it out and say, okay, anytime it goes over 90%, so whenever the CPU is greater than 90% over the last 5 minutes and check every 1 minute, that's what I want to take an action on basically. So now if I scroll further down and look at action groups, this is what I want to do with that alert. So let's say the alert is fired. Who do I want to notify? What do I want to do? And so I have to create an action group if I haven't got one already. If I already had an action group, I could select an existing one, but I'll create a new one for right now. And give it an action group name. Perhaps I want to email IT team as an example. And I'll just call this one email IT. And here I'm basically going to choose my resource group where I want to basically keep this action group. So I can choose to keep it in my default activity log alerts, which it will create for me. And then I need to choose the action. So let's say again, we want to email as our first action and choose the action type. And these are really important. And you can see there are a number of them here. So we've got email, SMS, push, voice. So if I select this one, this is where I would come in here and choose, okay, I want to email help@helpdesk.com, just a fake email I'm putting in there right now. I can choose to text message somebody, etc. All of those options are available there, and I'm just going to choose email for right now. But I could also go in and do other things. Let's say I wanted to cut a ServiceNow ticket. I want an incident ticket because this is a really important, alert for me. I want to make sure that we log that in our ITIL system. And so I would choose to use the ITSM connector in this example. And then I would go ahead and use my ITSM connection that I would have created separately as part of a ServiceNow, say, integration. So that's another option there. In addition, you also have the option of automation runbooks. And these are key. I often see a lot of people starting to use these now, where you can choose to run a runbook that you already have. And there's some already created for you now. So you've got restart VM, stop VM, scale up, scale down, remove VM. So, perhaps in this particular virtual machine by itself, I've hit the CPU alarm. I want to change it to a higher instance with more CPU. I could do that as well. So there's a lot of options here, in terms of the action group, not just send the email, but I could add multiple actions. I could email somebody, I could create a ticket, and I could say restart the VM if I wanted to as well. All of these things, you need to decide what you want to do based on your specific scenario, but lots of options available to you. In my case, I'm just going to choose the email option. So I'm going to click OK there. It's going to create that new resource group where it'll put those activity log alerts, and then we'll create that for you. Then I just need to give the alert rule name. So I can say, CPU over 90%. So I've got my group. In fact, I need to go back and select that group, which created it, but I haven't selected it yet. So now I've got the group selected, CPU over 90%. And got the percent in there, so CPU over 90 we'll call it, can't have that character in there, and choose a description for the alert. So the CPU went over 90%, help, whatever you want to put in the description for the incident. Obviously you'd be more professional in an enterprise scenario. Then you choose the severity. So this is, how important it is to you. If it's a Sev 0, it's normally mission critical. If it's a Sev 4, perhaps it's not that critical for you. And once you've got all that created, go ahead and enable the rule upon creation and create alert rule. This will take a little bit of time. It's essentially going to continuously monitor that virtual machine. Anytime that metric is exceeded, it will fire off that email, and you can see it's actually already completed for that specific one. Others do take a little bit more time. And with that, that concludes alerting and metrics. The final thing we just need to cover is something called diagnostic login. So if we go into virtual machines again, click VM01, and we scroll down to monitoring and choose diagnostic settings. If we look in here, you can see that Azure Monitoring collects host level metrics by default, so CPU, disk, network. But what it doesn't show us is guest level metrics. So these are the metrics. If you open up your Windows laptop and go to the performance monitor, or on a Windows server, you've got, application logs, you've got performance logs for your CPU that Windows is detecting, the Windows operating system. The host level metrics are what Azure sees from the hypervisor. The guest level metrics are what the operating system itself sees. So we can choose to enable these guest level monitoring metrics as well. You'll pick a storage account. There's probably one already created when you created your virtual machine. You may want to centralize all of the storage account login for guest level metrics. That's a decision you will need to make as part of a wider strategy for monitoring. But for right now, I'm going to select enable guest level monitoring. And what that does, it updates the settings for that specific VM so it can start to gather additional data from the virtual machine and report those logs in as well. And what will happen is you will get additional metrics once this piece completes. So when you go into the metrics section, when you scroll through here, you will see not just the host metrics, but also the guest level metrics as well. And you can start to choose if you just want to see what Azure's reporting or what the system is reporting as well. And with that, this concludes this demonstration. This hopefully gives you a great base in terms of monitoring. What you definitely need to know for the exam is how the metrics work, what are some of the options. So you can do averages, min, max, etc. How you can adjust, your time period to look at, and then make sure you know how action groups work. You probably get some questions around action groups and what's happening, maybe perhaps in a screenshot. You might need to know that it's sending an email or it's going to go over to the ITSM connector. All those things are, really important for you. But with that, this concludes this demonstration. In this demonstration, we're now going to show you how you can configure storage account login for your storage accounts, as well as look at some of the metrics and things that you can view in your dashboards. So to begin with, let's go straight over to the Azure portal. And in the portal, we can now see that we're in our storage account, SL SAS demo, and let's scroll down on the left-hand side, and you'll get to a section at the bottom called monitoring, and in there are two things, alert rules and diagnostics. So let's first of all go ahead and select diagnostics. And this is where you configure all the different diagnostic logins. So it's currently on by default, but it's just recording hourly metrics, and it includes API metrics, and it'll delete the data after 7 days. So I'm going to add a few things. We're going to enable minute metrics, and we're also going to say, okay, I want to turn on login for read, for write, for delete. We're going to turn everything on for blob storage. If you scroll back up, you can see you also have the option for the different storage services. So file, you've got the same options there. For table, same thing. And finally for queue properties as well. But once you have them the way you want them, go ahead and select save. Now that's saved successfully, let's go over and look at a few metrics. I've actually uploaded already a whole bunch of images to the blob server. So if we scroll back up on the left-hand side, notice that metrics comes under the specific service we want to look at metrics on. So you've got metrics under file, queue, etc. But if we select blob service metrics, and immediately I can see there should be a whole bunch of requests here. So we've got 3.83 requests, total egress, average latency, etc. So these are a whole bunch of metrics that we have that we can immediately, if we want to, publish to our dashboard. So we can go ahead and select this little pin. It's pinned to dashboard. We can select egress, pin that to our dashboard. And now if we simply select dashboard, scroll to the right, and we should see, we've got a whole bunch of VMs and things I was doing earlier, but these widgets are already here for us. We can create our own custom dashboards, move them around, but everything is there for you. And that's pretty much it from enabling monitoring and metrics. The other thing we can also do is go ahead and create some alerts. So if we go back to our storage account, select SAS demo, scroll back to the bottom down there, and we've got alert rules as well. So in this section, we can go ahead and add alerts, give it a name, and select the resource. So in this case, it's going to be on the blob storage for SAS demo, so we could choose file, queue, or table, but give it a name. So we'll call this, high requests, and we could give it a description saying this is for high requests, but then you can go ahead and select your metric and choose what it might be that you're looking for. So if we scroll down, we should see total requests, and there we go. And we could say, look, if the requests, you can already see them there, if it's greater than, say, 10 over a period of 5 minutes, send an email, and then I can drop my email in there. Or if we want to, we can directly send it to a webhook. So that could be to a automation runbook or another REST interface if we wanted to as well. And that pretty much wraps it up for monitoring alerts. As you can see, it's pretty easy. There's a whole bunch of metrics you can filter on if you want to, but that's pretty much where you would configure the settings and should get you through the exam just fine. To get started, let's take a look at some of the key features of Log Analytics. Well, the first one is that it plays the central role in monitoring. So it's not necessarily the tool that is doing all the metrics and performance data gathering. That's typically done on other systems, maybe the Azure PaaS services, maybe your Windows event logs, things like that. But everything is funneled into Log Analytics, and it's a central role that it plays in bringing all of this data together. The next thing is data sources, and we've also got other log analytics sources which we combine when we talk about this. And data sources are things you can connect log analytics to. So these could be virtual machines that you want to plug in and get data on. These could be system log events, Windows log events, performance events, etc. And then you've also got other log analytics sources, so things like Security Center and App Insights, which use their own sort of log analytics under the covers as well. And so these are two sets of sources that you can use, whether you're manually saying, hey, I want to get data from this machine, or I want to ingest data from other log analytics sources native to Azure. Then we've got the concept of search queries, which you'll see a lot of in the demonstration. So again, I encourage you to check that out because this will talk everything through. But once you've got all that data in there, we do queries on it to then output the data. And there's a variety of output options available to us, as you'll see. In fact, if we look at the log search use cases, and if we look on the left-hand side, first of all, we've got things like Azure Monitor, Virtual Machines, Operations Manager, that's SCOM if you're using that on-premises. That's System Center Operations Manager is what that stands for. You've got Application Insights, Azure Security Center, PowerShell, Data Collector, all these different sources of data that come in. The incoming data is automatically indexed, data types and tables are automatically created, and then the data is available for log search in and smart analytics to multiple channels. And those channels you see on the right-hand side. So we can design and test queries in the log analytics engine. We can visualize data in the Azure portal. We can send a log analytics search query and design it so that it triggers a logic app, or perhaps sends an alert, or perhaps, goes to Power BI and we've got a whole visualization there. So you can kind of see the role it's starting to play. It's kind of that middle piece that we have here, and it brings all of this together. If we look then at the architecture, on the left-hand side, kind of expand upon that, we have our data sources. We also have the concept of solutions. So solutions are third-party solutions that you can plug into Log Analytics. In fact, it's kind of a marketplace for them, where you can go in and say, add things like Network Watcher and other services that are out there. And then all that data comes in, it creates these records, and then you perform your log searches against these records and then say, okay, I want to alert on that. I want a dashboard for that log search. I want Power BI, etc. In fact, if we go a little bit further and we look at things like the data sources and break them out, you've got logs and performance there, plus those third-party solutions. And you can see that data comes in and creates those records, but they're in a series of tables. In fact, if you look at it again, another layer deeper, and we say, look, Windows event log comes in, it goes into the event log table. Syslog goes into syslog. Agents might go into heartbeat if it's something where we're just checking if something's online or not, like up-down type alerting. Custom logs, alert rules. You can see they've got all these tables there. And what you will notice, and this will be expanded upon when you go through the demonstration, but you've got this concept in the query. You see where it says event and then union syslog. So you can query across multiple tables. And again, that'll become more important a little bit later on, but worth noting for right now. If we look at those data sources, this is a summary of the ones that are available to you. So you've got the concept of custom logs, first of all. Those are text files on Windows or Linux agents containing log information, and they go in the event type log name _CL. We've got Windows event logs, which are event type event, Windows performance counters, which are under perf, Linux performance counters, also under perf, IIS logs, which are W3C, IIS log, and syslog, which are under syslog, which are syslog events on Windows or Linux computers. The last thing we'll leave you with in this lecture are some search query fundamentals, which I encourage you to write down or just make sure you've committed these to memory, as they will help you tremendously when you're getting started with log analytics. To begin with, start with the source table that you're focused on. So if you're focused on event logs, let's start with the event table. Then follow on with a series of operators. So perhaps I am doing a query where I want events on a specific computer. That would be my first operator to set the condition to be that computer. Then perhaps I want a specific event ID on that computer. I use pipe to separate out additional operations. So now I'm starting to narrow down my search in particular for that event table. But now if I want to join other tables and workspaces, I just need to use that union command that I showed you in the example earlier, and then I can search across multiple tables. So perhaps I'm looking at errors in IIS on systems that are showing a high CPU performance metric. So the performance metric will come from the perf table. The application insights table will provide perhaps my transaction times for my users that are accessing my website. But I can combine these using unions, so I can get a query that says, okay, when the transactions hit a certain threshold and the CPU is this high, I've got a correlation here that I can work with. And with that, this concludes this lecture series, and hopefully this gives you the fundamentals you need. There's definitely questions starting to appear for log analytics on the exam, so definitely make sure you know how to query around, especially as you hit the upcoming demonstration. In this demonstration, it's now time for us to get our hands on log analytics, and we'll go through a number of steps in this process. First of all, we're going to take a look at analyzing data using search queries. Then we'll look at visualizing data using the various dashboards, and finally look at how you can potentially create alerts based on some of those queries. So to get started, let's head over to the Azure portal. Okay, and in the Azure portal, the first thing we need to do is go ahead and create our new log analytics workspace. So let's click Create a Resource. In the search box, type Log Analytics. Select it, and go ahead and select Create. This now gives us the blade for creating our new workspace. So go ahead and give it a name. Choose your subscription, along with a resource group to put that workspace in. In my case, I'm going to use SL-operations and choose a location. You will notice that there's not a lot of locations here for the US. Primarily, you'll just use East US. There are Canada, UK, etc., other regions there if needed. Go ahead and choose your pricing tier, and just note, you've got three options. You've got the free tier, the per node OMS licensing, and per gigabyte standalone. The free tier will be enough for any demos you try to do yourself here, as this allows up to 500 gig free to get started with OMS. So select the free tier and click OK, and click OK again, and that will now begin provisioning our workspace. And this is basically where all of our data is going to go into from all the different data sources that we connect in. It's also where we're going to create our dashboards and queries and everything else there as well. So we'll fast forward as this completes. It usually takes about 3 to 4 minutes for it to completely provision the workspace. All right, and we can see that our deployment succeeded. We can go ahead and select that and this should take us directly to our log analytics page, and then we can go ahead and select our workspace, which you'll see in the bottom. Okay, and now we're in our log analytics workspace, and a couple of things to note. So first of all, in the middle of the screen, you've got this management section. So we've got overview, which we'll see later on, kind of gives you an overview dashboard, log search, which is going to be where we primarily spend a lot of our time, the OMS portal, and the view designer as well for designing various views. But before we can actually make any use of this, we do need to configure some data sources. So on the left-hand side, let's scroll down all the way down to data sources. And you can see there that we have virtual machines, storage account logs, Azure activity log, etc. Let's start by just configuring a couple of virtual machines to be data sources for this workspace. So we select virtual machines. You'll see we have a couple of virtual machines there. And you'll notice that I've got Linux VM01, Windows VM01. They are not connected to any workspace. But if I look at SLBC01, that was previously connected to another log analytics workspace. And if I want to, I can go into this one, disconnect it from the previous workspace. That'll take a moment, and when that's complete, I can then connect it to this workspace so the logs start to come into this log analytics workspace. Now do note, it is possible that we can query across workspaces if we want to, but this is the primary workspace the data is going to be a source for. If we go back to the virtual machines though, and go ahead and select Linux VM01, I simply go in here, you can see this one isn't connected at all, go ahead and click connect, and that will begin installing the agent on that machine and connecting it to this workspace. At the same time, let's go over to the Windows virtual machine, select this one and connect it in as well, and that will begin installing the agent on that machine. It is also possible to automatically install these agents, these monitoring agents. You go into Azure Security Center and it's a policy you can set there, as you may have seen if you watched the security module previously as well. So while that's going on, let's go back over to our Skylines workspace and let's scroll down again and let's add a few more data sources. So if we go to the Azure activity log, this is all our Azure activity, you know, when we're giving people rights, when anybody's doing operations in Azure. Same thing, I can select my subscription and decide, okay, all the activity logs for Skyline's primary subscription, I want to connect to this data source as well. You can see that happens pretty much instantaneously. If we go back again and scroll up now, we've got enough data sources. We do need to decide what we actually want to capture. So if we go to advanced settings and then go into data, you can see that we have Windows event logs. So for example, these pretty much correspond to the Windows event logs in Windows. So if I type in system, and click that, and we can go ahead and add that. By the same token, if I wanted the application logs from Windows, I could type application, add those in, and let's add some Windows performance counters as well. So let's go in there, and it's got the defaults already available for you there. All you have to do is just choose which ones you want, or just select this box, and that will add all of them. So that means all the performance data for reads, writes, CPU processor time, all of that will now be sent to Log Analytics. Okay, and lastly, let's go ahead and save that. And that's confirmed as saved. And then we'll fast forward here while we just wait for those agents to install, and then we can go through some of the queries. Alright, so a couple of those Windows machines now have their agents installed and are connected to the workspace. So I'm going to go ahead and show you a couple of log searches that you can use. So go ahead and select log search. And first thing to note is you do have an option. You can do your log searches straight away in this section of the portal, or you can click analytics, which I'll go ahead and select. This opens up a new portal for you and allows you to do multi-line queries, more advanced. There's a lot more you can do in this section. It gives you a lot more details on functions, all the different categories that you can choose from, all the different fields and tables basically that are in the log analytics workspace. But to begin, I'm just going to go back to log search itself and just start off with some basic queries. It is important to slowly build up on the query language. You don't need to know too much for the course, but if you do want to get a little bit more advanced with it, on the right-hand side are all these getting started links. So there's a query cheat sheet, there's a getting started with query section, there's a whole website actually if we select this. And it takes you to docs.loganalytics.io, and this is a whole learning section, so you can click learn, getting started, a whole bunch of queries here, there's a whole bunch of examples that you can use, there's a whole bunch of videos as well. So plenty of material out there to get started. Microsoft obviously wants people to use this tool, and so they put a lot of effort into kind of getting people ramped up on it. But let's go back to log search and let's start to look at the beginning of this. Let's just start by saying, okay, I want to look at all collected data. So it's going to put in a query called search and then a star at the end, and this literally just pulls in all our results. So you can see there's 2,000 results. This is data that started to come in from the various systems we have. In fact, you can see the very first one on the right, Windows VM01. This is coming from the object, the network adapter, and it's the bytes received per second. Now on the left, you'll notice that you've got the types. So we chose to ingest performance logs, event logs, Azure activity, and heartbeat comes as part of the Windows logs that we brought in. So the real key thing here is if you want to just look at the performance logs, you can click perf and go ahead and scroll down and click apply. And that's now going to just filter that out into just those performance logs. And you can also choose to look at it in a table as opposed to the list view if you want to get an easier look at things. Now, the other thing you can do in the query box, instead of typing in search star where type equals perf, if you know the table that you're looking for. So in my case, I might just be looking for everything to do with perf. I can just type in perf and go ahead and select run. And there's my results for that. If I just want all the detail on heartbeat, I can type in heartbeat, go ahead and select run. And that's now just going to bring up all those heartbeat, pieces of information that we have. In fact, let's select one of these. Let's go ahead and select the first one. And a heartbeat is just, when the agent checks in. So if we scroll down, this is a timestamp. So, 10:15 based on the time zone this is in, it's connected in. There's the IP of it. There's the computer. It's a Windows machine, etc. If I go back to list view, the other thing to notice is you can see that all these items are clickable here. So if I say, okay, I just want to know about heartbeats on this computer, I can click this. And you can see that it searches Windows VM 01. I can also do it the other way. I can take this away and say, I can pipe it to where computer. And if I start typing it in, you can see it's got IntelliSense built in, equals Windows VM 01. Select run. And you'll notice that doesn't work immediately, and that's because it's case sensitive. So I do need to go in here and change this to all caps because I build my machine with all caps. Now I can select run, and that will pull that back. So that's heartbeats where computer is Windows VM 01. Okay, so let's build on this a little bit more. So perhaps I want to just look at where the time generated was within the last day. So I can go ahead and pipe this query to another one and say, okay, the results of that where I can put time generated. I can say greater than ago is the term we use in log analytics. And I can do like 1 day, I could do 1 week, 1 month, 1 year, etc. But I'm going to choose 1 day and select run. And you can see I still get my 11 results. If we try 1M, we get nothing. If we try 1 hour, we can see still get 11 results because all of those heartbeats came within the last hour. Let's take a look at another one then as well. So let's switch off heartbeat and go for something around event. So I can say event and hit run on that. And we can see lots and lots of events. In fact, if I expand one of these out, I can see my event log, event level. And let's see if we've got an event ID. So there we go. So this is the time service in Windows. It's the event ID. Now, if I wanted to, I could also just say the same thing up here. I can say, okay, where event ID equals, and then just give it my Windows event ID number that I'm looking for. So if I say like 7036 as an example, I'm going to get all those events. So for both of my Windows machines, because they're both connected, and this is just one of the Windows events you can get, and you can scroll in and look at that more if you want to. And this is basically saying the connected devices platform service entered the running state. It's just a standard information on an event log. If we want to also, we can get a little bit more creative and start to render things like time charts. Maybe I don't want to, keep looking at things in tables like this. So I can delete this, and let's do a chart of CPU utilization of all VMs in the past day. So we're going to type in perf. Going to do where time generated greater than go 1D. And now I'm going to choose my counter for performance. I'm going to say where counter name equals, and this one is at % processor time. And I can immediately query that. We're going to do a little bit more with it. Let's just go ahead and run when we're at this point. Okay, so we definitely still getting our results for processor time. Now I can go a little further and say, okay, I want to summarize average counter value by computer. Okay, and I'm going to render this as a time chart. And all of that, and what it does is you can see on the bottom, we don't have a lot of data because we just brought those machines in, but if we look at the top, you can see both of those machines, SLDC01 and Windows VM 01, are there on this time chart instead. So as more data comes in, it would basically be a line graph over time. Now what I can do is change my bin size. You can see how we've got bin time generated 15, and that's 15-minute intervals, and I'm basically separating them out into these marginable units of 15 minutes. But I could go in here and change this to 1-minute intervals, go ahead and select run, and you will see that we do get more of that graph starting to form there. So that hopefully gives you a good idea of just log searches. This is probably it for the course as far as log searches themselves go, but I encourage you to kind of check out that website docs.loganalytics.io and just continue to learn to do queries, performance queries, event queries, etc. But we are going to shift gears a little bit, and let's go back to our workspace. And let's now take one of these queries and let's just build a very simple dashboard for this. So if we go into View Designer, this is one area we can do it. And essentially we can say, okay, here's an overview tile, so that I want to position on the top of my dashboard, and that goes in this overview section on the right here. And then under View Dashboard, this is where I put additional widgets that I might want to use. So we'll just do a couple of very basic ones. Let's just take the donut one, select that, and you can see that comes up and it's already populated. There's a query on the right hand side. If you scroll down, you can look at that query. You can grab that entire query if you want to and just play around with it, modify it just like you did in the other queries previously. And you can see this one basically takes us total count of the alerts and logs that we have, and then categorizes them by the top 3. So we can see we've got perf logs, event logs, and heartbeat logs that are in there. The next thing we would do then is go into our View Dashboard, and now we can add additional things. We can add additional queries. So if somebody clicks that donut tile, they can go in here and see these additional queries. We can add additional things on top. I'll just close this one down. 2 numbers and a list. If I scroll out a little bit so you can see more. You can see there, so computer sending data, Windows VM SLDC01, you can see that. Stacks of line charts, a lot of these are in preview as well, but you can see them. So you've got some examples, data types over time, data from computers over time. If we select these, we can certainly edit the query as well. If I scroll all the way to the right hand side and then scroll down, you'll see it's all made up of queries. So this very first line chart is this query, the second line chart is this query over here. Scroll further down, we've got that third chart, and that's another query. So you can go ahead and build those queries in the query designer. You could go into the larger view. If I go up to the analytics view, we can go in here. Again, there's some example queries, like all events, by time generated. You can double click these, run these. It's going to give you all that data, in the bottom here. I can look at charts and things of that data, and then I can just take that and put that directly in visualizations that I can then publish to my dashboard. The other thing you can do also, if we go back to the View Designer and go back to our main section here, if we go to OMS Portal, this will take us to an overview portal that we can use for managing our environment. So it's kind of a nice overview dashboard that you can present to the organization. So there's nothing there by default, but again, I can go and click the plus sign. That takes me to the View Designer that you just saw, and I can publish various widgets there. But in addition, there's something called the Solutions Gallery. So if I click this, there are a whole bunch of things already built in that Microsoft has created that you can simply grab and go with. So if you use these first of all, in fact, again, you can get all the queries from them, use them, modify them, do what you need to do, and put them in your dashboard. So if we just want something on agent health, I can select this one, go ahead and add that to our dashboard. That's going to add the solution and all the queries and widgets and things for us there. If I go back to the solution gallery while that one's installed in, let's grab another couple in here. Let's go all the way to the right. We'll show you one which requires additional recovery. So Network Performance Monitor is a good example of that. So if we click add on this one, and now let's go back to our home screen. These should start to populate very soon. If not, it helps to just give a refresh on the very top, and you'll probably see them appear in there. So there we go. So agent health, if I select this one, you can see total count of agents 2. So only 2 of our 3 machines are checking in currently. And if I select this one, scroll in here, and I can see all these additional widgets that have been created for us, and I can perhaps click one of these, and it brings up the log search, and again, there is the log query that I can grab. If I go back to the dashboard, I can also look at this other one, Network Performance Monitor, and you'll notice that some of them say solution requires additional configuration. So if we select this one, it'll give you the additional configuration instructions that you need to perform. So in this case, there's some firewall ports and things you need to open up in order to use Network Performance Monitor. Once you've done that and configured everything correctly with PowerShell, then this one will start working as well. So idea being is get all your queries, decide on what you really care about and what you want to visualize on a dashboard, and then start to build dashboards that make sense for that. Last thing we'll show you is just about alerting. So the other thing you can do is back in the workspace, go to alerts on the left hand side, and I'll zoom back in, and similar kind of process. I can create a new alert rule, but now what I can do is add it based off a query as well. So there's my target, which is this workspace. I add my target criteria, so I can do a custom log search. I can just say, okay, all events. We'll just do that for the moment. And you can see we've got all events there, and this is just the query that's built in again. I can choose the condition for when I, decide to fire off the alert. So I can say, okay, greater than 1. So obviously this will definitely fire off. And the period in minutes and the frequency. So this is how often it's going to check. And then go ahead and click done. Scroll down to define alert details. And this is the alert rule name you give it. So I can just say, all events. This is a demo. Choose the severity, so I can say, okay, this is critical, warning, or informational, so this is warning, and then I define something called my action group. So if I expand this out and I create a new action group, this is the group I want to target with the alert. So this could be, IT support, and I can say, okay, this is all my subscription, my resource group. Here's my unique actions. So I can say email team. And I can say my action type might be to send an email. The other things to look at, though, is you've got a option for a webhook. You can do ITSM connections, so to things like ServiceNow. And then I've also got automation runbook. So perhaps I don't just want to notify someone. Perhaps I want to take some action in response to this event. I would use an automation runbook. If I want to talk to a web service endpoint, I can use a webhook. If I want to just create a change ticket or something, say, hey, this happened. I can create an incident ticket in many cases, not just a change ticket. I can do that and then create my change ticket if the automation runbook executes. And then, or I can just email, right? So I can select email, choose the details, the email teams. In my case, I'll just put in, nick.collier@skylinesit.com. I can send text message if I want to as well. Select OK again. And that's my group completed. Once that's created, we should be able to move a little further. It takes about 10 or 15 seconds here. There we go. Choose my email subject. And I can just put a, alert from Azure. Again, I can customize these. And one thing I do need to still do, I'll create an action group, but I still need to select it. So we'll hit select action group, select IT support. The good thing is once you've created those action groups, you don't necessarily have to go back in and define them every time. You'll just create the new alerts and then choose the people or the events you want to take place when the alert fires off. So I go ahead and click create alert rule, and that will now create that alert rule. So whenever those events trigger, in this case, this query is just grabbing all these events, and when it's greater than 1, it's going to fire an alert off to me. That will send off. The other thing you'll notice, if we go over to Outlook now and just look at my email, you'll notice that I got an email that said, that was easy. You're now in the Azure Monitor Action Group ITS. So your users will get notified when you put them into one of those action groups. They'll get this email that lets them know they're part of that group, and they'll get notified, in those events that you've correlated to that action group. And with that, this concludes this demonstration, and hopefully this gives you a good overview of log analytics. I'm sure you'll definitely be using it over and over again as you get more and more familiar with Azure. In this demonstration, we're now going to take a look at resource groups, something we keep coming back to over and over again, and tagging of those resource groups. So let's head over to the Azure portal. And in the Azure portal, we'll go straight over to resource groups on the left-hand side. And you can see I've got a couple of resource groups already there in a variety of locations. And I'm going to go ahead and simply add a new one. So I click add, and in the basics here, the first thing I need to do is choose my subscription, where I'm going to put that resource group, and then give that resource group a name. So I'll call this one AZ Exam Demo. Then I choose the region. Now you can put objects in the resource group from other regions. The purpose of the region for the resource group is where the metadata for that resource group is actually stored, all the details about it, the tags, etc. It ultimately still has to be stored somewhere, and so that's the purpose of this region here. So it doesn't really matter too much where you put it, but the one benefit is when you are using ARM templates later on and saying, okay, I want to deploy this virtual machine, and asks you for the region to deploy the virtual machine in, you can simply state inherit from resource group. So it does still help to put the resource groups in the same region if you have a primary region where you deploy your workloads to. Following on from the basics, we then hit tags, and right away we can simply input tags directly on our resource groups as well. So you may have seen in some of the subscription demos, we can put tags there, but we can also put tags directly on the resource groups. And there was that tagging spreadsheet that we covered in one of the earlier modules. That's a good thing to kind of, set your stage in terms of what tags you want to keep and how you're going to tag. Think about that first before you just go in here and start tagging. But when you are ready and you've come up with the tags that you want, certainly through automation, you could deploy these much more easily. But if you need to do them in the portal, things like cost center are very common. I'll just put cost center. Lab could be my cost center, could be the HR department, could be, depends on your specific situation. And then you might have other things like maintenance window is a common one. I could say, this is going to be Saturday, 9 p.m. It could be a maintenance window that I have, and you might have different ways of storing these, even in JSON templates in some cases. But it's very important to make sure that you tag everything that you build so that you know who built it, what it's for, who's paying for it, etc. Business owner and technical owner, if nothing else, knowing who the machines and other services that are in there belong to is so important when it comes to reporting on cost, etc. So if we go ahead and click review and create, and then click create, and that will go ahead and create our resource group, which only takes a second or two, and then we can immediately go into that resource group. So here we are in AZ exam demo, and I want to bring your attention to a few things. One, we have an activity log in here, so this will show you one update right now. If we refresh, we see the update resource group, and that's the first activity log update from any new resource group that gets created. We have an access control section, so we can assign permissions. We cover RBAC permissions in identity, but we can add role assignments directly to the resource group. So think of this as another boundary for given access. Perhaps we don't want to give subscription access or any role in the subscription to somebody, but we just want to give them access to certain resources that we put in the resource group. This is the place we can do that. Tags we already discussed, and again, you can create them when you build your resource group, and also add and modify tags as you go. Events are a way to trigger and are more associated with things like logic apps, event grid, etc. Not something we need to cover right now. If we go down, there are a few other quick things to be aware of. Resource costs. This is a great area because if we've got lots of resources in our group, again, right now, empty resource groups, it's not showing really anything there. But as resources get put in the resource group, this is a place where you can see the roll up of those costs as well. We then have something that is very important, and you may get asked questions on the exam for this, is deployments, and we do cover ARM templates later on as well, but essentially you can go back here and look at all the deployments that have occurred in that resource group. So every time whether you deploy from the portal, whether you deploy from an ARM template, you can see those deployments, you can view the templates, you can redeploy them, and you'll see more about that later on. Next, we have policies, and policies are very much the same as the policies we can apply to subscription. So if you remember from the very first section of the course, we did subscription policies. Same thing here. We can assign a policy or a group of policies via an initiative. Maybe this resource group, we're restricting the virtual machine instance SKUs that are allowed to be provisioned. Maybe we want to enforce some type of encryption. Those are things you can then do directly on the resource group. And if we go back, a few other quick things. One is automation script. And this is also where you can just download the template, for all the resources that are actually in there right now. So deployments were showing you previous deployments. Automation script is really just downloading that resource group as an ARM template. Moving further on, we have a lot of options to jump ahead in monitoring. So we can get to monitoring through Azure Monitor. So we can access that through services, as you may have seen in the monitoring piece of the course as well. But we can also access it directly from here as well. And last but not least, we do have a new support request option we can submit directly from the resource group as well. But with that, that's really all you need to know for resource groups. Hopefully this gets you up and running. Just be aware of what you can and can't do directly from the resource group area. Common things to look out for are the deployments, the policies you can apply to resource groups, and just knowing that you can assign RBAC roles directly to a resource group as a way to restrict permissions in case you get questions around, user scenarios and things like that on your exam. And with that concludes this demonstration. One of the features Azure provides to prevent accidental resource deletion is the use of resource locks. And these are essentially just a mechanism for locking down resources that we want to have that extra layer of protection before they can be deleted. So for example, when we delete in resource groups and storage accounts, etc., we've just gone in and deleted them. Often we have to type in a name or something to actually delete it. But a resource lock creates this additional layer that we have to kind of remove first before we can delete the resource group. And there's two options available. One is cannot delete, and this is authorized users can read and modify but not delete the resources, so they can make changes to them but not actually delete anything. Read only, authorized users can read the resource but cannot update or delete. So the one that's actually most restrictive is read only, because it's read only. You can't modify any of the resources in there or delete them. Cannot delete, you can't delete them, but you could still make modifications to them. So a lot of people often think cannot delete is the most restrictive, or no, it's actually read only. So if you just want to make sure no one touches it at all and modifies it, use the read only resource lock, and you'll see how to configure these in the upcoming demo. In this demonstration, we're now going to implement a resource lock in Azure on a particular resource group. And this is to help in case we had something like shared services infrastructure or some particular data services we wanted to make sure nobody could delete. So we'll head over to the Azure portal, and in there, we're just going to pick a resource group. So in my case, I'm using SL-arm counts. This is one from a previous demo that we're going to delete eventually, but for now we're going to test it out with the lock, and you can see that this resource group has 5 storage accounts in it, so we don't want it to get deleted just yet. We'll hit the lock section, and we'll go in and click add, give the lock a name, and choose the lock type. Now if you remember from the tutorial, read only is the most restrictive, but in my case I'm just going to use the delete lock for this occasion. Select OK, and you can see that lock is now available on the resource group. If we scroll back up to the top and I attempt to delete this resource group, so I'll type in the name that it prompts me as per normal, and I hit delete, immediately we get that error saying the resource group SL arm counts is locked and can't be deleted. And if I go back in and remove that lock. The resource has no locks now. Go back to the overview, delete the resource group, and at this point it's going to delete, hopefully if all goes well, all of those storage accounts in there, and you can see it didn't come up with an error this time, so it's now in the process of simply deleting that resource group and everything that was inside it. And with that, it concludes this demonstration, and hopefully that gives you a quick insight into resource locks and how easily you can just put them on your resources in Azure that you want to protect. You'll probably get 1 or 2 questions on the exam on this, just how would I protect resources, and there's obviously different mechanisms we've covered so far in this module. One of the questions I get a lot from customers and anybody using Azure in general is just around governance and how do they restrict things? How do we make sure people can't make mistakes in the environment? And Azure policies are really a tool that allow us to enforce governance. We can say this is our policy around Azure and we want it enforced, so nobody can go out of the boundaries we've set in the portal or just via their ARM templates as well. And so Azure policies allow us to do that. They're either built-in or custom coded. So you'll see in the demonstration there's a number of built-in policies you can simply apply, or you can go ahead and custom code one yourself, or just look on GitHub and look at what the community has to offer. Now they can be assigned to subscriptions as a whole, so they'll affect everything in the subscription, or they can be more granularly assigned to specific resource groups. So if we've only given somebody permissions in a resource group and we want to put some policy around that specific resource group, we can do that as well. And finally, the way we do this is we first create the policy and then we assign it. So when you look in the Azure portal, or if you're doing it via PowerShell, you'll create the policy first and then you'll scope it to those specific subscriptions or resource groups. In this demonstration, we are going to implement an Azure region policy, and this will allow us to restrict the specific regions that we will allow users to deploy into, whether that's via the portal or whether they're using ARM templates. This is applied at the Azure level. If we switch over to the portal and simply select a resource group or create a new one for testing out, I'm just going to pick one from a previous demonstration. And in here on the right hand side under settings, you can see policies. If we select policies, we have this choice of assignments or policies, and we'll get to assignments in a moment, but first let's select policies and see what's available. These are all the built-in policies, including ones that are in preview. And if we scroll through these, you'll see various ones like apply tag and its default value, not allowing specific storage SKUs, not allowing specific virtual machine SKUs. The one we want for this demonstration is allowed locations, and if we select that, we will see the details along with the JSON tab. So we can actually copy this. I'm going to take it over to Visual Studio Code so you can see it a little better. We'll paste it in there and change it from plain text to JSON. And you'll see the way the syntax works. It's a bunch of if conditions. So if not field location in the parameters that we're going to pass in when you see us do the assignment, then effect deny. So you can see very quickly you can grab some of these and start to construct your own policy templates if you want to. But let's say we like this as is and we want to go ahead and apply it. Let's go back to the portal and go to assignments. I'm going to zoom in a little here and select add. And what will come up is our add assignment screen, and we can select policy first of all. So in our case, if we scroll all the way to the bottom again, we should see it here, allowed locations. And now I simply need to select the locations I want. So I can open up this drop down and I'm going to choose only North Central US. So everything else I wanted to deny. I need to go give it a few more things. So again, it's scope to SL-ARM counts. And we'll just give it a basic ID. And hit OK. And that assignment is now created. It only takes about a second for it to complete successfully. And now if I go to the top of my resource group and I try and deploy a new resource into it, so we'll add something like a storage account. And let's give it a basic name. And scroll down. We'll keep all the defaults for the storage account. We'll say use existing for our resource group and choose SL-ARM counts, and we're going to change the region to something else. We'll choose West Central US and hit create. Some validation errors, you'd select those. And you can see there the error type, the template deployment failed because of a policy violation, and the details of the policy are there. So you can see very quickly, this is a great way if you want to just put controls, if you don't want anybody putting data in other countries, if you want to make sure everything stays in your locations, if you want to restrict those large virtual machine types, using policy is a great way to enforce some very quick governance for your Azure environment. In this demonstration, we're now going to take a look at how we would move resources between resource groups. So let's head over to the Azure portal. Okay, and in the Azure portal, what I need to do is just find a resource group with some objects in them. In fact, I've got one here from a previous demo. So if I go in there, you'll see that I have a number of objects. If we scroll down, you can see I've got a virtual machine, a NIC, a network, and a disk in there as well. And perhaps I want to combine this with other resources or just move it to a brand new group, for various other reasons. So how would I go about doing that? Well, first of all, let's go and create our new group. So we'll go back to resource groups, click add, and we'll just call this one SL new group, and we'll click create. Okay, and that's created. So if we go back to demo 6, where our resources were from a previous demonstration, and go ahead now, and you'll see this button that says move at the top. Simply click that, and you see you have two options here: move to another resource group or move to another subscription. So it is possible, if you've got multiple subscriptions in your account, to move the resources to another subscription entirely. Sometimes if you convert it over to a CSP provider, you might use the move to other subscription option. But for the purposes of this, we're going to go with the first one, move to another resource group. So we'll select that. And you'll see you can choose the resources you want to move, or just select all of them. Move these resources to, and then we'll choose the resource group, SL new group. Now, one thing to note, there are certain things that perhaps can't be moved. So you've got here a particular alert that we'd created in one of the previous modules. You can see how it's the metric alert we did, and that resource cannot be moved, but it will remove the actual resources themselves, but we may have to go back and reconfigure some of the metric alerts there. And it does prompt you again, I understand that tools and scripts associated with moved resources will not work until I update them to use new resource ID. So any of those scripts maybe you've got tied to a resource group, because it's using the ID, you may need to update because these resources will potentially have a new ID when they are moved. With that said, go ahead and click OK. It'll validate. And if all goes well, that will just succeed and your resources will be in a new resource group. But let me show you what happens if you actually get an error on this. And you might see something like this: validation failed. Click here to see details. And if we look at this, you can see the error details. And in this case, this subscription is not registered to use Microsoft.compute/managed resources move feature code bad request. And this is because currently you cannot move managed disks between resource groups. So that's something to note, because we do encourage you to use managed disks throughout the VMs module, but then it does restrict you in terms of moving them between groups, and just something Microsoft needs to fix hopefully in the future, and then that will be supported. But with that said, you can see how easy it is to move the resources, but they have to be supported. And this concludes the end of this demonstration. Let's get started with blob storage by taking a look at this from the storage account perspective. First of all, we have our storage account, and you'll need one that supports blob storage. In addition, we have our containers, which are inside our storage account. This helps us organize our various blobs and images and data files as we come across them. And finally, we have our blobs themselves, which go inside there. Now, you may be thinking, okay, what is a blob? How is this different? Well, blob is a binary large object. Think of it as your ones and zeros. These could be images, video files, random text files, or whatever they might be. But don't confuse them with files compared to like an SMB file share, for example, which has permissions and other things associated directly from a CIFS perspective. This is for storing large amounts of images, videos, etc. Now, if we look at the storage account types, we have three major types. We have GPV version 1, blob accounts, and GPV version 2. Now, GPV version 2 is the main choice you will use when you create storage accounts in Azure now, because it allows us to do page blobs, block blobs, so we can do all of our images, videos. We can also store VM disks in there as well. We can mix everything in a GPV2 account. GPV1 allowed us to store blobs and other disks as well, but a blob account was specific only for blob storage, and ultimately it was confusing for everybody, so that's going away, and GPV2 accounts are ultimately the direction going forward. You may be asking then, okay, well, what is the difference between a block blob and a page blob? So a block blob, again, is ideal for storing text or binary files. Again, those are those images and video files. A single block blob can contain up to 50,000 blocks of up to 100 meg each for a total size of 4.75 terabytes. So that's a single image. Ultimately, it could be 4.75 terabytes. Append blobs are also there, and they're optimized for append operations, example for login. Now, you may see that difference between blob creation and append blobs, and that's just important from that perspective. Page blobs, on the flip side, these are for read-write operations. Think of your VM disks here. These are used by Azure VMs, and these can be up to 8 terabytes in size, which leads us on to the next thing that we need to cover, which are storage tiers. We've decided now that we want to use blob storage and store a bunch of images, but what's the right tier to go for? Well, the first one we look at is hot storage. This has our highest storage costs, but our lowest access costs. So think of this for frequently accessed images that we might be utilizing in our application, or, maybe website content, things like that, accessed very periodically. Then we have cold storage. This has lower storage costs now, but higher access costs. And it is possible to move from cold to hot and hot to cold, as you'll see in some of the demos. But what you do incur is a storage cost penalty when you do that, because if you're moving from cold to hot, immediately you're going to pay those higher access costs for accessing the cold storage as you move it to hot. So even though you can move them around, it's best to aim to use the right tier of storage for your purpose. And if you look at cold, it's really intended for data that will remain cool for 30 days or more to be cost effective. Finally, we have archive storage as well. This has our lowest storage costs, but our highest retrieval costs. When a blob is in archive storage, it is offline and so cannot be read. And this is really because it's pushed off to tape or some other archive type storage that Microsoft uses on the back end. So if you decide you want to access something in archive storage, there is a period of time as that has to get rehydrated back so you can access it. Now, ultimately, just pick the right storage for your use case. And if you decide, okay, well, sometimes things go into hot storage and then eventually I want them to go to cold or eventually to archive, it is possible to enforce some auto tiering around this that will gradually move, unaccessed blobs from hot down to cold, down to archive, and there's various automation techniques in Azure that allow this to take place. Finally, let's just take a look at the decision criteria as we try to choose between blobs, files, and disks. Often this gets very confusing. So if we break it down, blobs themselves, this is for storing large amounts of objects. Again, images, videos, etc. We might want to access them from anywhere. Just lots and lots of images, videos, text files, etc. that might be accessed. Then we've got files. So think of these as more from accessing from multiple machines, jump box scenarios. Maybe you've got a remote desktop that somebody wants to store a root user profile on. That's a good scenario. And then finally, we have disks. So these are really associated with our virtual machines attached to the operating system. Think of this for like lift and shift scenarios. When we're moving from on-premises, we might be doing disk expansion for application installations, lots and lots of read writes. That's when we would ultimately use disks themselves. Now that concludes the overview, and I encourage you to check out the subsequent demo, especially as we kind of build blob storage accounts and move images around. You'll get a lot of feel for everything that we've covered this far. In this demonstration, we're now going to cover creating a storage account via the Azure portal. So let's flip straight over to Azure. Here we are in Azure, and the first thing we're going to do is on the left, just go ahead and create a new resource group. So select resource groups, select add at the top, and type in your resource group name. So in my case, I'm going to use SL-storage. Choose your subscription and the resource group location. Again, this is just for metadata for the resource group itself. You can still put your storage account in any region you like. And go ahead and create that. The reason we do this and create our own resource group here is we can put all our storage accounts in there for demonstration purposes. Just delete the resource group when you're done and you've ultimately wiped everything out straight away. So within a few seconds, that should be created if we hit refresh here. And there we go, SL-storage. Now we're going to that resource group, and let's go in here and create a new storage account. So go ahead and select add, type in storage account. You'll see it'll come up there, storage account, blob, file, table, queue, because that's what we can store in there. And go ahead and select that, create. And now we'll get the blade for creating our storage account. So first of all, let's go ahead and give it a name. So in my case, I'm going to use SL-storage demo. And as you can see, this is a publicly addressable namespace that we need here, so it has to be unique. Then we choose a deployment model. For everything in this course, we'll ultimately be using the resource manager model, as you've probably seen so far. And then we get onto the storage account type. So if we go ahead and hit the drop down here, we can see we have storage, storage v2, and blob storage. And ultimately now everything we do, we're going to use a storage v2 account. Now you notice some of the options change below. If we go back and choose storage gv1, we don't get that option for the tier straight away. Go switch back to it again. And you can see that there we get a default access tier. And this is because we can set a tier of storage at the storage account level, which will apply to all the objects underneath it. Now we can still change the individual blobs to have their own access tier, but this is quite a nice feature because we can say, okay, everything we want here, we might want cool, we might want hot. In my case, I'm going to choose hot, and everything underneath it will apply to. Then we can choose our performance. So we've got standard and premium, much like when we talked about virtual machine disks. We can choose SSD type storage or standard spinning disk. In our case, we'll just go for standard for the purposes of this demo. Next, we need to look at replication options, and we have the same four that we covered in the virtual machine section. LRS, which is a locally redundant storage. This is 3 copies locally in the same data center. We have ZRS, which is zone redundant storage. This is in preview currently, still 3 copies, but in a zone-based region, so a couple of data centers in the same region. Geo-redundant storage, which is GRS. This is 6 copies across multiple regions. And finally, RA-GRS, which is read access geo-redundant storage that allows us to replicate to another region and actually read data there. It's basically warm and ready for us to access. In our case here, we'll simply select LRS. Next, we choose our access tier, as we already discussed. We're going to use the hot tier, and then we have options around secure transfer. If we open up the information on this one, this allows us to enforce encryption options for when we access in data from the storage account. For the purposes of this demo, we'll just choose disabled, choose your subscription, and select the resource group we just created previously. Finally, scroll down, select your location. In my case, I'm going to continue to use North Central US, and choose Disabled for virtual networks. This option, which will be covered in the networking section, is around virtual service endpoints, and that allows us to say, take a storage account, and instead of exposing it over the internet, we can expose it directly through a virtual network. And this is a way for security teams to buy off on the fact that, we have blob storage out there that's only inside of the Azure private network itself. With all those options selected, go ahead and click Create, and then we'll fast forward here. It should take about a minute for your account to be created, and we'll transition to once that's completed. As you can see, after a period of time, the storage account is now created, and we can go ahead and select it. Once it opens up, you can see the performance that we chose, which is standard, the replication set to LRS, and our account, which is set to GPv2. And then at the bottom, you can see our various services. So we've got blobs, files, tables, queues. If we wanted to go ahead and upload blobs, we could go into the blob section, create our container, and upload it from here. But you'll see in a subsequent demo, as we use Storage Explorer, how you can upload lots of blob images and manage your storage account from there. And with that, this concludes this demonstration. In this demo, we're now going to create a storage account via PowerShell. So let's head straight over to our PowerShell client, and let's begin. The first thing we need to do is make sure we have the right version of the Azure RM module available. You can check your current version by typing in get module space dash list available Azure RM. And once you hit enter, you'll see there module type script version 4.4.0, and you just need to make sure that you have version 3.6 or higher for you to be able to create storage accounts using PowerShell. The next thing we're going to need is our resource group, which we created already when we did it via the portal. So let's go ahead and do a get Azure RM resource group. And we can see there that we still have our resource group, SL-storage, and the metadata being in North Central US. Let's go ahead now and store that resource group in a variable. So let's type $resource group name equals SL storage. Hit enter. And now it's time for us to go ahead and create our new storage account. So use the following command to new-Azure RM storage account. Then hit dash resource group name. You can start typing it in, it'll fill it in for you. The variable for resource group name, followed by the name of our storage account, so dash name. I'm going to use SL storage P shell here to identify it as a different one from the one we created in the UI. Now we need to define the location, so we'll use North Central US. Next we need the SKU, so this is where we choose the type of disk and the type of replication we want. So if you type in dash SKU name, and then follow that up and type in, say, standard, and start tabbing through these, you can see you've got standard GRS, standard LRS, standard RAGRS, etc. And if you type premium in the beginning, it'll give you the LRS option, which is currently the only option for the premium disks. But if we go ahead and choose standard LRS there, and then finally choose the kind, in this case, we're going to use storage as opposed to blob. Go ahead and hit enter. And we'll fast forward here. After a minute or so, you should see that complete. And in a little while, you'll get a screen like this to show that everything's completed and there's some details around the storage account itself. But let's now just go straight over to the Azure portal. And if we go over to our resource group, and do a refresh. In fact, we already see it there. So we've got SL storage P shell. Select that one there. And we can see at the top that we've created a standard LRS storage GPV version 1 storage account in this case. And if we want to, we can use PowerShell also to upgrade that to version 2. But let's just go over and select configuration from the settings panel on the left. And there you'll see immediately it shows the account kind as storage general purpose version 1. And if we want to, this is another place we can simply hit upgrade. Go ahead and confirm the upgrade. And to do that, you need to type in the account name. So in this case, it's SL storage P shell. Select upgrade. And that will go ahead and upgrade your storage account. And you can now see it is set to version 2. And with that, this concludes this demonstration. All right, time for another demonstration. And now that we've created a lot of our storage accounts, whether we did it via the portal or via PowerShell, it's now time for us to be able to browse that storage and maybe upload objects, etc. to it. And so we're going to use the Storage Explorer client to do that. In order to begin, you first need to download the client, which you can find on the Azure website. If you head over to azure.microsoft.com/en-us/features/storage-explorer, or just Google Azure Storage Explorer, you'll be presented with this page. There's a Windows client, a Mac OS client, and a Linux client. Go ahead and download Storage Explorer free by selecting the link at the bottom after you've selected your OS. And once that's installed, we'll continue with this demonstration. Okay, so once Storage Explorer is installed and you'll immediately be prompted to run it, go ahead and do that and you'll be presented with the screen. You have a number of ways that you can log in and browse your storage. You can simply add an Azure account directly. You can use a connection string or a shared access signature that we'll learn about later on in the module here. And you can always use your storage account name and key as well. But in our case, we're just going to sign in by selecting sign in on the bottom here. And this will sign us in the usual prompt to sign into our Azure account. Okay, once that's added, simply select apply, and then you can see all of the various storage accounts. So in our case, we created a SL storage demo, first of all via the portal, and then we created one via PowerShell. So we can expand these out here and see what's inside them. Again, we really don't have anything in them at the moment, but you kind of get the idea there. Now, what we can do is add some files directly to that. So we can take some images, for example, and then go ahead and select the blob container section under your storage account. So if we right-click there and click Create a New Blob Container, call this one Images. And on the right-hand side now, we see we have this upload option, so we can go ahead and select that. Click Upload Files. And now I'm simply going to select a folder full of files. I've got an image sample on my desktop, so I'm going to select all of these, select Open, and go ahead and select Upload. And what you'll see is this begin to start here in a moment. And on the bottom, if we expand this out, we can see the group of images it's uploading, how many are complete, and you can see they're appearing in the top pane there as each one is uploaded. And so you can see the flexibility. It's just like managing a file share on your own machine where you can create images, delete images, etc., create new folders. If you want to get a URL from them, if you want to rename them, you've got these whole series of options available to you on the top there. The other thing as well is if we go over to the Azure portal, and look in our same storage account, so SL Storage Demo, we also have an option there, Open in Explorer. So if we go ahead and select this and click Yes, you'll see it'll switch apps and open directly in Storage Explorer as well. So this is another quick shortcut. If you're in the Azure portal and you want to open up in Storage Explorer, you can simply do that and it'll take you right across there. And with that, this concludes this demonstration. We're definitely covering a lot of details around storage here, and you might be thinking, are there other tools that Microsoft makes available to copy files, perhaps between blob storage accounts and different accounts, perhaps from your local machine to a storage account, etc. So let's walk you through a little bit of a demonstration here. But to begin, you first need to go ahead and download the tool AZ Copy from the Microsoft website. So here we are on the Microsoft website, and the first thing you need to go to is the Getting Started with AZ Copy webpage, which we've linked here for you as well. And this again is the command line utility that you can use to copy blobs or files to or from a storage account. Now you will notice that AZ Copy version 10 is the currently supported version. There was a version 8.1, and that was actually covered previously in my courses, but this is now updated to version 10. Everything we're going to do from here on out is version 10, so make sure you get in version 10 if you're following along. And what you need to do is scroll down, you'll see Download AZ Copy, and you've got your Windows, your Linux, your Mac OS options here, and it's an executable file. There's nothing you need to install. What will happen is when you click this download link here and click Save, it will download a zip file to your machine. Go ahead and open that folder, and what you'll see when you open up the zip file, in the folder inside it, there's azcopy.exe, and again, all you need to do is copy that to somewhere you can execute that from. Very quickly, if you're not too familiar on Windows and how you do environment variables, I'll show you how I've done it in my case. So if I go to my C drive and I go to AZ Copy, I created a folder called AZ Copy, and I just copied that exe file straight in here. And then what I also did was change my environment variables. I can execute it from anywhere. In Windows, you can just hit the Start menu and type environment. And you'll see it says Edit the System Environment Variables. Click in that, and then click in Environment Variables at the bottom. You'll see here you have your user variables. These apply only to you on your machine, and your system variables that apply to everyone. In my case, if I scroll down in System Variables, you'll see a section called Path. And if you click Path and click Edit, this is all the locations that you can execute from directly. In my case, at the bottom, I've got /AZ copy. If you want to put it in a different folder, that's absolutely fine. You can browse to that folder when you want to execute, or you can just add it to your path by clicking the new button on the top here and put it in. So if you put it in /temp or something, you would just put that in there wherever you basically put it in, and then you'll be good to go. But I'm going to cancel out of that now, cancel out here, and open up a command prompt to show you how it works. And I've also saved a number of pre-filled in commands that I'm going to use throughout this demonstration. And so I've got them here in a text file. I've got AZ copy login to my tenant ID. That's the first thing we're going to do. Now you don't have to always put the tenant ID in. You can just do AZ copy login, but it will go to a default tenant, and you might get an error if you're not authorized in that tenant. In my case, I want to specifically log into this Azure Active Directory tenant, and that's why I've got the tenant ID there. If you haven't covered Azure Active Directory already, you can jump ahead and learn more about Azure AD, but otherwise just make sure you put your tenant ID in for the tenant you're trying to log into, and you will be just fine. We're then going to run through a number of other commands which I'll talk you through, but for now let's just go ahead and log in. So I'm going to open my command prompt, and I'm going to type in AZ copy just to verify that I can actually grab the file. And you can see that it does work. It comes up to show me that I've got available commands, even though I'm not in the AZ copy directory. Again, I put that in my C drive under AZ copy, and there's our exe file. That's basically what's executing every time I type AZ copy. But let's go ahead and log into that tenant. So I'm going to go grab my login command here and paste that in, and that will now log in. And you'll see it says go ahead to this page, microsoft.com/device login. So if we browse over there, and then enter the code that's in the command prompt. So here we go, grab this code and enter it in, and that now logs me in with Azure AD authentication. You can also log in, as you'll see on that page, using a SaaS token if you prefer. That's another option, but in my case I'm just going to log in with Azure AD here. Okay, so that's logged in. If I go back to my command prompt, and we can see login succeeded. And so now the next thing we need to do is just show you the layout of the lab area I've got for this one. So in the Azure portal now, I've created two storage accounts for this. These are simple storage accounts. One is in North Central US, one is in East US 2. One is called AZ Copy Demo, the other one is called AZ Copy Demo Target, and we're going to use them for different use cases. If I click into the first one, we're going to look at AZ Copy Demo. You'll see here that it's just running on LRS storage, so locally redundant storage. It's on the standard hot tier, and it's a GPV version 2 storage account, and that's all we really need to know about it. It's just a basic GPV2 storage account that I can then copy into. If I go into the blob section of services, I can create my container, and we'll create one here, and we'll just call it test container, and we'll say private, no anonymous access for this container, and click OK. So there's our test container. And now before I can start copying files in there, there's one other thing I need to do, which is make sure I have the storage blob contributor rights assigned. So if I go to access control and I go in here and click role assignments, and then go ahead and add a role assignment, add role assignment, and you'll see a select a role, and you can type in blob. It's probably the easiest way to get this, and you've got storage blob data contributor. Now, even though I'm a global admin, even though I'm a subscription admin, even though I created the storage account, Microsoft does now require that you specifically give access as storage blob data contributor in order to copy files into blob storage. And that's a recent change, but a very welcome one, because they want to make sure that all the data services are locked down by default, and you have to explicitly give permission for them. So we do need to add this role, and I'm going to go in and add myself to that role. That can take up to 5 minutes to take effect, and while that's going on, let's go ahead and look at the files we're going to be copying over. So if I go to AZ copy on my C drive and then go up one folder, I've got an images folder, and in there you can see I've got 3 images, 1, 2, 3 here, and I've got a subfolder called images subfolder, and if we go in there you can see I've got 1, 2, 3, 4 images in there as well. If I go back to my storage account and go back to that container, so if I scroll down, go to the blob service, and then select the container, test container, I don't have anything there presently. Now I've saved all my commands, ready to go, and we're going to use this one, AZ copy, the command task action we want to take, /images, and you can see the star there, so that indicates I want to copy everything in that directory, and I'm going to put it in AZ copy demo, that's our storage account, .blob.core.windows.net, because I'm not using any custom domain for that storage account, and I want to put it in the test container that we've created. So let's go ahead and give that a shot in the command prompt. Okay, here I am back in my command prompt, and I'm going to paste that command in and hit enter. And we can see it's copying 3 files up there right now. Now you might be asking why only 3? Well, we'll come back to that in a second. Let's go back over to the portal and just verify those 3 images went across. And if we refresh our container, yep, we can see 1, 2, 3 images there. Now if we go back to our command and we simply add recursive switch to the command and hit enter, it will now go through the folder that we're copying from, look through the subfolders and copy those in as well. That's completed. If I go back to the portal, refresh, you can see I've got that images subfolder in there now, and I've got those additional images inside there as well. Well, now what if we want to copy all of this from this blob storage and container over to the other one in the other region? Well, let's go ahead and go back. We also need to give rights to that other blob account. So we'll go back to our storage accounts. I'm going to go to AZ copy demo target, identity and access management again, add that role assignment, click add, role assignment. Remember, it's blob contributor that you need. And I'm going to assign myself to this storage account and click save. And now there's one more catch. So even though I've got rights on the target and we know I can copy files from a local machine to a target using my Azure AD authentication, unfortunately Microsoft doesn't yet allow you to copy from the source without a SAS token using AZ copy. So what we need to do is go back again to our other storage account, select AZ copy demo, and then scroll down and select shared access signature. And we can choose all the services for now, but if you were doing this in an enterprise where you wanted to restrict, you would typically just create the SAS token for the services you need. But in my case, I don't need to worry about that. The only thing I just want to make sure of is that I do choose a time in the past here. So I always typically go back a day and then go ahead and generate my SAS token. And I'm not going to use any of the other settings, but just to clarify, in case anyone's wondering, so this is allowed IP addresses, so this is sources that can use that SAS token. Here are our protocol options for HTTPS only or HTTPS and HTTP, and this is our signing key again, so key 1 or key 2, and I can regenerate those keys. If I scroll back up on the left hand side, I can generate access keys in the access keys section, but obviously regenerating the key invalidates all the SAS tokens that were created with that key. But with that, we've got our SAS token, so I can copy this, which I'll grab here and paste that into my command. And we'll just scroll back and check that's okay. Yep, add an extra question mark there, which we already had, so I'll get rid of that. And then what I also need to do is add the source container, in my case, test container / and then we get our SAS token after that. So if we scroll through the beginning, we've got AZ copy. We want to copy everything from AZ copy demo in the test container with this SAS token that we just generated. Scroll all the way across, and we're copying to AZ copy demo target.blob.core.windows.net in test container as well. And if you haven't already done that, you do need to create a test container in the new storage account as well. And you can do that using the command AZ copy make. In my case, I can grab this command and paste that in. And we just need to change the storage account to be the target one, in my case, so AZ copy make. And in the target storage account, I want to create test container, hit enter, and that is created. Now I grab my other command on the bottom here and paste that in, and let's see if it copies everything across. And that looks good. There's 7 pending files. They're already copied across. And if I go to the portal, select the target storage account, scroll down and choose the blob service, and you can see we have the exact same thing now in the target account in the other region. Test container inside there, 3 images here, 1, 2, 3, and our images subfolder in here as well. And we can click into one of these just to see what it is and download that one directly. Grab that there, and we should see one of our beautiful images that we used here for our demonstration. So with that, that concludes the demonstration on AZ copy. I do encourage you to go back to the website and just make yourself aware of the different commands and how to use them. You can click use with blobs here and scroll down, and you'll see a lot of examples very similar to the ones I've just gone through here with you. How to upload an individual file, a directory, how to copy from a storage account to another. Just take note of the notes sections because there are those limitations that currently exist. As you saw when we're using Azure AD authentication, I can authenticate to copy to the target, but when I'm copying from my source storage account, I do need to use a SAS token. So make sure you're aware of SAS tokens, make sure you know how to use them, and hopefully this demonstration reinforces that for you as well. And with that, that's the end of AZ copy. All right, so we've discussed a lot around the different storage types that are out there, and we've created blobs and things in the various demonstrations, but how do we control access to them? And the first one I want to bring your attention to is access policy, specifically to the container. And on the container inside of your blob storage, you can set the public access level. Now the default is private, so this is no anonymous access, nobody can access your images, etc. When things are set to private. The next one is blob, which I used for some of the demonstrations where we have anonymous read access for blobs only. And the third one is container, where we have public access for the container as a whole, so that's read access for the containers and the blobs. Now, if we go further into this, we can also get a little bit more granular with SAS, which is shared access signatures. We may not want to just generically assign permissions at the container level, so we can use this method, which is a query string that we add onto the URL of a storage resource, and this string informs Azure of what access should be granted. And we'll get a little bit deeper into the shared access signatures and how you construct them in a little while. But to go a little bit further, there's two types. There's account SAS tokens. These are granted at the account level to grant permissions to services within the account. And then there's specific service SAS tokens. These grant access to a specific service within a storage account. And it should be noted that these are all encrypted. They utilize a hash-based message authentication to keep everything nice and secure. So what does a SAS token really look like? And if we break it down, when you copy it from Azure and you say, hey, I want my SAS token, it's going to give you a very long URI. That's a unique resource identifier. And there's a couple of things to keep in mind here. So you've got your storage resource URI. So in my case, I've got slsasdemo.blob.core.windows.net. That's my storage account, my images container, and then image.jpg. That's my specific blob that I'm referencing. And then I have this giant string that's appended to it, which is my SAS token as a whole. And it helps if we go ahead and just break that piece down further. So to begin, let's start with our blob that we know we have our image.jpg. That's the first part of the entire URI. Then we have the storage service version. So this must be set to version 2015-04 for April-05 or later for it to work at the moment. That's the current as of the documentation. And then we have SS equals BFQT. Now it's very simple actually. If you look at the B, that stands for blob, the F is for file, the Q is for queue, the queue service, and T is for table. So these are the signed services which are accessible with the account SAS. Then we have SRT, in my case, equals SCO. So these are the signed resource types. So the S under SCO stands for service. So this is access to service level APIs. The C is for container, so access to container level APIs. And then finally, we have the object itself. So this could be the blob, or in the case of a table, could be the table, could be queue messages, etc. Then we go down a little further and we have signed permissions. So this is a bit of a mouthful here. We've got R, W, D, L, A, C, U, P. Well, let's break these down. So if we take the R, that's for read. So that allows us to read and essentially have read access to the object. The W is for write access. The D is for delete. The L is for list. A is for add. C is for create. U is for update. And P is for process. That's specific for queue messages. The same for update. That's specific for queue messages. If we go a little further, then we have our signed, expiry, and start. So the SE is the expiration date and time for this SAS, and the ST is the start time. Finally, we got signed protocol. So we're going to say in this case, we've got HTTPS as the signed protocol. And finally, as you can see, we have signature, which is SIG equals, and then the whole hash that we have after it. And that's really important because this is used to authenticate the request made with the shared access signature. So hopefully you can see, when you look at it as a whole, it's like, oh my God, what am I getting into? But now if you look at it, you can see, okay, this is really just breaking down. These are the permissions. This is kind of identifying what you can do on the object or what it can do on the container. And, the signature is what really authenticates the whole thing at the end. Now you might be thinking, well, that's great, but this could get a little bit cumbersome managing all of these shared access signatures that are out there. And so Azure provides something called stored access policies. And this is a method for controlling SaaS. It's a group shared access signatures and provides additional restrictions. Now, the good thing is they can be used to change the start time, expiry time, permissions, or you can even revoke it after it has been issued. It is, however, only supported on server SaaS. So for blob containers, file shares, queues, tables, etc., but not on the storage account as a whole. And you'll see how we configure that in the subsequent demonstration. But hopefully overall, this gives you an idea of some of the ways you can manage access, but check out the demo, and then hopefully that'll kind of solidify the knowledge you need for the exam here. Let's go ahead now in this demonstration and create and manage our shared access signatures. So let's head over to the Azure portal, and in the portal, we're going to use the storage account SAS demo. So we'll select that one. And in there on the left-hand side, you can see we have our access keys and shared access signatures. So I'm going to show you access keys first of all. This is very important because you have two access keys associated with your storage account. And if you want to, at any point, you can regenerate your keys. Now, the reason they give you two is because if you need to regenerate your key, you can move everything over to key 2, make sure everything's working, then regenerate key 1. Because what happens is when you regenerate your keys, all those shared access signatures that we create will no longer work. Now, if we go over to shared access signature, we can now create one for, let's say, our blob store. So we can say, okay, we want to allow services for blob, but we don't want file, queue, and table. We're going to give full permissions to the resource. And if we scroll down, now we select the start and expiration date. So hopefully you saw in the previous module description around our shared access signatures, this is where it'll create that start and end time. And sometimes it helps just to create one an hour in the past for your start time, so you know it's immediately going to be accessible, actually even further, just depending on your time zone if you're worried about that. You next have a section on allowed IP addresses. So if we want to restrict access to specific IP addresses, we can do that here. This could be a single IP or it can be a range. Our allowed protocols, so HTTPS only is the most common. And then you can see at the bottom here, we have the signing key. So we can choose to sign this shared access signature with key 1 or key 2. And as long as we don't regenerate that key, this shared access signature will continue to work. So let's go ahead. Let's use key 1. Let's generate the SAS. And if we scroll further down, you can see our SAS token and our specific blob service SAS URL. So we could grab this token now. If I hit it there, go ahead and put it into one of our images that we have in already loaded. And let's go ahead and grab that image.jpg, paste our token there at the end, and our image comes up using the SAS token that we've created. But this can obviously be a little bit cumbersome because, you know, we've got to now manage this shared access signature. Would have created 10, 20, 30, 40, 50 of these. How do we sort of deal with that? And so the policies that I mentioned previously are a great way to do this. And if we go over to Storage Explorer, in Storage Explorer, we can right-click our container and we can select Manage Access Policy. So in the section, we can create a new access policy. We can give it a name. So let's call it Images 1 Day as an example. We'll start it today. We'll end it to 24/2018 in this example. I choose the permissions again at this point and I select Save. Now, by itself, the policy doesn't actually do anything. What I need to do is when I create my shared access signature from Storage Explorer, I can reference that specific policy. So now if I go back over to the container, right-click it, and choose Get Shared Access Signature, at this point, I can drop down and select my access policy, and it's going to put in the start and the expiration time as well as the permissions that I selected in the policy, and I can go ahead and create that, and now I get that shared access signature, which ultimately is referencing, you can see there in the query string, the policy. And the good thing now is if I want to change the expiration date, I can simply go ahead and change the policy, and that's ultimately going to expire the shared access signature because it's relying on that policy. And with that, hopefully this gives you an idea of how you can control access to your containers, images, etc. using shared access signatures, but in combination with policy. The last thing we just want to cover briefly in this module is around encryption keys and Key Vault. And Key Vault is a service in Azure that you can use to store secrets and keys, etc. that you might want to use. And you could certainly take the key from the storage account, put it in Key Vault, and so when you want to access it, you open up the Key Vault, you get the key, and you use it from there. Now, for added assurance, when you use Azure Key Vault, you can also import or generate keys in hardware security modules. That's HSM. So on the bottom right of the screen on the slide here, what you see are the customer managed keys, which can be put in Azure Key Vault. They can be used to wrap and unwrap the wrapped account encryption key for something like storage service encryption, which ultimately is used under the covers for the storage account. And you'll see a little bit more about that later on. But for the purposes of the exam right now, know that you can use Azure Key Vault to store your keys, and know that it is possible to bring your own customer managed key as well. One of the other things you need to know for the exam is your ability to use custom domains for your URLs. For our storage account, we may not want it to be blob.core.windows.net as the domain suffix there. Say if I want to reference a specific blob, or perhaps I just want to be able to reference the container itself. And custom domains allows us to do this. And ultimately, you can do this for storage and CDN. So we can do it for blob.core.windows.net, or we could use it also for the Azure edge.net domain. And there are two ways ultimately to do this. At the end of the day, we're creating a DNS record with our DNS host provider that we're mapping a CNAME record there. And there's two ways, like I said, you can do your domain directly. This method is the simplest, but it results in a brief downtime because Azure has to verify the domain registration. Now, there is another way to do it, but it involves an intermediary step, and it's the use of the AS verify subdomain. So I could say take verify.skyline.com, point it to asverify.sldscdemo.blob.core.windows.net. No, that's a bit of a mouthful. But once that step's completed, you can then create a record that points directly to sldscdemo.blob.core.windows.net. But there's no downtime now because we've already verified using that subdomain. So we've used verify.skyline.com temporarily, make sure Azure kind of recognizes our domain, does all the verification, and then everything's good to go from that point of view. So you just need to know that there's two options here for the exam. You may be asked, how do you, eliminate downtime? And the answer is to use the AS verify subdomain. And, you may see a few questions on that. One of the key services in Azure right now is import and export, because there's a lot of data center migrations going on and the need to just get lots of data into Azure or out of Azure via disks instead of, say, uploading everything over the internet or via express route that perhaps you don't want to saturate. And so there's a number of use cases for import export that you need to understand. One is for data migration to a cloud, speaks for itself. So, when you want to take that data from your data center, export it onto these hard drives, copy it onto these hard drives, and then ship it off to Microsoft, and then they will import it in, to Azure onto a blob store for you, so then you can access it and move it around as you need to. Another use case is content distribution. Perhaps you've got a lot of data in Azure and you need to send it out to customer sites. That's one example there. Backing up, perhaps you're backing up your on-premises data to store it in Azure and you've just got a lot of data. Perhaps you want to archive maybe things that you sent off on tape to another site once before, and you're going to bring all that back in and now maybe ship it off to Azure for recovery in the future if you need to. And finally, data recovery, the reverse of that, perhaps I want to send that data back to recover it because I've been storing a lot of data in Azure, but now I've got a need to recover it, and so I could use the export service to get that data back to me. Now, there's a lot of components in the service itself. So one, we have the import export service, which you access via the Azure portal, and that's used to track your data import, the upload jobs basically, or track the data export. These are the download jobs to you. The next service you've got is a command line tool, which is used for preparing disk drives that are shipped, copying data to your drive, encrypting data with BitLocker, generating drive journals, determining the number of drives. That's the WAI import tool that you will find, and that's the command line. You can just download that from Microsoft. There's version 1 of that for blob and version 2 for files. And finally, disk drives themselves. It supports HDDs and SSDs. There's import jobs where you ship the drive containing your data, and with export jobs, you're essentially going to send Microsoft empty drives that they will put the data on and then send back to you. Now, the supported disks and all that information is available on this link that's on screen, and again, will be in the course material for you. Now, if we go a little bit further and look at the job workflow, which this comes from the Microsoft site that you can see the link to on the bottom left. Think about this from beginning to end. You've got this creating phase, shipping phase, transferring, packaging, and completion phase. So creating, if we think about this way, number one, you prepare the drives using the import export client tool and you encrypt them with BitLocker. Then you create a job in the Azure portal, and then you ship the drives off to the Azure data center in that shipping phase. And then the carrier delivers the drives to the data center. It's all tracked and everything. You'll see all that in the service itself. The hard drives are then processed. So this is the transferring phase now, where Microsoft is processing the drives. The data is copied from the hard drives to the specific storage account that's indicated. And then the hard drives are packaged for return shipping back to you. They packaged up, shipped to you, and you effectively have completed the service then. The export job, a little bit different because you're just basically shipping the drives to Azure first. then they transfer the data to them and then ship them back to you. But that essentially, is the service as a whole. And just make sure you understand it, know that different drives are supported, know how to get that information, and you'll probably get a few questions on the exam around this, perhaps around the use cases or perhaps just knowing how the service itself works in the portal. All right, in this section, we're now going to have a look at CDN, also known as Content Delivery Network. And it helps to think about how users interact with content around the web so we can understand how the CDN fits in. So to begin with, let's think about it as if we have a source of data. Maybe this is like a web application and people are going to a website and retrieving a bunch of images. Typically, in the case of our user here, Theodore, he would go ahead and make the request to the source, the origin, and the origin would serve up the content. Now, the problem here is that if people are across the globe, let's say we have people in the UK, Australia, South Africa, etc., we don't necessarily want them always coming back to the US to get their images and various pieces of content. So the answer to that is to use a CDN. And what we do is we put in an edge in between the source and the user. So Theodore, for example, the first time he goes to access the content, we'll try to retrieve it from the CDN. Now, the CDN doesn't have the content yet. So the edge will go ahead to the source, grab the content, cache it in the edge, and then serve it up to Theodore. Now, his current experience, if he was in, say, one of those regions across the globe, wouldn't be any better at this point. However, the next set of users that go ahead and request the content, they go to the edge, request the content, and it's served up directly from the edge. So there's multiple points of presence across the globe where this content is cached and is available to users across the globe, so they get a much, much better latency response time when they're serving up the content. Now, in Azure, you have three major offerings that you can utilize in order to take advantage of CDN. There's standard Akamai, and I'll get into some of the features of these in a moment. There's standard Verizon, and there's premium Verizon as well. And it does help to go ahead and check out this link here because there's a huge table just of all the different features available in each of them, and we'll sort of head over there in a second and kind of cover some of them. At a high level though, when you look at the offerings in the portal, you'll notice a few things that really kind of stand out as differentiating between the different services. In particular, if we look at Akamai versus Verizon, what you'll notice in Akamai is they put a lot of emphasis on this media optimization. So let's go ahead actually and switch over to the website and take a look at the table there. And here we are, as you can see on the web page, if you scroll down to the features section, you'll see this here. It specifically mentions dynamic site acceleration, adaptive image compression, dynamic site acceleration, object prefetch. Those are features that are only available in standard Akamai. And so you may be wondering what those are. So if we look at dynamic site acceleration, adaptive image compression, think of this like, most websites consist of an HTML page, which, you load it, and then it goes out and requests all of the images. So what prefetch does is it actually, retrieves the images of the scripts embedded in the HTML page while the HTML is served from the browser, even before the browser requests the object. So think of it like you may go to your favorite web page and you sign on, but immediately it's already grabbing the images while the HTML is still rendering in your page. And then the other big one here, around adaptive image compression, some devices, if you think about it, especially mobile ones, experience like slower network speeds from time to time. I know this happens to me all the time when I'm on the train, on the way to Chicago, and the network speeds kind of come and go. And in these scenarios, it's beneficial for the user to receive smaller images more quickly rather than waiting for the full resolution images to come down. So this is a great feature. If you go to a web page that supports this via a CDN, rather than you sitting there waiting for the images to load up, it's going to serve up smaller versions of those. Now, they may not look, they're not going to be as high quality, but you'll get them more frequently. The other big one is, around video. The request patterns of streaming have a lot of challenges. When you think of a popular live stream of a new series or a new video on demand that gets released, thousands and thousands of viewers might request to stream at the same time. And in this case, you need some smart, technology to really deal with that. And so the technology from Akamai, has a feature that delivers streaming media assets efficiently to users across the globe at scale. And this reduces latencies because it reduces the load on the origin servers. So if you think about your origin server having to kind of deal with all of this, you don't have to worry about that because that's offloaded to the Akamai engine that's basically taking care of that for you. If we shift down to some of the features that are kind of unique to Verizon, if you scroll right down to the bottom, one in particular, aside from some of the management and ease of use things, is this ability to use a rules engine, URL, redirect, rewrite, mobile device rules. This is something that's unique to the Verizon offering as well. And this allows you to customize how HTTP requests are handled. So for example, you can block certain types of content, define your own caching policy, modify HTTP headers. Those are things that are unique to the Verizon premium offering in particular. So when you look at these, and we'll go through in the demonstration how to kind of create a CDN endpoint in a moment, but just as you look at these, the two things to stand out for the exam are, okay, if it's optimized for media, I probably should be looking at the Akamai engine. And if I need something more around rules and redirection and blocking content, etc., Verizon just has a lot more features in that area. In this demonstration, we're now going to go about configuring a CDN and demonstrating that by the use of images that we'll store in Australia. So let's go ahead over to the Azure portal. And to begin with, you can see that I've already created a storage account called SLCDN Demo AUS for Australia. And if I go into that storage account, go into blobs, you'll see I've created a container already there for images called CDN images. Expand that out, and you can see I have a whole bunch of images in there, and they're stored in the Australia region. And I'm accessing all of this via my laptop in Chicago. So to kind of show you one of the images, first of all, let's go over to Storage Explorer. This is just a quick way to grab an image URL. So we'll grab this top one, copy the URL. I've made these all publicly accessible for this demo. And in my browser, I'm going to paste that image. And you can see that came out pretty quick, probably because it's cached in your browser. So that's something to be aware of. And if you go in and create a new in private window, we'll hit it again, and we will see, okay, it takes a little bit of time for that image to come in. It's quite a large image, and it's obviously coming from Australia. So what we can do now is go over to Azure, and let's go and create our CDN. We're going to close this window down, close this one out, back in Azure, and now let's go and create a resource. So click Create a Resource on the top left, go down to Web and Mobile, which is where you will find CDN, select CDN, and it will ask us to create our CDN profile. So I'm going to call mine SL-CDN, choose our subscription, choose our resource group. And in my case, I'm going to select SL-CDN, which is a resource group I've already created, and that resource group is in North Central. And now I need to choose my pricing tier. So I can select View Full Pricing Details, and this will bring up the differences between Premium Verizon, Standard Verizon, and Standard Akamai, as we described earlier in the module. And my pricing obviously is there as well. And if I go ahead and select, in my case, I'm going to use Standard Akamai for this demo. And finally, I have the option to create a new CDN endpoint now. I'm actually going to skip that for the moment, but let's go ahead and click Create. And in a few minutes, it should create our CDN profile for us, and we will come back to this as soon as that's completed. So as you can see in my resources now, the CDN profile is completed. Let's go ahead and select that. You'll notice a couple of things here. First of all, the pricing tier is listed on the right-hand side there, so Standard Akamai as we selected before. And then as you can see on the bottom, I don't have any endpoints currently associated with this profile. So we can go ahead and select Add Endpoint at the top. And now I need to type in some additional details for my endpoint. So first of all, we need to give it a name. So I'm going to call mine SLCDN Images Demo. And you can see there the suffix is .azureedge.net, followed by the origin type. So I'm going to be using a storage account, but you can see there you can use a cloud service from Classic, Web Apps, or a custom origin, but we're going to use storage account. The origin host name, so this asks me to select my storage account. So in this case, I'm going to select the SLCDN Demo AUS storage account we used previously. I'm not going to add anything for a path. That allows me to redirect directly to a path in the origin if I want to. And then you can see that it creates an origin host header as well for me, and protocol port 80 and 443, that's already there. This part on the bottom though is pretty key. I can optimize for general web delivery, which is what I want on this occasion. But if I wanted to, like I said earlier in the course, if we were optimizing for media streaming or video on demand, dynamic site acceleration, those are things that I can select from this menu as well. But let's go ahead and select Add. It'll go ahead and create that endpoint for us. It'll take about a minute, and then we'll come back to that once it's completed. Okay, and we can see that status is now running on the bottom there, and we have our host name slcdnimagesdemo.azureedge.net. So how do we go about proving this out? If we go into that edge, and in a second it'll pop up, and on the right hand side we have our endpoint host name and our origin host name. So let's go ahead and take an image. Let's go down to Storage Explorer, and let's take another one here. Let's take quite a large one. So yeah, 7.8 meg here. We will take this image, copy the URL, go back over to our browser, and let's create a new window and put that in. And this, first of all, we can see how long it's going to take for this image to come across from Australia. Now what we can do is just change the URL on the front of it. So if we go back to Azure, grab this endpoint host name, to copy that, go back to our image, and grab it in front, and paste over. And now we're basically saying, get me the same image, but get it from the edge, and expand that. Now the first time it does it, it still has to retrieve it from the origin, so we don't get much of an improvement in response time yet. Now I know if I just refresh it now, it's in my browser cache, so I'm going to grab that URL. Let's open a new and private window, paste it in there, refresh, and we can see almost instantaneously the images available, and that's because it's downloading from a local point of presence in my region. And with that, hopefully you can see the benefits of CDN, how they work, how you configure them, and that concludes this demonstration. In this demonstration, we're now going to take a look at Azure Files in the Azure portal, and then how we would connect our machine to that Azure file share. So let's head over to the Azure portal first of all. Okay, and the first thing we're going to do is go ahead and create a new storage account. So we'll click Add and choose our subscription and our resource group. So I'm going to choose the SL-storage resource group. Scroll down, give it a storage account name. So we'll call this SL file demo. And make sure that's not taken. There we go, got the green check there on the right. And scrolling further down, location, North Central US. We'll just use standard tier for performance here. General purpose version 2 is fine for our account kind. I can choose my replication option here. So because I'm using a file share, maybe I don't want that just to be locally replicated. Maybe I do want to use something like read access geo redundant storage, which if you saw in the other module, that's going to create 6 copies of that data and put it in other regions as well. And because I'm going to be accessing this data pretty frequently, I'm going to use the hot tier for my access method. So we'll click next, which takes us to the advanced settings. Nothing we need to do at this stage. We could put some tags in if we want to as well at this point, but otherwise let's review and create. So we'll go ahead and click create, and that gets our new storage account created. Okay, well that's created, so we'll go to the resource, which is our storage account, and in here we can create our file share. So if we scroll down on the left hand side, we will choose the file service files, and in here click new file share, and let's give it a name. So SL file share 01, and we'll give it a 10 gig quota, and it really is that simple. That is our file share now created, pretty quick. And now we can click the context menu and go to connect, because we want to connect to this file share, and it will now give us a couple of ways to connect from Windows as well as from Linux. If you scroll down there as well, it actually gives you the scripts directly in there with the keys and everything already filled out for you. So in my case, I'm going to connect by creating a PowerShell drive on my Windows operating system that I'm on right now. So I'll click this copy on the right here. If I wanted to map the drive, I could use netuse, which is this bottom option here, but the top one does a PowerShell drive. So now what I'll do is I'll open PowerShell ISE, right-click it, and run it as administrator. And I'm going to go in now and paste that script. And if we look at what it does for a second, you can see the first thing is just storing the account key that's going to access the file share. Pass in a credential object, so that way when I do new PS drive, I can reference the credential object with the account key, and that's going to connect me into that file share. So if I go ahead now and click run script, it will run that PowerShell script, and you can see it's created a Z drive for me in PowerShell. So now I can simply go to Z drive and nothing on there, obviously. It's just an empty file share at this point. But that's all there basically is to it as far as, getting a drive connected and getting access to, a whole bunch of files. And with that, that concludes this demonstration. In this demonstration, we're now going to take a look at Azure File Sync and how we can use it to cache files closer to perhaps people's data centers or regions when we have, say, a central file share. So this is a great example because you could deploy Azure File Sync on a machine running in your data center where your users will map drives to, and then it is basically archiving or tiering, I should say, files up to the Azure file share service that's running in Azure itself. Now, a couple of things to note before we jump into the demo. One is you do have this web page I highly recommend you go to. We'll put the link, in the course for you, but there are a number of prerequisites that need to be available. For one, there's region availability for Azure File Sync. So we need to have an Azure storage account and file share in the same region that we want to deploy Azure File Sync. So if we look at the region availability and we scroll down, you can see some of the things we've done in the course so far were in North Central, but that's not available. So we're actually going to use Central US, which is based in Iowa, for our file sync and file share in this case. If we go back, a few other things as well. So we'll go and create that first of all, the storage account, the file share, and then we also need to have a Windows server with an appropriate version of PowerShell and the Windows management framework already set up. I've actually already deployed a Windows 2016 server for us ready to go, so we will use that, throughout. And if we scroll down, there's a few other things that you also need to be aware of in preparation for using file sync, aside from, just turning off IE enhanced security configuration, temporarily there. There are two options to install file sync, the portal or PowerShell. We will do it via PowerShell. If we click this link here, we're basically going to grab this entire script that they give us. which just makes it far, far easier because it actually goes and downloads the file sync agent for our particular OS without us having to go clicking around, downloading everywhere. It's just going to do all that for us. So make sure you have this link ready to go before you begin if you're going to follow through in this demonstration. But with that, let's head over to the Azure portal. And the first thing we'll do is let's create that storage account in Central US. So in our subscription and our storage resource group still, we'll call it SL File Sync 01. And again, we're going to change that to Central US. Performance is fine as standard, GPv2 is fine, RAGRS if we were wanting to make sure that this had redundancy built into the storage. And I'm going to just click through the next options. No additional custom settings that we need to put in place for this one. So it completes the validation and click create. And we'll fast forward here to when the storage account is completed. Okay, that's complete. So we'll head over to our storage account. And we can see it there. We've got SL File Sync 01. And what I'm going to do first of all is the second part of the prerequisite was to create a file share. So we'll go to File Service, into Files, and create that new file share, which we'll call SL File Sync Share 01. And we'll just give a 100 gig quota there temporarily and click Create. And that's our file share created as well. Now what we need to do is go ahead and RDP into that Windows server where we're going to install the file sync service. So I've got my virtual machine ready here, SL File Sync VM01, and I'm going to connect to this one. Okay, and I'm logged into the server and server manager's coming up. And the first thing I need to do is go ahead and turn off that IE enhanced security configuration over here. Set both of those two off and click OK. Next, I'm going to open up a PowerShell client. So I went to Start, typed in PowerShell there, and right-click and run as administrator. Okay, now I just need that script that we got from the web page. And we run that script after pasting it in, and you can see it's downloading the client and we'll continue on with the installation there. So we'll fast forward a little bit here as that completes. Now once that completes, you should actually get a pop-up window to complete the installation and register with the Azure service. But if you don't get it, it could be for a number of reasons. One, you might not have the Azure RM modules installed. So go ahead and go to PowerShell. Run that as administrator. And do install module name Azure RM and hit enter there. That will install the Azure RM PowerShell modules for you. You may get this prompt to install a NuGet provider, so just go ahead and select yes for that if that's the case. And you may also get a pop-up saying it's an untrusted repository. Same thing, just select yes for that as well. Okay, and with that complete, the next thing we need to do is go ahead and start the sync agent. So we'll go to this computer, go to C drive, program files, Azure, storage sync agent, scroll down, and you'll see something that says server registration. Right click and run that as administrator. Okay, and you can see that saying sign in and register the server. So we'll click sign in. And it will prompt us for our Azure login. Okay, and now you can choose your subscription. So we can see I have my Skylines primary one. Let's go to query that now, and then we can pull the resource groups inside there. So SL-storage. Now you can see we don't have the storage sync service yet. We only created the files. So what we need to do is go ahead and create the storage sync service in that resource group. So back in the Azure portal, back into that resource group, SL-storage. And let's go ahead here and create storage sync service. It's actually under Azure File Sync, not Storage Sync. Click Azure File Sync and click Create. So we'll give it a name, SR File Sync SVC for SR File Sync Service. We'll put it in that storage resource group, and that is in Central US. And click Create. And we'll fast forward again here until this completes. Okay, and that's completed. So we have this new service, SL file sync SVC of type storage sync service, which we can click here. And we can get some details on it there and go ahead and create our sync group, which we'll do first of all. So let's give this a group name. So we'll call it Skylines Sync Group. Choose our subscription, select the storage account. In this case, we've got SL file sync. And again, that had to be in the same region. And then we should be able to select our file share that we created earlier, SL file sync share 01. Go ahead and click create now. And that's our first cloud endpoint that we have there. And now let's go back over to the server to continue. So again, we'll select here. Probably won't let us immediately do it, so we'll have to either try to go into another resource group and back in and see if that does the query again. It does, so we can do SL file sync SVC now. And here you can see we've got our subscription, resource group, and our file sync service. Click register. Sign in again here. Okay, and you can see registration is successful. You have now established a trust relationship between your server and the selected storage sync service. To manage the server and set up sync, use the Azure portal or PowerShell now. So we can click OK and close these down. Okay, and next I'm going to go back over to the Azure portal, and in here I'm going to create what's called a server endpoint. So I click Add Server Endpoint, and this is all within our sync group, and I can choose that registered server SL file sync VM01. Choose a path, so I'll choose dcolon, which is the temporary drive on that Windows server, and we'll call it Skylines. And I can choose whether or not to enable cloud tiering, so that'll tier files off to the cloud, when space becomes low. And with that, I'm choose disabled, I'm gonna click create, and this will take a little bit of time, probably a couple minutes or so, but essentially it's setting up the sync between the server endpoint and the cloud endpoint. And while that's going, we can actually go over to the server, go to this PC, look at the D drive, and very shortly we should see that Skylines folder appear here. There it is. And what we can do now is take some images that I've downloaded already. These are just some pictures from the internet, so I'll grab these, we'll get them ready, and as soon as everything is completed, we'll drag those into the Skylines folder. But we're still waiting for the health to go green, so we'll just wait here until that's completed successfully. Okay, and after a while, that's all completed successfully, and we can see that everything is healthy now. Let's go back over to our machine, and here we are, and let's take our image sample, grab all of these, and throw them into the Skylines folder. Everything is copying across there. If we go into Skylines, we'll see all those images. And now, if we go back over to Azure, and we look at this file sync share 01, we'll click this one, and click SL file sync 01. This will take us to that file share that we created earlier on. And that's the storage account. If we scroll down and click Files, we should see our file sync share 01. And there we can see all of those image files are now in that file share as well. And so the point of this is that you can essentially have a file share located on a server that's syncing up to the cloud, but any changes are instantly accessible. If you lost that server for whatever reason, something went wrong, everything is available for disaster recovery. You could set up another Windows server, create it as another server endpoint, and Azure will sync those files back down to the endpoint. And with that, that concludes this demonstration. Before we get into the specifics of Azure Backup and Azure Site Recovery, it's worth first understanding the different business continuity strategies that are available. So the first one is high availability, and we talked a little bit about this in the virtual machines module. This is really the case where we run another instance of apps in the case of a catastrophic failure. So maybe a blade on the first rack of servers goes down, and we've got an availability set configured for our virtual machine. Well, that will fail over to another set of hardware. That's basically our high availability option. In addition, we have disaster recovery. This is where we run our app in a second data center so that if a failure occurs to the primary, the secondary is still online, the app will still continue to run. We might get a blip for some users that were connecting to that primary system, but through the load balancing technology, they would be rerouted to the secondary node. And then finally, we have backup itself, and this is where we want to restore data. So we might have our original set of data that's constantly being backed up, and then if something goes wrong with that data, we can restore it, or perhaps we want to restore the entire virtual machine. Perhaps in response to a disaster like the previous option, we could then just do a standard restore of that machine. Now, Azure Backup in particular is one of the products Microsoft provides you in Azure, and this is a backup solution that's been purposely built for the cloud and comes with a number of features. In particular, we've got unlimited scaling. Azure Backup will use the underlying power and scale of Azure Cloud to give you high availability, no maintenance or monitoring overhead. You can set up alerts, but there's no real overhead from your perspective to kind of scale up the system. In addition, you get unlimited data transfer as well. So Azure Backup does not limit the amount of inbound or outbound data that you can transfer, does not charge for the data that is transferred. However, if you decide to use some of these import-export services to import large amounts of data, then you might incur some costs at that point. But otherwise, it's a very cost-effective service to utilize. We also then have the multiple storage options as well. So it supports LRS and GRS. If you recall from the storage module, LRS is locally redundant storage. This is where it replicates your data 3 times in a storage scale unit in a data center. Or we can use GRS, which is geo-redundant storage. And this is the default and recommended option because it's basically taking your data to a secondary region. This is hundreds of miles away from the primary region. Costs more than LRS, but if a whole entire data center or region goes down, then you can still recover your data via the other region. Then we have long-term retention, so there's no limit to how long you can keep your data in what's called a recovery services vault that you'll learn more about. You can keep it as long as you like, but you are limited to 9,999 recovery points per protected instance, but that should be plenty for almost everybody's backup situations. Then we get application consistent backups. Now, I would say that Azure advertises this, but it does depend on which service you utilize, and you'll learn about the different services in a moment. Otherwise, they'll be crash consistent if you're not using any of those services in particular. And finally, data encryption, naturally, like a lot of other Azure storage services, is supported to allow for secure transmission and storage of your data in the public cloud. So let's take a look at the Azure Backup components that are available to you as well. Well, first of all, we have the Azure Backup Agent, also known as the Mars Agent. This allows for file level restore, system state restore. It's not really a VM backup, but you'll see this in one of the demos, but allows for file level kind of recovery of services for you. Then you have a couple of others which require servers. So you've got System Center DPM and Azure Backup Server. You might be using System Center DPM already on premises, and you can utilize that with Azure Backup. Azure Backup Recovery Services Vault would essentially become a target for DPM, and DPM stands for Data Protection Manager. It's a service a lot of people have been using for a long time. There's Azure Backup Server, which you can install on premises or in Azure as well if you like. And then finally, Azure does include an IaaS VM backup, which you will see in the demo as well. In fact, the course really calls for the first and the fourth option here. So we'll look at the Mars Agent recovery and the IaaS VM backup recovery in the subsequent demos to follow. Now, if you want to know about how all these different options compare, because it can get very confusing, simply head over to this link, which I'll select. And if you scroll down, you'll see a table, which I'll zoom into. And it says, which Azure Backup components should I use? And it breaks it down by the various options. So for the Azure Backup Mars Agent, what are the benefits? You can see it backs up files and folders. It's limited to Windows only, backup 3 times per day, and backups are stored in Recovery Services Vault. Scrolling down, you can get the details of DPM and all its extra features, Azure Backup Server and all its extra features, and then finally the IaaS VM Backup as well and all of its features. So it's a good reference site if you're trying to figure out, well, which is the right option for me. But like I said, you'll see us demo the first and the fourth option coming up very shortly. Now, before we get into those demos, the last thing just to mention is a couple of the other recovery options. I already mentioned we've got Azure Site Recovery, we've got Azure Backup, but there are 2 other options that you can utilize as well. First one being Snapshot Recovery. So Snapshot Recovery utilizes the underlying blob storage. You can essentially do blob snapshots taken of your VM page blob. These can be copied into the same or different regions. You can create a storage account in another region and copy your snapshot across to it. And then you can basically get your VM from that snapshot. You create it from the snapshot itself. It can be application consistent, but only if the VM was shut down. So if you shut down a VM gracefully, take your snapshot, copy it to another region, instantiate that VM, it will be application consistent. Otherwise, it's essentially a crash consistent recovery option. The other option we have is geo-replication, and this essentially allows us to use the underlying Azure storage GRS option, geo-redundant storage, which basically replicates our data to a region far away from the primary. And this allows us to then recover in the event of an outage to the entire region, or if we just had an outage and we wanted to recover from that data that's been replicated over there. It also has that RA-GRS, that means it's read available, read access is the official term. There's an RA-GRS option available, so if we wanted to, we could just take that geo-replicated virtual machine as an example and power it on in the other region it's warm and ready for us to go, or if we just wanted to read some of the data, we could do that as well. So these are two other options, a little bit more manual in operation. They're not really automated recovery options, although it is technically possible to do some of that with Azure Automation and PowerShell, but this essentially is more of a kind of a manual recovery type option. In this demonstration, we're now going to go about configuring Azure Backup, and then we're going to backup and restore a Windows VM. So let's head over to the Azure portal to begin. Alright, in the Azure portal, you can see I've already created a virtual machine, SL Backup VM01. This is just a Windows 2016 VM that we're going to use to simulate our backup a little bit later on. Nothing special yet, just a VM we've built from the marketplace. So to begin, let's go ahead and create a resource and type in backup, and we get backup and site recovery OMS. Select that one. And this is where we can create our recovery services vault. So we go ahead and click create, and we'll give it a name. So we'll call it SL-recovery vault. Choose our subscription, choose our resource group. So I'm going to use SL-recovery for this one, and then our location, which I'm going to put in East US for the purposes of this demo, and that's also where I put my virtual machine. So go ahead and click create. This sets up the vault for you, and it's pretty quick. Should only take a few seconds, hopefully, to complete this. And that's completed. Let's go ahead to that resource, and we can see our recovery services vault, and currently nothing is being backed up because we obviously just created this vault. You'll see on the top that we have these options for backup and replicate. So we're going to do backup first of all. You'll see replicating some of the site recovery options later on as well, but go ahead and click backup, and once you're in there, you'll see the first option is where is your workload running. So you get to choose between Azure or on-premises, and I'll just show you the on-premises options quickly. We're going to use one of them in the other demo, but when you choose on-premises and you select, okay, what do you want to back up, if it's files or folders, select that and click prepare infrastructure, you'll see that you get the option to download the recovery services agent. That's the Mars agent that I mentioned in the tutorial section, and then vault credentials and various other things that you'll see in the upcoming demo. But if we select this drop down again, you can see if I select like VMware virtual machines and click prepare infrastructure, you'll see I get options here for using System Center DPM or Azure Backup Server. Also mentioned both of those in the tutorial. We're not going to cover those in this course, but it's worth just knowing that those options are there if you need to get to them, because Microsoft will expect you to know what the different recovery options are. So hopefully this makes it more visual for you. If we go back though to virtual machines, so we go to Azure and then select virtual machine because we want to back up our virtual machine that's hosted in Azure. Click backup, and then we get onto the next section, which is to choose our backup policy. So there is a default policy which backs up daily at 2 p.m. and a default retention range. But if we go ahead and select this drop down, you can create your own backup policy. And this is one of the things I actually love about Azure Backup, because it's made backup very, very simple for us. You know, I can go in here and choose a policy. We'll call it SL policy, and then I can choose my backup frequency. So maybe I want to back up at night instead. So we'll go down to, like, you know, maybe 10 p.m. Make sure to set your appropriate time zone, obviously. So if we go to Central Time as an example, so 10 p.m. Central Time, so in Chicago that would be backed up, and then I get my different retention ranges as well. So you can see there, you know, at 10 p.m. it's going to keep 180 days of that daily backup point. Here's my weekly backup point. We're going to keep that for 104 weeks, and I can choose to toggle this on or off if I want to. So if I don't want to configure retention of that weekly point, and I'm good with just the dailies and the monthly that comes in, that's fine, but I can keep that weekly so I know that's there. Same for the monthly all the way down to year. and I can click OK once I'm happy with that. And then we go into the items to backup. So I've only got one virtual machine running right now, so I'll select that one, select the virtual machines 1, select OK. It'll validate that, and then you basically enable backup. And that'll take probably a minute or so to complete, and we'll begin backing up at the next cycle for you. So if we go over to that, I'll just fast forward here for a moment and head over to the virtual machine. Okay, so yeah, we're on the virtual machine. I'm going to scroll down, and you'll see that you have an option under operations called backup. Simply select that, and you will see that this VM is now under backup via Azure Backup. And you can see that it's past the backup pre-check, but there's an initial backup pending. And if we want to, we can go ahead and simply select backup now. You can see that you also have the option to stop backup if you want to remove it completely from backup. We'll go ahead and select backup now. And we'll retain that one, whatever date you want to give it, simply select OK. And that's going to trigger the backup process and back up that virtual machine. So again, I'm going to fast forward here. That's going to take a bit of time for it to complete the backup, and then we'll come back to it when it's completed. Alright, so as we can see on the backup job screen, the backup for SL Backup VM01 was completed. If I go back up to the virtual machine, so we'll head back to SL Backup VM01, and you can see there backup status, last backup status, success, and you can see at the bottom there also that it's in an application consistent status. Now, if I want to, I can choose to recover the whole VM, so I can click Restore VM, and this is where I choose my restore point. So I'll select that application consistent restore point, select OK, and then I can choose how I want to restore that virtual machine. So I have a few options. I can restore the disks, or I can create a virtual machine. So I can give it a new virtual machine name. So I can call it SL Recovered VM. Choose the resource group. I can put it in the same resource group if I want to, same network, etc. Go ahead and select OK. And then click Restore. And that will now begin restoring another copy of that virtual machine. So the original one is still running, but we're restoring an additional one with a different name. Now I can also, if I wish, do file recovery on that virtual machine. So I can select file recovery, grab this, select my restore points. Again, I've only got the one that I just did recently. And then I can download script to browse and recover files. So I can click this download this executable. And then I essentially get the script that I can open up. I'll just save it on my desktop for the moment. And open folder, and essentially it's an application file that you can run inside the virtual machine you are backing up, and it will mount essentially the file system from that machine. And just like you'll see in the upcoming Mars Agent demo, it essentially mounts a drive for you, and you can then browse the files on that machine itself. But we'll go back to the portal here for the moment, and we'll come out of the section, and we'll go ahead and look at the job for recovery. So if we click View All Jobs, we can see that restore job is in operation, and we'll come back to that when that's completed. Okay, and after a while, looks like this one took about 25 minutes. That restore has been completed. We can select that job, and on the right hand side we can see, if we scroll down, we transferred data from the vault and it created the restored machine. If I scroll back up, I can see that target VM name is SL-recovered VM. So I can go ahead and go over to my virtual machines, and I should see now that I have a recovered VM. There it is, SL-recovered VM, and that essentially is my restore of the SL Backup VM01. So the same as that Windows 2016 image that I created from the marketplace, we've just done it now as a recovery instead. So hopefully that kind of makes it clear how easy it is to back up and restore in Azure, particularly IaaS virtual machines. It's super easy to get up and running again, and that concludes this demonstration. In this demonstration, we're now going to go about configuring the Microsoft Azure Recovery Services Agent, also known as the Mars Agent, to do some file level recovery from a local desktop machine. So let's head over to the Azure portal to get started. Okay, so we're in the Azure portal, and I've still got my recovery vault set up, SL Recovery Vault. I'll select that one. Go ahead and select Backup at the top. And now I'm going to choose that my workload is running on premises. I'm actually going to use my local laptop for this example, and I want to just back up my files and folders up to Azure. So if we select that and then click Prepare Infrastructure, we'll get the option here, first of all, to download the Recovery Services Agent. So let's go ahead and click that. That'll just download locally to my machine. Then you also need to download Vault credentials to register the server to the Vault. So these are credentials that will expire after 2 days, but are needed as part of the installation for the Recovery Services Agent. So let's go ahead and download those as well. Okay, and both of those are downloaded. So I'm going to open up my downloads folder, and you can see I have my Mars Agent installer and my Vault credentials. So I'm going to go ahead and double click the Agent installer. And as you can see, that sort of does its installation process. And then you get your usual like Microsoft installation, questions that you get. Where do you want to install it? Where do you want cache location? So we'll go ahead and select next to both of these. We'll accept the defaults. We'll accept the defaults for the proxy configuration. We're not going to go through an internet proxy. We'll opt into Microsoft Updates and go ahead and install. And that'll take a few minutes. We'll jump ahead here until that's complete. Okay, and once complete, you go ahead and select Proceed to Registration. And this is where it asks for those Vault credentials. So we go ahead and select Browse, go to my Downloads folder, select Vault credentials, validates them, go ahead and select Next. Enter a passphrase. You can simply generate one if you prefer, so you can do that. And enter a location to save that passphrase. So I'm just going to save it on my desktop for right now. Go ahead and click Finish. And that now registers this local machine. This is just a Windows 10 desktop I'm on right now, and it's registering with Azure Backup. Okay, so now that's configured and registered with Azure Backup. We go ahead and select Close. You'll see the checkbox is already selected there, so it's going to open up the Recovery Services agent. As soon as I click Close, here it comes. It's going to load up the policy information, check for updates, and now I simply need to go ahead and schedule backup. So on the right-hand side, I can click Schedule Backup. Wait for it to get policy information, and let's go through this wizard now as well. So hit Next to get started, and now I can add my items. So I can click Add, and let's say I want to back up my whole C drive, I can, or let's say I just want to back up, what's in my Downloads folder. So let's just take that as the example. So I'll go to Users, Myself, and I'm just going to take my Downloads folder for right now. Just got a various, downloads that I've done over time. Go ahead and click Next. Select your schedule, so day or week. So I can do 10 p.m. today if I want to. Select my retention policy, so I don't really want a weekly, monthly, or yearly retention, so I can uncheck those, but I could configure those if I wanted to. If this was a full server environment, obviously I would want that. Select Next. I can choose this option of automatically backing up over the network or offline backup, but I'm going to choose automatically over the network, but there are options there for offline backup as well. Go ahead and click Next and click Finish when we are done, and it's going to go ahead and create that backup schedule for all of those download files basically. So go ahead and click Close, and if I look now, I can see on the right hand side I can back up now. So if I go ahead and select that, go ahead and click Backup, and you'll get a status update here, and it will basically begin transferring all of those files in my Downloads folder up to Azure. And now if I ever want to recover them later on, I basically can. So we'll fast forward here until this is complete. Okay, and that's successfully completed, so let's close that screen down. And now if I want to recover data on the right hand side, if I select that, you can see that I have an option to recover to this desktop or another server. I can select Next, I can choose individual files and folders, and now it will fetch those volumes that have been recovered. So if I select the volume, it was on my C drive, it's got a recovery point. I'm going to go ahead and mount that. Okay, and that's mounted it as a disk, so I can go ahead and select Browse, and you can see it's mounted it as my D drive on this machine. Click Browse, can open up that users folder. You can see my user account and Collie. Double click that. There's my Downloads folder, and in there should be my two files, my Mars Agent installer and my Recovery Vault file as well that was in there. And those were backed up to Azure, and I basically brought them back down using the Mars Agent recovery feature. And with that, this concludes this demonstration, but I hope you also can see how useful this can be if you've got files and folders on your machine that you want to back up to Azure and keep them in the cloud. This is another way that you can utilize that. Right, with all those intros out of the way, let's dive straight into the meat now. And let's just take an introduction to virtual machines. For anybody that's not familiar with virtual machines, it helps to just think about how your computer operates, right? So you have some hardware, you have CPU, memory, and disk. And on top of that, you have your operating system. So this could be Microsoft Windows, could be Mac OS. And on top of that, we obviously have our applications that we install. Well, along came virtualization many years ago now, and the concept is still very similar. We still have our hardware, so we still have to run our application somewhere, and we have our CPU, memory, and disk, but we install something in between, which is the hypervisor. And on top of the hypervisor can live multiple operating systems with multiple applications. So instead of just running one operating system that may only get used 10% of the time, we can run multiple operating systems, make much more use out of that CPU, memory, and disk. And every single one of these is essentially our virtual machine. And when we're in Azure, we're basically doing the same thing. We don't manage the hypervisor on premises. You would typically manage something like VMware ESXi or Microsoft Hyper-V, but in the public cloud, Microsoft presents us with a whole bunch of options for provisioning our virtual machines. And that leads us onto a really, really cool thing, which is all of the VM types available to us. Typically on premises, we would have, one or maybe two different variations of host, and every time Intel releases a new CPU, we would upgrade those hosts. But in the public cloud, because, just the scale that they have, you have multiple choices available to you. So if we go through this, it's very important to understand and select the right instance type for your workload. The A series were the very first series that Microsoft introduced. They're divided up into basic and standard. So standard are actually our general purpose VMs, and then there's a basic version of the A series for testing and development. Then we get on to B, which I remember as B for burstable. These instances can burst to the full capacity of the CPU when needed, but you get a discount because you're not using the machine a lot of the time. So it's storing CPU credits, and then when it has to consume CPU, it can use those credits and use the full capacity of the CPU. Now, if you're going to use the CPU continuously, it's obviously not going to make sense because you're not going to store any credits, and you're going to get worse performance. But a very cost-effective option, and I highly encourage people to use them during some of the labs and things as well. D is the general purpose ones. You'll see a lot of these around in the enterprise. And then we have memory optimized. These are the E series. You'll see there's some other memory optimized ones out there. This is the newest memory optimized series they brought out recently. This is a high memory to CPU core ratio. Then we go into the F series. Immediately after memory optimized is CPU optimized, and this is the reverse. So we have a high CPU core to memory ratio, and so it's kind of the opposite of the E series there. The G series, Microsoft calls this the Godzilla. At least that's what people tell me when I'm walking around, Microsoft Ignite in various conferences. Very large instances, hence the Godzilla name there, for large databases, big data use cases. Then we got high performance compute, computational, molecular modeling, scientific applications. That's the H series. The L series is for storage. I remember this as L for LUN, like in the traditional sense of storage. And these are, storage optimized with a high disk throughput and high I/O. Then we got the M series, another very large memory series available. These go actually much, much larger than the E series. You can go up to 3.5 terabytes of RAM here. Then we have the N series. They're actually divided up into NV and NC, depending on the type you choose there and what configuration you require. But these are graphics card enabled instances. And finally, we have SAP HANA on Azure certified instances as well. So as you can see, just a ton to choose from that. And then we go into the specialization. So if you just got your head around, okay, I've got all these types, well, now there's different specializations, and you notice this in the way the instance types are written out. So for example, we've got S for premium storage. So if you see D series, you'll also see a DS version. So DSV2, that's a premium storage option there. We have the M specialization as well. That's for larger memory of a configuration type. So if, for example, we've got a standard A2, then you might see a standard A2M that just has more memory. And then the final one, we have R, which is supports remote direct memory access, also known as RDMA. And you'll see that by things like H16MR as well. All right, so we have all of these various types and specializations, but how do we actually compare the CPU performance differences between the different types? We know some might have more CPU and more memory, but what do those cores actually equal in terms of actual performance? And so Azure Compute Units, also known as ACUs, are a way to compare CPU performance between different types and sizes of virtual machine. It's a Microsoft created performance benchmark. So they took one of their A series virtual machines and started it at 100, and then equate all your different other instance types to that one. And so essentially you can say, look, a VM with an ACU of 200 has twice the performance of a VM with an ACU of 100. And a good way to really look at all of this is to go to the OS reference documentation for Windows virtual machines or Linux virtual machines, and Microsoft will actually list all of these out for you. And these are actually great sites, just from a deployment aspect and revision for the exam. Highly encourage you to check them out. And if we go to the Windows one here, what we'll see as this pops up is a section called concepts in here. If we expand that out, you'll see VM types and sizes, but if you scroll a little bit further down in types and sizes, you'll see Azure Compute Units here. And if we expand this out, you can see here, the SKU families, A0, A1 to 4, and you can see here's the ACU number. So if we compare, say, anything in the A1 to 4, A5 to A7, these all got at 100. And if we go down to something, like a DS1, V2, the performance there is going to be 210. The other thing to note is, this 2-to-1 ratio that you'll see on the V3s and the DV3s and the EV3s. And this is because they are now hyper-threaded. So, for example, a DV2 might give you, 210 to 250 on the ACU number, but when you go up to the V3, you're actually getting less performance. So it's just something to keep in mind, as you start to, invest in your instance types in Azure. Definitely, compare these so you know what you're actually getting. Don't just go by the pricing calculator if it's something that you're doing that depends on CPU. Next, we need to cover one of the key parts of the curriculum as well, which is identifying supported workloads on Azure. And we'll start with the Windows ecosystem. If we look at the OSs first of all, and we look at pre-Windows 2008 R2, so these are things like Windows 2003, they are supported for deployment. However, you must bring your own image, and there's no marketplace support at all. And you also need to have your own custom support agreement. Microsoft's not going to give you any type of support for Windows 2003, via Azure. When we get to Windows 2008 R2, that is supported. However, there's a specific support matrix for server roles that you want to check. So just because Windows Server 2008 R2 is the OS is supported, you do need to check the matrix of server roles that you're going to install on top of the server and check that those are supported. Things like Windows Server 2012 supported. There's actually a data center version in the marketplace. Windows Server 2016 is supported. There's a data center and a nano version in the marketplace. And for desktop OSs, those are supported for Windows 10 Pro and Enterprise, which are available in the marketplace. And there's another link here that's very, very useful. And if you click on this one, it'll actually also give you details of other Microsoft Server software that's supported on Azure. So it goes beyond just the operating system. And if we scroll down a little bit on this web page, we can see things like Microsoft BizTalk Server, Microsoft Dynamics CRM. So within the Microsoft ecosystem, Dynamics CRM is an example. 2013 and later versions are supported, and they list these for a whole host of things. It's very common to run Exchange, which is supported again for 2013 and later if you're not using Exchange Online, and there's some other options here as well. So this link will give you any other information you need around the specific workloads that are supported. But for now, at least for the curriculum of the exam, you may get asked on these variations, but for the most part, I'd say just revise the operating systems and you should be good to go. As far as Linux supported distributions go, all the major ones are pretty much accounted for here. So we have CentOS, Debian, Oracle Linux, Red Hat Enterprise Linux, SUSE Linux, etc. And another link here you can go to if you need to check, what Linux distributions are endorsed. We hit this link here, we can see it takes us to this page, and all of the current supported Linux distributions are here. So currently for Red Hat, it's 6.7 plus and 7.1 plus. So try to remember those. CentOS 6.3, 7.0, and SUSE 11 and 12 are supported as well. All right, so we might be thinking we've got our types, our various supported OS distributions. Can we do it anywhere? And the answer, unfortunately, is no. There are, in fact, regional limitations on services in Microsoft Azure. And the screenshot here, I'm just showing the various compute products that are available in the various regions. And if you just take a look at this, look at the B series as an example. It's available in East US and West US 2 only at the time of recording this course. A8 to A11 instances, only 4 regions those are available in. And so this is important to know. Just because you decided, hey, I want this particular type of instance, you need to make sure it's actually available in your region, because you're not going to onboard every single region necessarily to your organization. In addition, it's worth understanding region pairs. So East US is paired with West US, and what that means is when Microsoft does their patching, they will patch one of those regions, then the other one. They won't do those at the same time. If you don't use region pairs, and let's say you went North Central and East US, they could be patched at the same time. So in the rare event that there is an outage, you could have a global outage to your Azure infrastructure if those are the only 2 regions that you use. So it's worth also keeping in mind the region pairs as well. And finally, before we get into the demos, the last thing you just need to be aware of is restricted usernames that you'll see when we go into the demo as well. So, here is a general list, things like administrator, admin, user. A lot of this is common sense. You can't use these for your VM usernames when you create your Azure VMs. In this demonstration, we're going to look at creating a virtual machine from the Azure portal. So let's head over there to begin. And here we are in the Azure portal, and one of the things you might notice if you have built virtual machines before is things have changed a little bit over time, and Microsoft continues to change this part of the portal. But we can go ahead now and click virtual machines and see I've already got one virtual machine there. That's just a Linux virtual machine I've got running. I'm going to add another one. We're going to build a Windows virtual machine at this point. So I'm going to click Add. And straight away now you get the Create a Virtual Machine panel that pops up, and you'll see they've added these tabs now across the top to make it easier to go forward, come back, throughout the process in itself. If we go through though, click Subscription, you would choose your subscription that you want to provision this virtual machine into, and then choose the resource group that you want to use. Now I've already got a resource group created called AZ-Demo where VM01 is currently in, but I'm going to add another VM to that resource group, so we'll continue to use AZ-Demo. I now need to give it a virtual machine name. So in my case, I'm just going to call this VM Demo 01, and now I need to choose the region, so I can choose any of the Azure regions that I'm entitled to provision into. In my case, I'm going to choose East US, and next we have the availability options. Now if I click this, you will see that sometimes we will get availability zone, sometimes we will get availability set. So availability sets were covered in one of the lectures, and if you haven't jumped to that yet, feel free to jump ahead to availability sets. Availability sets are inside the same data center, but allows you to have two virtual machines in separate racks of power and network connectivity. Availability zones are in the same region, but they're in separate data centers in themselves. So it's another way to get additional redundancy. Now, Microsoft is rolling these out gradually to all the regions. If you click this icon, it's blurred out a little bit there, but you can click the little blue thing that says view locations that support availability zones, and then you can choose those. But definitely encourage you to understand the differences between availability sets and availability zones, because Microsoft is really emphasizing availability zones going forward. Next, we choose the image. So I'm going to choose from a Windows or Linux image here. These are all the standard ones available to you, and I can choose Windows Server 2016 directly from this pane. Now note, if I wanted to see all the images, I can click Browse All Images and Disks. That will show me everything available to me from my marketplace, but in my case, I'm just going to do a 2016 data center server. Next, we move on to the size, so I can click Change Size here, and this will give me all the different VM sizing options available to me, and I can do various filters on these. I can get rid of these filters if I want to. I can add additional filters. Right now it's looking at general purpose with premium disk supported, small sizes right now, so that's why I'm only getting a handful right there. If I got rid of the small, it's going to certainly open it up to a lot more sizes that are available to me, and in some cases your subscription may just not support that, or perhaps you've also got a policy in place that doesn't allow you to choose specific VM types. But in my case, I'm going to go back up and I'm going to choose one of the B1s. I'm going to choose the B1 MS. That option there, that's a 1 CPU, 2 gig of RAM, supports 2 data disks, got a max IOPS of 800, includes a temporary storage drive with 4 gig on it, and it's using premium disks. And on the right, I can see my cost per month would be $15.40 estimated. Now, one thing to note with the B series, as you probably heard about when we did the lecture on VM types, the B series does use the concept of CPU credits. So when you do provision them up, they can take a little bit longer to build. The purpose of B series is really for web servers, so that, when they're not in use, they're generating credits. When they are in use, they're consuming from those credits, but you don't want to use them if you're running things at 100% all the time. However, they are very cheap to run for lab purposes. You've got like the B1S here, smaller memory version. You've got the B1MS, which is that double memory version of the B1, much cheaper to run, for the purposes of your lab. But again, they take a little bit longer to provision. But if you select one, then go ahead and click select, and then that takes you on to the next section. So now we need to include our administrator account. And you'll notice that things like admin aren't allowed. That's a restricted word. If I go back and I just type in, say, my name, that is allowed, and we can move forward with that. And then you can go ahead and type in your password. This is the Windows password to get into the machine. Once we've got all that typed in and the passwords matched, we can then move on to the inbound port rules. And this section is pretty important because if we want to RDP into the machine, say over the internet, we do need to expose that. So we can allow selected ports and we can choose the ports that we want to expose. So perhaps RDP is one I want to expose. This is great that they added this. Things aren't just open by default. You have to choose to allow those inbound ports to be open, and you can further lock them down using Azure Security Center and just-in-time access as well. But for right now, just go ahead and select RDP if you do plan on connecting into the machine after you've deployed it, which you'll need for some of the subsequent demonstrations that we do. One thing to note is the one difference between Windows and Linux here is in Linux we could be prompted to generate a key and put that in here, or we could use a user account. Windows, we just use username and password for the administrator account. If we keep going down, the next thing we have is save money, which is save up to 49% if you already own an Azure license for that Windows server. So if you already have one, simply select yes and choose your license type. You have to confirm that you have software assurance for that, and that will reduce the cost that you pay for those Windows servers. So this is a great benefit. If you've got a lot of Windows machines that you move into Azure, you will get a cost benefit by already having that software assurance. But in my case, I don't, so I'm going to click no, and then move on to the next panel, which is the disk section. So we have our disk types, and as you can see, this machine, because it is an S series, does support premium SSD as well as standard SSD and standard HDD as well. I'm going to just go ahead and choose premium SSD for my disks there, and then I can choose if I want to create and attach a new disk or attach an existing disk as well. So perhaps I deleted a machine, but I left behind a virtual hard disk that I want to attach to this machine. I could do that there. If I wanted to just go ahead and create a second disk, and here you can see I can choose my disk type. So if I want to use a different type to the one I used for the primary disk. So remember right now I've got that OS disk that's on premium SSD. I also have that temporary disk that's on a local disk associated with the host that the virtual machine runs on. So that has specific use cases where I want fast access to a locally cached disk. And then this disk, again, I can choose SSD, premium, standard SSD, or standard HDD. In my case, I'm just going to choose a standard HDD right now. Choose the name of that disk. That's the Azure name for the disk, not the name inside of Windows. the size, and then the source type. If I want to choose a snapshot or a blob that I already have of a VHD, I can do that. But in my case, this is just going to be an empty disk that I attach with this virtual machine. With that, I click OK. And then we scroll down a little bit further, and then I can move on to advanced pieces as well. So if I want to use manage disks, the default now is yes, that's what we always recommend. But if I wanted to manage the disks myself, I could choose no there if I wanted to. Next, we move on to networking. And in networking, first of all, you're going to see details around the network interface. So when you create a virtual machine, a network interface card is created for you and is associated with the virtual machine. I choose my virtual network that I want to connect this virtual machine to. So again, I could create a new virtual network or just connect it to a virtual network I already have. In your enterprise, you'll probably have a scheme of networks and subnets that you want to utilize. Choose the subnet. In my case, I just have the 10.0.0.0/24 subnet that I'm going to use, and whether or not I want to create that public IP. So I can click here. By default, it will prompt to create it, but I could choose none if I don't want the public IP. So perhaps I'm connecting through my VPN or express route from my data center that I have, then I wouldn't need a public IP to access the machine, or perhaps I'm using a point-to-site VPN connection to get into the virtual network in Azure. Again, I wouldn't need a public IP, but in my case, I want a public IP so that I can just RDP into it, because this is an isolated Azure environment and I'm not connected in via any VPN or express route connection. Then we come across NIC network security group. So again, on a subnet, I can have my network security group and I could just rely on the rules there, but I could also have a network security group associated with the network interface card of the virtual machine itself. Now I can choose not to. If I choose none, you can see that it says all ports in this virtual machine may be exposed to the public internet. This is a security risk. So obviously highly recommend you at least choose a basic one and then choose which ports you want there, or you can choose an advanced one. It takes away that basic option for you there, but you would then configure that network security group more specific to the rules that you want. In my case, I'm going to choose basic. I'm going to choose allow selected ports and select RDP as we previously did. Next, we have an option of accelerated networking. Now, accelerated networking is only available on certain instance types and certain operating system versions. So perhaps you've got Red Hat 7.4 and you wanted accelerated networking. That is available on that machine on specific D-series versions of the instance type. And that allows faster networking between virtual machines that have accelerated networking enabled. Essentially, it bypasses one of the virtualization layers and goes directly to the NIC card and just gives better throughput all around. So that's when you would use accelerated networking. Next, we have load balancing. So if we want to, we can place this virtual machine in the backend pool of an existing load balancing solution. In our case right now, we're not looking to do that or load balance this with other virtual machines. So we will move on to the management section. So under management, you can see here we have a few things. First of all, we have boot diagnostics, so we can opt to turn these on or off. And generally, we just keep them on because it helps us diagnose any problems in the virtual machine. We have OS guest diagnostics. If you covered the monitoring section earlier on in the course or in some of the other videos we have, this is where you can turn on those guest level metrics, or you can just keep them off and just rely on the host level metrics from Azure. And the diagnostic storage account, which is where the diagnostic logs associated with those two things are going to be stored. It will create one for you if you don't specify one. For identity, as will be covered later on in identity, you can assign a system managed identity, automatically for you. And then we have things like auto shutdown. So enabling auto shutdown is something I always recommend you do in your lab environment. Turn it on, choose the time, whatever time zone you're basically in. So in my case, I am in, Central Time right now. So, got to go back the other way. So let's go to Central Time. US and Canada, and at 7 p.m. this machine will basically shut off automatically, and that will save me costs in my lab, and I can choose to notify before shutdown or not if I want to. Next, we have backup itself. So one of the fantastic features about Azure is you have backup built in, and it's as simple as clicking enable backup, choosing your recovery services vault if you have one, or creating a new one right now, and choosing a backup policy, and there's already some of those already built in for you. So if you do want to back up your virtual machine, all production machines, you should have this turned on by default, especially if you aren't using some other third-party backup solution. But for purposes of the lab, I don't need to back up this machine, so I'm going to turn that off and then move on to guest config. Now, guest config is more focused around things like PowerShell DSC extensions, Chef, Puppet, etc. They're not something we're going to cover right now, but you will see them in a separate module in the course if you haven't done so already. So we're going to move on to tags. Tags are really just a way for us to organize our data. You've probably seen some tagging demos already, but let's say I just wanted my cost center. In my case, my cost center is lab. I can use this point in time to go ahead and add various tags to my build. Finally, I can review and create, and this is great because it also gives us an option to download the template, and you'll see ARM templates and automation much later in the course, but you can download the template for use in your automation tools right here, before you go ahead and build it. But if you are happy with it, check through everything, make sure everything is as expected, and then go ahead and click create. and that will begin building your virtual machine. Windows machines, B series, take about 5 to 10 minutes to complete. If you choose a D series on premium disk, then they'll be created in much less time. And finally, Linux machines a little bit quicker as well. So plenty of options, but you can monitor your deployment here. You can cancel it, during deployment if you want to. You can see the services in Azure that I've already deployed. You'll notice like the IP, the NSG, the disks are all separate services. You can watch them deploy there if you want to. You can also go and see the template on the left-hand side. You can still download it here if you want to. You can add it to your libraries if you want to redeploy, similar machines. This is a good way to kind of, create that ARM template and get it the way you want for deployment later, via automation. But with that, this concludes this demonstration, and in the subsequent demos, you will see how to connect to your Windows or Linux machines. With our virtual machine now deployed, it's now time for us to connect to the virtual machine itself, and there are multiple ways that we can do that. First of all, let's go over to the Azure portal and create an RDP session to the virtual machine. Here we are in the Azure portal, and the easiest way to find your VMs is either to click the virtual machines tab on the left or go into your resource group, but note that it will show the other associated features with the virtual machine as well. Here we are in the virtual machines tab, and you can see our virtual machine SL-VM01, which is our Windows virtual machine here. Go ahead and click into that. On the right hand side now, you'll see an icon that says connect. Go ahead and click that one. As you can see, it will download an RDP file to your machine. If you open that up, it'll look just like a normal RDP file that would use when you create an RDP connection to any Windows machine traditionally on your on-premises network. You'll get a certificate warning. That's just because we haven't created a certificate for this machine, but go ahead and click connect, and you'll be prompted for your credentials. Now just simply enter the username and password that you used when you created the machine. Click yes if you're prompted for the certificate warning again. And as you can see, we're connected into the machine, and up comes our desktop. So that's one way to connect into our virtual machine. The next way is very similar, but instead of us doing it through the portal itself, let's go and do the same thing using PowerShell. So first of all, let's close out of this RDP session and go over to our PowerShell client. And in this case, we use the following PowerShell command: get Azure RM remote desktop file, followed by the resource group name. In our case, it's SL-70533-VMs, followed by the name of the virtual machine. And then we can add an optional parameter either for launching it directly or saving it locally. In this case, we're going to launch it, hit enter, and you can see immediately we get the connection box pop up and we can go straight into our virtual machine. Alright, so we've seen a couple of methods to connect to our virtual machine via RDP, but it's also possible to connect via WinRM using PowerShell. In order to do this, we have two main methods: WinRM HTTPS. This is where we can connect over SSL using port 5986, and this is the recommended option if you're going to connect over the internet, as it's much more secure. In addition, we have WinRM HTTP. No SSL is required. This uses port 5985, and this is ideal for connections from the same private network which is already secure. There are a number of steps involved in order to set up WinRM. First of all, you have to create a key vault, create a self-signed certificate, upload that certificate to your key vault, get the URL for your certificate from the key vault. So at this point, we've created the key vault, the certificate's in the key vault. Now we get the URL for the certificate directly from the key vault. Finally, we reference our self-signed certificate when we create the virtual machine. All of these procedures can be found at the following link. You won't be expected to know the detailed commands for this, but you should be familiar with the high-level procedures of what's required to create the self-signed certificate. And with that, that concludes this demonstration. In this demonstration, we're going to now connect to an Azure Linux virtual machine. Let's start by heading over to the Azure portal. Here we are in the portal, and as you can see, I've already pre-created a Linux virtual machine, which is SL-LinuxVM01. But before we go in and connect, let me show you some of the settings you need to be aware of when you provision the virtual machine. So let's go ahead and click New. And now let's select the Ubuntu server here to deploy. Just like Windows, we have to give it a name, VM disk type, etc. But if we look a little bit further down under our username section, we have two authentication types: SSH public key and password. If we decide to, we can create an SSH public key and paste it in here. But in our case, we're going to use a username and password. So if we go in here, select password, type in our username above, type in our password again, and then everything else pretty much proceeds in exactly the same way as we did in the Windows demonstration. I'm not going to deploy this now as I've already pre-created one, so let's close out of this and head over to our virtual machines. Here we are with our already deployed machine. And if I go in here and click connect, you can see that it tells me to use SSH with the following command: SSH sladmin at the IP address. In order to do that, we need to either open up a terminal session if you're using a Mac, or in my case in Windows, I've downloaded Putty. Putty can be found at the following website, which we'll link in the course material. In my case, I've already got Putty installed, so let's go straight over to that and connect to our Linux virtual machine. Here it is on the desktop, double clicking, type in the host name. In my case, I'm going to use sladmin at the public IP address I copied from the Azure portal. Go ahead and click open. It will prompt me for the password. Typed it in, and we're now connected into our Linux virtual machine. And with that, that concludes this demonstration. Whenever we've been creating virtual machines so far in the demonstrations, we've been using marketplace images. These are provided for you in the marketplace. They have various properties like a publisher, an offer, and a SKU attached to them. Some may charge you different fees depending on the software installed. But we also have the option of custom images. These are essentially do-it-yourself images that you can create yourself for use in Azure. There are a lot of benefits in this. For example, when you deploy a Windows VM from Azure, it's often not patched to the latest patch level, and it might make more sense for you to build an image that's already patched and then use that for creating your virtual machines. So custom images have two ways in which you can create them. In Windows, we first need to do sysprep. In Linux, we use sudo wa-agent deprovision plus the user. Then we will generalize the image in Azure and then create an image. Let's take a look at how we would create a Windows VM image in this demonstration. Let's head straight over to the Azure portal. Here we are in the Azure portal, and let's go straight back into our virtual machine, SLVM01, that we've been using in the previous demonstrations. Let's connect into it via RDP. And here we are in our virtual machine. What we first need to do is sysprep the machine itself. So let's go into sysprep. This can be found under c:/windows/system32/sysprep. In there, you'll see a file called sysprep. Double click it. It opens up the system preparation tool, and you'll need to choose a couple of things. First of all, we want to enter system out-of-box experience, OOBE, and secondly, we want to select the generalized box. Finally, under shutdown options, select shutdown. Click OK. Sysprep will begin working, and once it's completed, it will shut down your virtual machine. You do not want to power it on again at this stage. We'll fast forward here and come back to this process once it's completed. Okay, so we fast forwarded here, and as you can see, we're out of our RDP session, and that's natural because the virtual machine had to shut down. You may notice this error appear. We recently resolved a problem with your virtual machine. If you select into that, you'll notice that it says the virtual machine is stopped as requested by an authorized user or by a process running inside the virtual machine. So this is perfectly normal. Let's go back out of there. And if we look, we can verify at the top, our virtual machine is not started right now. We can start it if we want to. Its status is currently set to stopped. And now all we need to do is create our image. So what we do is select the capture icon at the top. It'll ask us to give it a name for the image and what resource group we want to use. So I encourage you at this point, create a new resource group. In my case, I'm going to call it SL-VM images. And then you can also check the box to automatically delete this virtual machine after creating the image as well. So in this case, we're going to create the image in the new resource group and have Azure delete the machine straight away. Click Create. A task will begin. You can see that it tries to stop the virtual machine again, and it'll move on to subsequent tasks momentarily. And we'll fast forward again here and show you once it's completed. So as you can see here in Azure, we've now completed a number of the tasks. It successfully stopped the virtual machine, successfully generalized the virtual machine, created the image in our new resource group, and deleted our virtual machine. So if we go over to virtual machines again, close this notification window, you can see our Windows VM is no longer there. But if we go over to resource groups, we can see we have our new resource group, SL-VM images. If we go in there, we can see we have our image file. If we select into that one, we can now create a VM directly off that image. So on the top left here, select this icon and you can build a VM from that image. Now this is very useful as well because we could also install lots of packages. In addition to patching, as I mentioned, we can have agents, we can have other pieces of software and things that we just want to bake into the image itself, store it as a template here, and then deploy over and over again. And with that, this concludes this demonstration. Let's begin by looking at configuration management as a whole and why it's very important. Previously in our demonstrations, we were deploying virtual machines, we were configuring VNets, subnets, etc. But the virtual machine, when it's deployed, doesn't really have our software packages installed on it. Perhaps we bake them into the template, but then how do we keep them consistent? How do we add additional configurations on top of them? And so if you look at the virtual machine, we break it down into two main sections of configuration management. We have our OS settings, our antivirus and backup agents, infrastructure monitoring. This section is really focused around infrastructure settings, things that your Windows and Linux team will really care about for every virtual machine that gets deployed. On top of that, we have all of our application settings, application installations, app configuration settings, and application monitoring, amongst others. These are things that our middleware and application teams care about as well. In order to get a consistent set of configuration for your entire machine, we utilize a variety of configuration management tools to achieve this goal. This means that if we needed to redeploy the machine, as long as everything is set up in configuration management, we know that deploying the machine again, we will get the same machine over and over again. This is that concept of cattle versus pets that you hear so often in the IT industry today. If we look at this now from an end-to-end process, think about you might use an ARM template or Terraform or some other tool to deploy your infrastructure first of all, and we'll obviously cover ARM templates later on in the course. But think about it this way, the ARM template and infrastructure automation tools go out, deploy all of your infrastructure resources, network, storage accounts, network security groups, and your virtual machines. Everything we've done here is outside of the virtual machine itself. Now we want to configure inside of the virtual machine on top of the operating system. The virtual machine goes off and we use a variety of extensions here. VM extensions allow us to use things like DSC, custom script extensions, etc. to now configure inside of the virtual machine. Ideally, you'll use the VM extensions that make the most sense for your particular environment. If you're a heavy Puppet user and have a lot of teams using Puppet, it might make sense for you to all standardize around Puppet. Perhaps you'll use Chef, perhaps you'll use DSC, and maybe combine that with some scripts on top of it. The choice is really up to you, but there are multiple ways to achieve the same goal. If we look now at configuration management, these are the three extensions that are provided by Microsoft Azure. We have our PowerShell extension, which obviously we'll go over DSC in a moment, but we also have Puppet and Chef extensions available as well. The key difference being that Puppet and Chef are enterprise-level configuration management for multiple nodes. PowerShell DSC, while very good and tactical for us to go and deploy a configuration, doesn't have the same holistic management that something like a Puppet and Chef might have. So if you're looking more at the enterprise across on-prem, public cloud, Windows and Linux, definitely take more of a look at Puppet and Chef. But if you really just want to get a configuration up and running, PowerShell DSC is still a really good tool for you. One last thing to mention, PowerShell DSC scripts can be used inside tools like Puppet and Chef as well. So if you've got a configuration you've configured in PowerShell DSC, there's nothing stopping you porting that over and using that in Puppet or Chef. Now, while Puppet and Chef are certainly out of scope for this course, Microsoft does expect you to know PowerShell DSC and some of the key components. So to begin with, there are three major components with PowerShell DSC. Configurations, these are your declarative PowerShell scripts which define and configure instances of your resources. The next piece we have are the resources themselves. Microsoft refers to these as the make it so part of DSC. They contain the code that put and keep the target of a configuration in the specified state that you've decided on in your configuration. And then finally, we have the logical configuration manager. This is the engine behind DSC. It facilitates the interaction between resources and configurations in a sense to keep the system at the specified state. Now, if we look at a PowerShell DSC example, on the left-hand side, you see some code for deploying IIS and ASP.NET 4.5. First of all, we have the name of our configuration. In this case, it's Skyline's website. Next, we specify the target the configuration applies to. In this example, we're using localhost. Moving on, we have a declarative statement about what we are configuring. In this case, we're saying install IIS. This is the Windows feature, same as if you went into Windows and turned on the IIS feature from the server manager. We have another one here, a second declarative statement, this time to ensure .NET 4.5 is installed, and then we have our curly braces to close out the configuration. That's pretty much what you need to know for the exam. Look at configurations like this and be able to interpret what they're trying to do. We'll see in the demonstration that follows how to take one of these configurations and apply it to a virtual machine. In this demonstration for PowerShell DSC, we're going to take the code that we covered in the module and install it on a Windows virtual machine. In order to get started though, we're going to need some help from PowerShell. But let's begin by looking at our code in Visual Studio and then getting it ready for Azure consumption. Here we are in Visual Studio Code, and you can see I've got my configuration here very similar to the one we had in the PowerPoint. In this case, our configuration name is Skylines IIS. We're still going to deploy to node localhost. We're going to install the IIS feature, and we're going to install ASP.NET 4.5. Now, as I mentioned, we have to get the code ready for consumption. So first of all, we save this file. In my case, it's install iis.ps1. And if we go over to PowerShell, as you can see, my file's there, install iis.ps1. But now let me make it ready for consumption. So I use the command publish Azure RM VM DSC configuration. If you start typing publish-Azure RM VM, you'll see these come up pretty easily. So there we have it, publish Azure RM VM DSC configuration, and now we need two parameters to save it locally. First, we need the configuration path for the PS1 file, so let's type that in first. Secondly, we need our output archive path. In this case, I'm using a local file called sl install iis.zip. Once completed, if I look in the folder again, I now have my sl install iis.zip file ready for consumption via the Azure portal. It's worth noting that if I didn't want to do this locally, I could actually publish it to Azure Blob Storage, and instead of going to the Azure portal to upload the zip file, I could reference it in my PowerShell script. But in our case, we've created the zip file locally. We're now going to go over to the Azure portal and install it via the VM extension there. Okay, here we are over in the Azure portal again, and I'm going to use a new VM I created, sl-VM02. It's just a simple Windows virtual machine, just like we did in Module 1 of the VM section. And if we go in here and scroll down a little bit, you'll see something called extensions. If we select extensions, straight away on the right-hand side, you can see we currently have no extensions set up already on this virtual machine. Let's go ahead and click Add. And here you'll see the various extensions available to you. We discussed Puppet earlier and Chef, and those are available there, but in this case we're going to use PowerShell desired state configuration. Selecting DSC and selecting Create, we'll now be prompted for the modules and scripts that we wish to install. In this case, our module, if we select the File button here, will be our local zip file that we created using PowerShell. Next, we need to use the module qualified name of configuration. If you look at the information button here, it goes in the following format, module/function. In our case, we will use install iis.ps1 /skylines iis, which was the name of our configuration. Scrolling down, we have to put in the version of DSC that we wish to use. In my case, I'm going to use 2.26. With that said, we don't need to enter any of the other information there for the use case we're trying to perform. Go ahead and click OK. As you can see, deployment is now in progress and DSC is underway. Let's check back out in a little while to see if it succeeded successfully. As we can see now, PowerShell DSC is showing that provisioning succeeded. This took a couple of minutes to complete. If we now go RDP directly into the machine, and I have an RDP session already open, look in here and go to Manage, look at our roles and features, scroll down, we can see that the web server feature is actually installed. If we open up a web browser and go to localhost, we can see that IIS has been successfully installed. And with that, this concludes this demonstration on DSC. Now that we can see the value of the PowerShell DSC extension, What's really the benefit then of the custom script extension? Well, think of it this way. This allows us to execute VM tasks without logging into the VM. So if we wanted to log in and execute a PowerShell command or another script, that's what the custom script extension allows us to do. We can upload via the portal or download scripts from Azure Blob Storage or GitHub, reference those in the portal, and it's basically going to inject that script into the virtual machine and run it. And this can be automated using PowerShell as well. There are some benefits and drawbacks though. So if we think of the benefits, no local or domain credentials are needed to log into the Azure VM. The VM does not need an accessible IP address to remotely connect. It's very, very simple to implement. The drawbacks though, it must be enabled for each VM you want to run your script on. You have to enable that extension basically. VMs will need internet access if using GitHub or Blob Storage for scripts. And finally, it is relatively slow. It's not like you're logging into the box, type a script in, or load your PowerShell file and hit go. It takes a bit of time to execute, and if you have to troubleshoot it, it could be a little bit cumbersome. On the whole though, it's a great way as part of automated builds and deployments. If you have some custom scripts that need to run to do some post-configuration tasks and they're not really well suited for some of the desired state tools, it makes sense to execute them here. In this next demonstration, we're now going to deploy our Azure virtual machine using PowerShell. It's very important for the course that you start to learn a lot of the PowerShell commands, as there will be questions on them throughout. To begin with, let's look at some of the PowerShell virtual machine commands that you'll be expected to know. First of all, new resource group. To use this PowerShell command, you use the command to new-azure rm resource group. You then pass two parameters to it. -name is our first one, which is our resource group name that we would type in after that, and then location, which would be East US as an example, or North Central US as I used previously when I deployed the virtual machine using the portal. Next, we've got our new virtual machine. This is a very simple command, new-azure rm VM. However, it only works if you give it a virtual machine configuration. You need to provide names for each of the required resources. So the resource group name that it's going to go in, the name of the virtual machine, its location, etc. In order to do that, you use the create VM configuration command, which is new-azure rm VM config, and pass it the VM name and other parameters as well. Finally, we've got some commands for starting and stopping the VMs. So to start a VM, it's simply start Azure RM VM and pass it your virtual machine, and stop VM is stop Azure RM VM. Now let's go and look at the actual code that will be necessary to deploy the VM. Okay, so to get started, we're back over here in Azure, and obviously we don't want to create it using the GUI, we want to create it using PowerShell, and Microsoft actually gives us a lot of these scripts on their website. So this link, which will be linked in the course itself under virtual machine scripts, allows us to create a fully configured virtual machine with PowerShell. So I strongly recommend for the exam, maybe give this page a quick read, but to really demonstrate it, scroll down to the sample script, click copy, and take that over and paste that into whatever your favorite editor is. In my case, I'm going to use Visual Studio Code, paste that in there. Obviously, this is the entire script here, so if we scroll up to the top and we'll walk through this. First of all, there's a number of common values that I need. I mentioned we have to create a resource group. So in this case, I'm going to create SL-70533, and I'm going to give it a slightly different name, so P-shell, so we can distinguish it between the other resource group we have for the 7533 exam. Next, I've got location, so I'm going to select North Central US. And for the VM name, I'm going to choose SL-VM02. Now let's walk through the script itself, and I'll magnify the screen here so you can see this a little easier. We first need to create the user object. So this gets us a username and password for the virtual machine. So we use the $cred equals get-credential. That's going to prompt us for credentials and store them in the variable called cred, C-R-E-D. We'll then create our resource group. You can see there that we're using that command I mentioned, new-azure rm resource group, and passing it the parameters that we want. In this case, it's taking the $resource group from above, which we've defined already, and the location we mentioned above. We're creating our subnet configuration with new Azure RM virtual network subnet config. We create our virtual network, and we create our public IP address and specify DNS name. Scroll further down, create our inbound network security group rule and our network security group. So if you saw before, when we did it manually, that was filled in by default in the portal. Here we have to actually define it. So we create the rule, which is included as part of creating the security group. So you'll see that the first variable is NSG rule RDP. That's the variable we're saving it in. And then when we create the NSG, it references the security rules stored in NSG rule RDP. We create the virtual network card and associate with the public IP address in NSG. And finally, we take all of this and we create our virtual machine configuration. So here we have $VM config equals new Azure RM VM config, our VM name that we specified in the beginning, and the VM size. In this case, you can see in the script we have standard_D1, and I actually know that's not a valid instance type for that region. So I'm actually going to change that to a standard B2S instead. And I'll go through at the end of this just a PowerShell script you can use. If you want to know what SKUs are available in your region, there is a command you can use to check that. Then we've got the operating system, the source image. This is the actual image that gets deployed, using your CPU memory disk. You have to have kind of a template, a stored, image file of Windows that we want to use. In this case, I'm using Windows 2016 Data Center, but you could use other images if you wanted to, and we'll talk more about that later. And then we've got the network interface. And finally, we can now create a virtual machine. So in this case, we use new-Azure RMVM, as I mentioned in the PowerPoint slides, but now I select my resource group name, which is a resource group variable that we specified in the beginning, the location, and the VM configuration. If we go ahead and save that, and now go over and let's try to run that. And here we are, I've tabbed over to PowerShell. Let's go in first of all and log into Azure. So we do that by typing in login-Azure RM account, and you can just type login-A and tab through if you need to. And when you hit that, it'll prompt you to log in just like you normally would. Okay, now that's complete. I can go ahead and run my script. So in this case, my script is called deployvm.ps1. And first thing it prompts me for are those credentials. So remember we had that variable which was indicated by the $cred. Let's go ahead and type in the username and password that you want to use there. And now it will go ahead and start deploying our virtual machine. So this may take some time, so we'll speed things up here and show you once it's completed. Okay, so you can see there that everything was completed successfully. The status code response is true. If we go back over to the portal now, and we can see we've got our 7533 PowerShell resource group. Select in there, and we should see successfully we have our new virtual machine SL-VM02 and all the associated objects as well. Now if we want to delete that, we can go back into PowerShell, and we can now use the following command: remove -Azure RM resource group. Followed by the name of the resource group. Hit enter. It'll ask us if we're sure we want to remove it, so hit Y for yes. PowerShell now continue and delete the resource group and all of the objects inside of it. So again, great for when we want to just delete everything. We don't want to have to go through and delete all those objects in the resource group manually. We can just come in and delete the entire resource group. Obviously use this with caution, but it will delete everything in there for us. And with that said, we'll speed this up and show you once it's completed. And here it is. You simply get this response that says true. If we head back over to the portal, go over to our resource groups, and we can see it's no longer there. And with that, that concludes this demonstration. There are two major choices when we look at VM storage types in Azure. We have standard storage and premium storage. Standard storage is backed by traditional hard disk drives. These are your spinning disks that you have on older machines. They're the most cost effective, but their maximum throughput is 60 megabytes per disk, and the maximum IOPS is 500 IOPS per disk. On the flip side, Microsoft provides an option for premium storage. These are backed by modern-day SSD drives, higher performance, maximum throughput of 250 megabytes per second per disk, and maximum IOPS of 7500 IOPS per disk. If we look at the standard storage sizes, you don't choose your specific size like you would traditionally in a VMware environment on premises. Instead, you choose from the model of disks in your category. So in standard storage sizes, we have S4 all the way up to S50, and they start at 32 gig all the way up to 4095 gig or 4 terabytes. The maximum IOPS for all of the above is 300, and the maximum throughput for all sizes is 60 megabytes per second. Now, if we look at premium storage sizes, a little bit different. These are the P series of disks, so they go from P4 up to P50. They recently added the P15, which is a 256 gigabyte disk in the middle there. The maximum IOPS is 120 for the P4, all the way up to 7500 in the P50. So you can see, even if you selected your appropriate size, you need to still make sure it's going to meet your IOPS requirements. And that is true for the maximum throughput as well. We could take a P4, but let's say we needed a throughput of 100 megabytes per second. Even though the P4 we only needed 32 gig, we would have to go up to the P10 in order to get the throughput requirements met. So make sure you look at this chart. It's constantly updated on the Microsoft website as you calculate sizes for your disks. Managed versus unmanaged disks is another important thing. On unmanaged disks, this is essentially your do-it-yourself option. You would create your storage account and put your disks in there. There's a lot of management overhead that comes with that because there is a 20,000 IOPS per storage account limit. It does, however, support all replication modes, LRS, ZRS, GRS, and read-only GRS, which we'll talk about in a subsequent section. Managed disks, however, are your simplest option for virtual machines. They're lower management overhead as Azure will manage all of the storage accounts for us. They only, however, currently support the LRS replication mode. This brings us on to replication modes. What's the difference between all of these? Well, LRS is logically replicated storage. This is replicated 3 times within a storage scale unit. A storage scale unit is a collection of racks of storage nodes that are hosted in the same data center in the region as your storage account was created. Zone replicated storage, which is known as ZRS, these are replicated 3 times across 1 or 2 data centers in addition to storing 3 replicas similar to LRS. Data stored in ZRS is durable even in the event that a primary data center is unavailable or unrecoverable. Then we have GRS, geographically replicated storage. This replicates your data to a second region that is hundreds of miles away from the primary region. Your data is curable even in the event of a complete region outage. Then we have read-only geographically replicated storage, also known as RA-GRS. Same replication as GRS we just discussed, but this also provides read access to the data in the other region. It's very important for the exam that you understand the replication strategies. If you take these 3 categories, data is replicated across multiple data centers. Well, the only ones that fulfill that are ZRS, GRS, and RA-GRS. LRS does not support that, it is only local. Data can be read from a secondary location and the primary location. The only option that supports that is RA-GRS. So even though GRS is replicated, we cannot read from the secondary location. This is also known in some cases as it's warm, so recovery time objectives are much better on RA-GRS because the data is already loaded. The number of copies of data maintained on separate nodes is another factor. 3 for LRS, 3 for ZRS, but goes up to 6 for GRS. So just make sure you understand this table, as I think it'll definitely help you for the exam. In this demonstration, we're going to add a managed disk to an existing Azure virtual machine. So let's jump straight over to the Azure portal. In the Azure portal, we select our virtual machine, in this case AZ103, which is our existing Windows machine we created earlier. Once inside, select the disks under the settings category. And here you'll see on the right hand side, we just have an OS disk right now. It's 128 gig. It's using premium LRS storage, no encryption enabled, and its host caching is set to read-write, which is the default for all OS disks. Now we want to go ahead and add our data disk. So click Add Data Disk. And on the bottom here, you'll see your LUN0 and the name of the disk. Select Name, and choose here. You can choose an existing disk, or we can choose to create a new disk. In our case, we want to create a new one. So here we go, Create Managed Disk comes up, and we'll give the disk a name. SLVM02 disk 2 in my example here. We're going to use our existing resource group. We want to keep all the resources with that VM together. If we want to delete everything, we can just delete the resource group and everything contained in there will be deleted. Our account type, again, we can choose premium or standard for our disk type. We're going to stick to SSD drives here. Source type if we wanted to, if we expand this out. This allows us to create a disk off a snapshot or a storage blob. But in our case, we're creating an empty disk, and then we choose our size. As you saw with the premium disk sizes in the PowerPoint presentation earlier, the size affects the IOPS and throughput below. What's great is Microsoft puts this directly on screen for you. So if we drop this down to a 256 gig disk, we'll see the IOPS and throughput drop. If we go up to, say, 2000 in size, we'll see it increase again. So you can still choose the disk size, and it's going to select the underlying premium type disk that's appropriate for your disk size. Go ahead and click Create, and in a little while your managed disk will be successfully created. We'll fast forward ahead here. Now that disk has shown up, I've gone ahead and clicked Save at this point, and it's now updating the VM configuration with the disk. So first we created the disk, now we have to save the settings here so it's associated with the virtual machine. And as you can see, it successfully updated virtual machine disks. So now if we log into the virtual machine, we've got an RDP session already open. Scrolling here, in fact, yep, we can see it's already come up there, 2000 gig. Now if we right click, create a new simple volume, this will guide us through the Windows wizard, just like you normally would add a disk. Comes up with the size, we can choose to allocate all that size or not. Go in here and choose the drive letter, in this case we're going to have the F drive. Click Next, 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 hit Finish. And Microsoft is now formatting that disk, and it'll be available for us to consume in Windows once that's completed. And with that, that's the end of this demonstration. Disk caching is another feature on the exam that you need to become familiar with. It's a method for improving performance of existing virtual hard disks. So rather than maybe upgrading your disk to premium and moving your data across, disk caching can provide you some additional benefits. It utilizes local RAM and SSD drives on the underlying VM host. So the RAM and SSD drive it utilizes is actually local to that specific host that your virtual machine is running on. This gives us increased performance versus it having to transfer to the SAN-based type array systems. It's available on both standard and premium disks. There's a couple of settings you need to be aware of here. On the OS disk, read-write is the default, and you can change that to read-only or read-write, but it is recommended to stick to read-write for your OS disks. Data disks, whenever you add them, have a default setting of none, but you are allowed to change that to read-only or read-write as well. Read-only caching will improve latency and potentially gain higher IOPS per disk for all read tasks. Read-write caching, same thing, it would help with the write caching as well. However, you need to be sure you have a proper way to write data from cache to persistent disks, otherwise you could potentially get some data loss. There are certain use cases that this works for and certain that it doesn't, so check with whatever software product you're using if it supports read-write disk caching. For the most part though, if you do have a lot of read tasks, turning on read-only caching for your data disks will give you improved performance. In this demo, we're now going to enable disk caching on our virtual machine. Let's head over to the Azure portal. Okay, here we are in the Azure portal, and let's go to our virtual machine, AZ103. This is the machine that we created the extra virtual disk on previously. If we head over to disks, we should see we have our OS disk and a data disk there as well. And if you look below, you can see that host caching is currently set to none. Now there's no option currently in this area to change the host caching, so we need to head over to PowerShell. The first thing we need to do in PowerShell is store our VM as a variable. And to do that, we'll need two things, the name of the VM and the name of the resource group that it's in. If you're unsure, just type in get Azure RM VM. And this will list all of your virtual machines and their associated resource groups. As you can see, we have two virtual machines here, both in the resource group SL70533-VMs. So we'll go ahead and store that VM in a variable. $VM, that's our variable. Get Azure RM VM again. The resource group name, followed by the name of the virtual machine. Okay, if successful, you won't see anything, but you can validate that everything is stored in the variable, but just type in $VM, and we can see that our virtual machine is there. At this point, you can also see a property there called storage profile at the bottom, and inside of that, it contains our image reference, OS disk, and data disks. If we want to access the data disk, simply hit $VM to reference our variable, period, storage profile, period, data disks. This will then list all of the data disks associated with our VM, and in this case we can see our data disk called SLVM02 disk 2, our disk size of 2000 gig, and more specifically what we're focused on here is the caching, which is currently set to none. So now we need to set the caching to read only or read write. In our case we're going to choose read write caching, so we type in set Azure RM VM data disk, the VM variable that we created earlier, the name of the data disk we want to reference, in this case SLVM02 disk 2, followed by the caching mode we wish to choose. So in this case we mentioned we'll use read-write caching. And finally, we need to update the Azure RM VM with this configuration. So we pipe all of that to update Azure RM. Hit enter. And after about 30 seconds, you should get a response that says success true. Now let's go over to the portal and validate that disk caching is now set to read-write on that data disk. And as we can immediately see in the bottom right, host caching is now set to read-write. And that concludes this demonstration. In this demonstration, we're going to take a review of Azure VM networking, and you've seen the constructs come up over and over throughout the course already in different pieces. But now let's just take a look in the Azure portal at some of the networking constructs that you just need to make sure we reinforce and you're familiar with. So in the Azure portal, I've got a virtual machine up here, SL-VM01. And first of all, I'm just going to go straight over to settings, to networking, and bring all of this up for us. So first thing to note is you can attach a network interface and detach a network interface from here. So we have this interface attached, SL-VM01215, and you can, build additional NICs. You can go and create a resource, and you can do a network interface directly from here. You can see it there. We can create one. And you decide when you create this interface what virtual network it goes on, what subnet it goes on, private IP address can be dynamic, static, all the things that we're going to kind of review as we go back through that VM. But just be aware again that the NIC is a separate interface card that can be attached to the virtual machine and detached as needed. So let's go back over to the machine. I'm not going to build another interface now. We've already got one on there. So back to the VM. And we can see the interface, and just below that you can see we've got the network security groups, and we've got inbound port rules and outbound port rules. And again, this is if we've got a network security group that we want to attach to the interface itself, or potentially on the subnet. So you can see we've got a network security group, and it says impacts 0 subnets, 1 network interfaces. So again, just know that, because this is a place where you can check the effective rules you have against your machine. Now if we go back up and click the NIC card itself, we'll click this one here. This will take us into the interface, and a few things you'll notice straight away. One, you've got your private IP address here, that was allocated by DHCP, but we also have our public IP address, which is also clickable. We're not going to go into it just yet, but the public IP address is, allocated to us and is also something that you can build on demand. It's like a separate service in itself that is attached to the NIC. So again, the NIC's attached to the VM, but we can attach a public IP address to the NIC. And let's go to IP configurations. This is where we do all of our IP addressing. And you can see in here, we've got IP forwarding, which we can disable or enable, the virtual network, which we can go to if we want to click on the network and do some network configuration, and then the subnet that we're basically in here as well. So in this case, we're in this default subnet 10.110/24. But on the bottom, you can see we've got IP configuration. So if we click this IP configuration, this is where we decide, okay, am I going to enable the public IP address or disable the public IP? Which public IP address do I want to use? I can click this link here. This will take me to, choose a public IP address, or I can create a new one directly in here. So again, I can create that as a service by itself, or I can create it directly from within the IP config pane in this case. But that's how we associate the public IP address with the NIC. Below that, I've got my private IP address set in. So you can see I've got my virtual network subnet link available to me here. You can see it's dynamic. It's allocated via DHCP 10.114 was allocated to the machine. And if I want to make that static, I can click static. That's basically going to put that DHCP reservation in Azure under the covers that makes sure that this machine is always going to get the 10.114 IP address. So let's close this out. We'll go back to the networking section and go back into that NIC card. And you can also see we have our DNS server section here as well. And this is where we can inherit from the virtual network. So we can set DNS settings up on the virtual network itself, or we can choose custom. So if I want this machine to utilize a different DNS server, I can essentially do that here. So not too much in this section. Most of the time you're going to do this from the virtual network itself, but there might be an occasion where you want to specifically, call something out for a specific virtual machine. And last but not least, we're going to go to network security group again. I'm not going to make any changes there. Click the network security group. This takes us into it, and we can click inbound security rules here on the left hand side. So now again, we're looking at it from the NSG perspective. I could simply wipe out those rules by clicking these are the default rules, I should say. We can simply wipe those out by clicking this here. I can add more rules, I can change the rules, they're all here. These are the defaults that we discuss in the networking section. Same for outbound. If I go to network interfaces, I can see that this NSG is applied to that SLVM 01215 network interface, and it shows me there that interface has that public IP address we just talked about and the private IP address. Yeah, so the key thing to think about in Azure is, when you're dealing maybe historically with a VMware environment, you go into a VM, you see your NIC and everything's kind of there, and you also have like a distributed virtual, port group that you might look at as well. But in Azure, think about everything is kind of its own construct. The public IP is a construct in Azure that I can, buy and reserve. The NIC is a construct. The VM itself is a construct. The subnet is a construct, and all these things are software defined, and I'm essentially piecing them together. So there's different viewpoints that I'll see depending on if I'm looking directly at the NSG or if I'm looking at the virtual machine or the NIC, etc. So it just helps, hopefully that makes it clear for you. But I definitely encourage you to kind of just explore the section, take 5 minutes, detach a NIC, attach it back on, try to go to a static IP, try to go back to a dynamic IP, just work through all those scenarios, and that'll give you some good background, in terms of how you do things. And in particular on the NIC card piece, definitely just not only detach it, but completely remove it, delete it, and then add another one to the machine, and you'll see some of the things that you run into as you do that, because things are in use and you can't delete them, etc. So with that concludes this demonstration, but definitely let us know if you have any questions at all. Okay, so we know we need to plan for availability in Azure. How do we go about doing that? And the mechanism Microsoft uses for that are availability sets. Before we can kind of, decide how to use them, let's understand our potential for VM impact first. First of all, we have planned maintenance. This is when Microsoft needs to patch or say do some firmware upgrades on the underlying hardware that your VM is running on, and they need to evacuate your VM. In most cases, this will happen using their live migration technology. They'll simply move your virtual machine from one host to another. But on other occasions, they do need to shut down your virtual machine in order to do this maintenance because live migration won't work for whatever reason, and so you need to account for that. The second one is unplanned hardware maintenance. This is when Microsoft detects, using say their monitoring systems, that a failure may be about to occur on the underlying host. And again, kind of like planned maintenance, they need to move your virtual machine, or sometimes very quickly they have to shut all the virtual machines down, do the maintenance, and then bring that host back up. And then finally, we have unexpected downtime. This is when there's a catastrophic failure to the underlying hardware, and you're essentially forced. Your VM is, shut down immediately, not gracefully, and the VM will eventually be powered on another machine, but your application will receive an outage. The way to solve this is using availability sets. This allows us to group two or more machines into a set, and they're basically separated out based on two things: fault domains and update domains. If we think of fault domains, first of all, this is essentially when we have a rack that has its own power, its own networking connectivity, and we can have up to 3 fault domains in an availability set. So if we think of our virtual machines, if we have 3 virtual machines in a particular tier, which we'll get into more in a moment, they can be spread out amongst those fault domains if we've used 3 fault domains. If there's an outage to one, the virtual machines on the other fault domains will be unaffected, and eventually the virtual machine that had the outage on the first fault domain would come back up once Microsoft resolves the underlying issue, or just simply moves your machine to another host. In addition, we have update domains. So think of these a little bit differently. Microsoft has to patch a whole series of hosts, but they will do them sequentially, and they won't patch the same update domains at the same time. Now, they allow you up to 20 update domains, so your virtual machines will be spread out amongst those update domains in your availability set. You don't control the specific order. So for example, if you've got 3 update domains, UD0, UD1, UD2, we know that they won't happen at the same time. Again, this is the patching of the underlying hosts, not your virtual machine patches themselves, but we know that UD0 won't happen at the same time as UD2, but UD2 could happen before UD0. This isn't an ordering system, it's simply a separation. If we think of planning for availability in a little bit more detail, the other thing we need to think about is what goes into an availability set. Well, it's very important that you put your tiers into separate availability sets. Think of it like this: we would have an availability set for our web tier, an availability set for our app tier, and an availability set for our data tier. Now think of it just from a fault domain perspective. We know now in our web tier that if we had 3 fault domains, those 3 servers would be separated out between 3 underlying fault domains. The reason for this is if we combined everything, let's say we put our data tier and our app tier and our web tier all together, we could be in a situation where all of our data VMs are on the same fault domain, because again, we've only got 3 fault domains. Microsoft's going to spread all of those machines out amongst the fault domains and update domains as well, obviously. And, if we've got too much in there grouped together, they could just, we could just have all of our data machines on the same fault domain, and that doesn't really help us from an availability standpoint. So use this model whenever you're trying to decide, what availability sets to use. And there's definitely a lot of questions, at least when I did the exam on this. They'll give you some scenarios on, he has so many web servers, so many app servers, so many data servers. They'll describe the scenario, and you have to decide how you group the servers out. Okay, so in this demonstration, we are going to now create an availability set that we can place 2 virtual machines in. Let's head over to the Azure portal to begin. In the Azure portal, the first thing we need to do is head over to availability sets. You can use the search button at the top, type in availability, and you'll see the services appear for availability sets. I've already selected that here. So if we go ahead, let's create our first availability set. Click Create Availability Sets at the bottom, or click the Add button in the top left. In there, you'll need to type in a name for your availability set. So in my case, I'm just going to use SLVM Demo AS. We'll choose our subscription, and we'll use our existing resource group or create a new one if you feel the need. In addition, we choose our location, and then you can see here, we talked about it in the PowerPoint presentation. We've got a number of fault domains and update domains I can use. So I can go up to 3 fault domains. In my case, I'm going to choose 2 right now, and I can choose up to 20 update domains. And again, this is how our VMs will be spread out inside the availability set. Next, we have this option around the managed disks. If we use managed disks and say yes aligned, Microsoft is going to make sure that our disks underneath the virtual machine are also appropriately put into availability sets. There's nothing we need to manage manually there, as opposed to when we do it in kind of the classic methods. So with that said, just go ahead and click create, and your availability set within a minute or so will be ready for you. And now it's ready. We go to our resource. We can see our availability set here. We can see our fault domains, update domains, and currently we have 0 virtual machines in there. So let's go ahead and add a couple of virtual machines. And to do that, it's really the same as creating a new virtual machine as we did in one of the earlier modules. So we'll just go ahead and click new and get into the virtual machine creation here. Give it a name, etc. So in my case, I'm calling this SL Test AS for availability set 01. Give it a username, password, etc. Choose your subscription and resource group. Select your size. And then you can see here, when you get to the high availability section of creating the virtual machine, simply expand this out, and you can choose your availability set. We can actually create a new one directly from here in virtual machine creation, but go ahead and select your availability set there, and now it knows that this virtual machine, when it's created, needs to be part of this availability set. I'm going to fast forward here and continue creating the 2 virtual machines and come back when they're completed. All right, so we can see both of our virtual machines, SL test AS01 and 02, have been created successfully and are both running. Going to flip over to our availability set now, just by using the search button at the top. Go to availability sets, and we can see SLVM demo AS that we created earlier. We'll go into that one. And now on the right-hand side, what we can see are our two virtual machines listed there. They're both managed, and we can also see that we have our two fault domains. So SL test AS01 is in fault domain 0 and update domain 0 as well, and SL test AS02 is in fault domain 1 and update domain 1. Now that's great. So these VMs from an availability standpoint are on separate hardware in Azure's data center. One of the other things that's good to know is how you would associate a load balancer with this availability set. This is one of the other things you're expected to know in the exam. Now I'm not going to cover load balancers in detail now. That's going to be covered in the networking section, but let's go over to a load balancer I've created previously. So I'm going to select load balancers from my menu on the left here. You can see I have a load balancer already there, SLAS LB01. Going to select that one. And in here, you can see we have a section for backend pools. If we click that and go in here, nothing there right now, but I'll go ahead and click Add, give it a name. So in this case, I'm just using SL-pool, and now I can associate it to an availability set. So I select that, I select my availability set. We can see SLVM demo AS with two virtual machines in it. And now I add a target network IP configuration. So I choose that, and now I choose my first target machine. So AS01. Choose its network IP. And then do the same again. Now for AS02, its IP, and hit OK. And what's great then is now this backend pool is associated directly with that availability set. So, my traffic's going to come in, get spread out between those two VMs, and those VMs are on separate hosts. So in the event there's a failure, one of the machines will always be up and running, and my application will be serviced. And you can see after a little while that's created, expand it out. You can see our virtual machines and our private IP addresses associated with them, as this is a backend pool. And with that, this concludes our demonstration. As we've covered availability sets, Microsoft has also begun to introduce availability zones throughout their regions. Now, they're not available in every region, so it is important to, look at the regions when you are planning for availability zones and make sure they are available. But essentially, they work similar to availability sets, but now we get 99.99% availability. They minimize the impact of planned and unplanned downtime, and really just enforce them like availability sets, but now you choose your specific zone in Azure. So in availability sets, we had those fault domains and update domains. What we do with availability zones is we essentially just choose the zone. In fact, when you build in your virtual machine, you'll get a number. If availability zones are available in your region, you'll get to choose those instead of availability sets. So it's an either or option. You can't have availability sets now in the regions that have zones. They want to move you towards zones. But essentially, you choose the zone number. So if you build in a VM, one VM will go in availability zone 0, one will go in availability zone 1, and then you know that they're in separate data centers in the same region. Now, the latency is such that it's such a fast connection between the two data centers in the region itself. So there's no performance impact by using zones, but they do give much better redundancy. In fact, there was a region outage in South Central at one point where the data center essentially had some power issues and went down, and just because you're in an availability set did not help you. You were completely out. All the backup generators and things didn't kick in properly, and people had complete outages. But availability zones would be two data centers further enough apart to make sure that in the event of something like that happening, you would still be online, providing your machine was in the other availability zone. So know these in addition to availability sets. Now let's take some time to talk about scale sets, and maybe you've heard the term in the industry, cattle versus pets, and scale sets is really a lot around that. Traditionally, if we wanted to scale up an application, we would add more CPU, memory, disk, etc. But scale sets allow us to essentially scale horizontally. So when we want to scale out our virtual machines, we simply stamp out additional ones to meet the demands, and then scale back in when that seasonal demand is slowed down, for example. If we look at this, we can define virtual machine scale sets in Azure, also known as VMSS. You can use the portal, PowerShell, or the API, and you'll see a demo of that a little bit later on. But you define the number of instances you wish to run, the instance size, etc. Do you want to scale beyond 100 instances? Do you want to use managed disks? You define everything around your instances there, and then we determine if we want to auto scale. So keep that in mind. A lot of people think of scale sets as, oh, do I have to use auto scaling? Well, you don't have to. You can go in there and choose to scale up and down as you want to, but you can auto scale if you wish. And auto scaling really is around setting a minimum and maximum amount of instance sizes. So you could say have a default default amount that you start out with, that you always have to have like a minimum of 1, but we want to scale up to maybe 10 as an example, or maybe we go with a minimum of 2 just to ensure we have that availability as we talked about in availability sets. But then I want to scale up for load as well. We can scale out based on a variety of metrics, and these can be infrastructure or application metrics. And this is really important because Azure ties everything together. We can use things like App Insights to look at the application metrics, say like transactions that are happening on a web server, and scale out based on that. Or we can scale out based on traditional infrastructure metrics like CPU, etc. We can also scale out based on a schedule as well. So if we know that at a certain time of the year, let's say a lot of retailers on Black Friday, for example, need to scale out for demand there. We know on schedule, we don't need to wait for the application to be hit hard. We can already preemptively start scaling out. So schedule-based helps in that instance. And finally, you do need to remember to account for sessions when you scale in. Very often, we always want to create a scale in rule at the same time as we create our scale out rule. So we know when demand goes down, we scale in. But if we've got a lot of users with sessions on specific web servers, they're not going to maintain their session if they scale in. So we need to account for that by using things like Redis cache, etc. when configuring auto scaling in rules. So hopefully you can see now there's just a lot of power in treating scaling in this manner, and we'll see more of that in the subsequent demo here. In this demonstration, we're now going to cover how to create a VM scale set using the Azure portal. So let's head straight over there. In the portal, to begin, simply type in scale at the top of your search bar and choose virtual machine scale sets. Up it comes, and as you can see, I currently have no virtual machine scale sets in my environment. So I'm going to select add. As you can see, it comes up and asks us for some of the basics for our scale set. First of all, give it a scale set name. So I'm going to call mine SL scale 01. Choose the operating system disk image. So in my case, I'm going to continue to use the Windows Server 2016 data center images I've been using before. It is possible to use your own custom images. You just need to configure it using PowerShell instead. Go ahead and choose our subscription and resource group. So I'm continuing to use the same resource group I've been using throughout these VM demos, our location, and then our username and password for those virtual machines. If we scroll down, now we get the details around the instance specifics. So in my case, I'm saying I want an instance count of 2, and now I need to choose my instance size. So in my case, I'm going to select this and choose a B series. If we scroll all the way down and choose the B2S here, and then I need to decide some other things. Do I want to scale beyond 100 instances? Obviously for this demo, I don't need to do that. And do I want to use managed disks for my virtual machines? I definitely do. Next, we do some IP address and information. So I'm going to do SL public 01. With the configuration out the way, we can now move on to the auto scaling section. So if we choose enabled here, another section expands out. If we scroll down, we can see a few things we need to decide here. So the minimum number of virtual machines, this is important. If we're trying to design for availability as well, we probably want to go with a minimum of 2. That's the minimum that will always be available in the scale set. And then we can say a maximum of 4 in my example, but I can choose to go up to 10, 20, etc. And then we can choose how we want to scale out. So what's the decision criteria for scaling out the VM? Right now, we're just looking at the infrastructure criteria that appears on this page, and we can go by CPU threshold, so 75% as an example. When we get to 75%, we'll add another virtual machine. We set it to increase the number of VMs by 1, but we could immediately say, look, when we get to 75%, go ahead and add 2, which would then put us at our maximum of 4. Then we have the scale in rule. As I mentioned, we want to try to create that always when we create a scale out rule. And in this case, I'm saying at 25% CPU threshold, start to decrease my number of machines by 1. And with all of that configured, just go ahead and click create. And we can see deployment is now in progress, and we'll come back to this once it's completed. Okay, so now we can see that our scale set's successfully been created, SL scale 01. If we go ahead and select it, we can go in here, we can see our instance count. If we go down to instances, you can see there both of those are running. And if we open up the scaling section, and we can see in here our various auto scaling rules. And as we mentioned before, we're currently scaling based on an infrastructure metric, but we could, if we wish, add additional profiles, scroll down here, add additional rules, and decide if we want to scale in based on other metrics such as application metrics, etc. And with that, this concludes our demonstration. All right, so it's time for us to begin our journey down networking, and there's obviously a lot to cover here for the exam. If you look on screen, we've got this network overview image that Microsoft always presents us with, and you can see more on this at the link on the bottom of the screen. I do encourage you to check that out. There's just a ton of documentation Microsoft provides around networking. But if you look at the image on screen, on the left-hand side, we have our on-premises network with options for like an encrypted tunnel, direct connection. Over to the right-hand side, which is our Azure network. And this right-hand side is where we are going to be focused on primarily as we work through this module. And there's all sorts of concepts there, but let's start with the VNet first of all. The VNet is one of the core pieces, and it has a number of capabilities that Microsoft provides for us to utilize with VNets in Azure. And if you look on screen, we've got a boundary there. So we've got our VNet boundary. Inside there, I've got two subnets, subnet A, subnet B, and I've got a couple of virtual machines in each one. Each virtual machine has a network interface card that connects it to the subnet. And then by default, these subnets can route to each other because they're in the same VNet. And then if we want to, we can put an NSG, a network security group, which we'll hear more about later, around these to say, okay, I want to filter traffic between them. So this is kind of the core concept of just if I want to put machines out in Azure, VNets are the way to do it. So what are all those capabilities? Let's just kind of summarize them and work through this list. First of all, they are isolated. VNets are isolated from one another unless we choose to connect them to each other. So VNet isolation is very important, particularly in multi-tenant scenarios. They all provide internet access. So if we want to connect these VMs to the internet, we can do that by default unless we choose to restrict that, but that is available for us. They allow us to connect multiple Azure resources, not just virtual machines. We could put cloud services like web apps and other services in there. We can plug them into the same VNet as our virtual machines. Everybody can share that networking boundary if they wish. The VNet connectivity, I kind of mentioned briefly, and again, we can chain these if we want to, so we can connect VNets to other ones, and there's various methods to go about doing that connectivity. We can provide on-premises connectivity, so we can allow VNets to route to on-premises, as you saw in that original diagram. We can apply traffic filters via network security groups. That's kind of the shields again that you can see on the screen there. And finally, VNets provide a number of capabilities around routing. So we have default routes available. We can also define user-defined routes. And so we can basically customize this to manipulate it in a way that meets the needs of our organization. If we look at some of the key points, let's just hammer these home. Number one, VNets are a primary building block for Azure networking. So just think of this as the core for everything that we do out in Azure and all the services we want to connect together. It's a private network in Azure based on an address space prefix. And this is something that we define. We create subnets in our VNet with our own IP ranges. So we need to plan for them. We do have to think about things like overlap in address space, much like we would on premises as well. We can choose to bring our own DNS or use Azure provided DNS, and there's more to come on that a little bit later on. And finally, we can choose to connect the network to on-premises or the internet if we wish to. But hopefully this gives you a brief overview. I think if you just understand these 5 points and work through the demos, I think you'll get a lot out of this and see very quickly how easy it is to connect all the pieces of Azure networking together. In this demonstration, we're now going to go about creating a virtual network and a subnet via the portal, and then we will follow that on by creating a series of subnets using PowerShell so we can do things much more quickly. But let's get started in the Azure portal. So to begin with, I've already created a new resource group called SL-network, and on the left-hand side, I'm going to select virtual networks. And as you can see, no networks currently present. So let's go ahead and select add. And the network blade comes up for creating a new virtual network. And let's give this one a name. So the first one we'll call SL-70533-portal. Now we're not going to go too much into address spaces in this course. There's plenty of YouTube videos on subnet and if you want to go about reading that, but for the purposes of this course, I'm going to create a /23 network for this one. So 10.0.0/23, and then I'm going to create 2/24 subnets inside that /23. Next thing we need to do is go ahead and select our subscription. So I'm using my pay-as-you-go, choose our resource group. So I'll choose SL-network, and you can see I'm doing this in North Central US. And now I need to name my subnet. So the first one, you can see it creates a default subnet. I'm going to call this subnet A. And we're going to give it the address range of 10.0.0/24. That's the first /24 inside of our /23 range. And we'll go ahead and click create. You can only create one subnet at this point from the portal. And within probably 30 seconds or so, our network will be created, but we'll speed things up here. And that's created, so we'll hit refresh. And there is our network. So now let's go inside there. And we can see if we scroll down to address space, we've got our 10.0.0/23, and let's go into subnets. And we can see we have subnet A, but let's go ahead and create subnet B. And you can see it's already picked the next /24 for us, so 10.0.10/24. And if you look closely underneath, it's saying our address range is 10.0.10 to 10.0.1.255. So we actually only have 251 usable addresses in there because 5 are reserved for Azure. And we're not going to cover network security groups and route tables yet. We'll come onto those later on. So go ahead and click OK. And that will create our second subnet. It should only take a couple of seconds. And we should have our subnet. So you can see we now have a VNet with 2 subnets, subnet A and subnet B. All right, so we can do things via the portal, but it can get a little bit cumbersome, particularly when I want to create a lot of subnets. So for that, in this next example, I'm going to use PowerShell instead. And let's start off in Visual Studio Code, where I've already got a PowerShell script ready that I can walk you through. So the top section of the script is just declaring kind of the global pieces I need. So the resource group and the locations. In this case, I'm going to deploy this new virtual network along with its subnets that you'll see shortly into SL-network, the same resource group I used before, and in the same location, North Central US. The second section, I've got my VNet name and address space, so I'm calling this one SL-7533-VNet-P shells to differentiate it from the portal one, and I'm increasing my address space this time. I'm going to use a /22 because inside of that /22, I'm actually going to create 3 /24s, and there wouldn't be enough space if I just stuck with the /23. Here, the next section, I'm declaring some variables around my subnets just so I don't have to type everything in with every line. So I've got subnet A name, which is SL-web, and that's the first /24, 10.0.0.0. Then I've got my next /24 for SL-app, which is 10.0.1.0, and then my next one for SL-data, which is 10.0.2.0. Next, I declare a variable, which I'm going to use when I create the VNet itself, and I just call this $subnet. And in this one, I created a new Azure RM virtual network subnet config. And this takes subnet A's name and subnet A's address prefix and adds it there. So think of this like when I created that VNet in the portal, I associated a subnet with it. This is the first one. If I scroll further down, this is where I actually create my VNet and I include that subnet configuration. So I'm declaring this as a variable because I'm going to use it a little bit later, but the command here is new-Azure RM virtual network, followed by the name of the VNet, which again is SL7533-VNet-P shell, which I stored further up, my resource group name, my location, and the address prefix for the VNet as a whole, and then the first subnet I want to create, which I reference with $subnet, $subnets being my variable for that. At this point, the network is created, but now I want to create those additional subnets. So I use these additional commands, which are add Azure RM virtual network subnet config. I reference the virtual network. I then reference my subnet configurations, which is my name, so subnet B name followed by subnet B's address prefix, and then I run that same command again for subnet C. Following that, I have to do one last task, which is to save the additional subnet configurations. They're only local at that point. They haven't been set against the virtual network, so I simply do a set Azure RM virtual network and specify the VNet, and then that will save the changes that we added when we added the additional subnets. So with all that, let's go over to PowerShell and run this. And I've got it here in my C drive script Skylines network folder, and I'm simply going to type in create. So create vnet.ps1 is the file I've got. Hit enter. And that is now going to go off and do all the hard work for us. So we'll give that about 20 seconds or so here. And that's completed. And then it's added the additional subnets. And now it's saved that config. So if we go over to the Azure portal now, go back into virtual networks and do a refresh, I now see I have this PowerShell version as well. So we'll select this one. And in there, if I go down to subnets, you will see that I have my web, app, and data subnets as well. So hopefully you can really see the flexibility and the ease of use that PowerShell will allow you here. I highly encourage you to get used to it straight away, and you almost certainly will get questions on the exam related to PowerShell commands in this area. All right, it's time to talk about IP addressing in Azure, and it helps to know first of all that it's all provided via DHCP, which is an Azure provided managed service. All addresses are DHCP based in Azure. Addresses are not allocated until the Azure object is created. So it's important just to know that they're not pre-allocated or anything. Once the VM is online, created, then it's kind of gets that reservation. And addresses are not recovered until the object is deallocated from Azure. In addition, it's worth noting that static addresses are just the equivalent of DHCP reservations. It's not like you're going in to the backend and configuring something statically. This is simply a DHCP reservation against your machine, for example. In addition, address prefix comes from VNet and subnet definitions that you probably saw in the previous demonstration, and Azure reserves the first 3 and the last IP from the pool. This is really, really important. You will probably get questions around usable address space in the exam, so know this because it's super important to know that Azure already takes a bunch of addresses up. And finally, when you think about this, the first address of a /24 is .4 because again, 1, 2, and 3 are reserved by Azure. All right, in this demonstration, we're now going to take a look at the IP address configurations of virtual machines, and more specifically, how we can configure a static IP address, and also how we associate and disassociate public IP addresses from our virtual machine. So let's head over to the Azure portal. So here in the portal, I've got a new virtual machine called SL-testvm01, and when I built this machine, I had it create the public IP address at the same time. You can already see it there on the right-hand side in the summary screen. If I select networking, The important thing to note here is that I can attach and detach the network interface card. The network interface card is an individual software-defined networking object that's in Azure. It's a resource in our resource group, and you can see the one that's created here, SL Test VM 01917. In addition, you can see I have a public IP associated there, and I also have our private IP associated there as well. And if I wanted to, I could also do network security group rules, which we're covering later in the module, but those are below. For now, select the network interface card. And then on the left-hand side, select IP configurations. And you'll see our IP config, which is in subnet A. So if I expand this, you can choose subnet A or subnet B. But if we look at the bottom, IP config 1, it's an IPv version 4 address, and we've got the private one, 10.0.0.4, which is dynamic, and we've got our public IP address, which is also an individual resource that we can define. Now, if I select this configuration, I can manipulate everything from the screen. So I could simply disable that public IP address immediately. I can hit disabled, I can re-enable it, and I can also change the public IP address. So I could select this one, and if I wanted to create a new one, I could, or if I wanted to select one of the other ones I already have, I could below. Now, this one isn't available for selection at all, even if I went to another machine, because it is associated with this particular network interface card. But if I close this down and go back to the screen prior, you can also see on the bottom the private IP address settings. So in subnet A, we've got this dynamic assignment of 10.0.0.4, and I can simply change that to static, and I can set that IP address to be permanent on that machine. So you can see there's just a lot of flexibility because you control everything individually at this network interface card level, and all the public IP addresses are separate as well. And it's important for the exam that you know how to get to this point, you know how to disable the public IP address, and you know how to set a private IP address as static. The other thing, just to point out very quickly, if we go back one, we're not going to save any of that. You've also got the DNS servers section on the network interface card as well, and we can choose to inherit our DNS servers from our virtual network, or we can add custom DNS servers as well at this point. And all of this is just a lot of flexibility that you can control individually at the resource level. Alright, so everything we've been talking about so far has been primarily focused around the Azure virtual networks and all the great software-defined networking services that we can build out there, but often we still want to connect that Azure network to our on-premises data center, and so we have a number of hybrid connectivity options available to us from Microsoft. First one, and very common, is site-to-site VPN. This is how a lot of people get going before they're ready to commit to something larger, and essentially this involves connecting your data center over a VPN device to Azure. The next one is ExpressRoute, which is kind of what people mature and gravitate towards as they adopt a lot of Azure and decide, okay, I'm ready for a dedicated circuit. Maybe I'm doing a large-scale migration. Maybe I've got a lot of data to access on premises and in the public cloud, and I've got apps running everywhere. I really want Azure to feel like a permanent extension of my data center, and ExpressRoute is a good method for that. And the third one is point-to-site, which is a very easy way to connect, say, your laptop directly into a virtual network. And we're going to cover all of these in a little bit more detail as we go through the module. So let's begin with site-to-site VPN, and you can see a couple of examples on screen right now, but let's just take a look at the top one first of all and focus on the basics of a site-to-site VPN. Well, on the one side we have our data center, in this case on premises. It's got its own IP range, and on the other side we have Azure with a VPN gateway, and essentially we just want to connect these two together. We have to have a public IP on the right hand side. You can see there we've got that VPN VIP, and on the right hand side we've got our VPN VIP there. And what we do then is we create an IPsec IKE S2S VPN tunnel between the two, and now they are connected. Now we can also do this across multiple sites, as I mentioned, so we can have multiple data centers with their own networks. Again, you can see in a lot of these examples we don't have any overlap in address space because that's obviously not going to work from a routing perspective, but multiple sites all connected in to the same VPN gateway. So there's a lot of flexibility there. If you've got a lot of offices or a lot of data centers that you want to connect in, you can do it that way. You could also create multiple VPN VIPs if you want to connect different offices into different VPN gateways and segments of Azure networks. You can really start to carve this out in multiple ways. If we look at some of those specifics, you definitely need to know for the exam, a site-to-site VPN gateway connection is a connection over IPsec/IKE. That's IKE version 1 or version 2. It requires a VPN device in your enterprise data center that has a public IP address assigned to it. It cannot be located behind a NAT, and site-to-site connections can be used for cross-premises and hybrid configurations. If you definitely take one thing away, remember those 4 points for the exam. If we look at point-to-site, then in contrast, this is really about connecting clients directly into the network. So you can see on screen there we have a number of VPN client users, on the right hand side, and they could be a mixture of laptop, remote workers, could be people at their desks, but essentially they've got a few options there. They can do an SSTP or IKE version 2 tunnel, as you see on the screen there, into the VPN gateway. Now that's just like VPNing into your corporate network. When you want to access network resources in your corporate network, you might VPN in there. Well, same thing here. You're just VPNing into Azure, and now you have access to your resources in the Azure network. The one thing I will say about this, a lot of people use this in conjunction with, say, a jump box. So you might VPN in, connect to a jump box, run it from there, or potentially look at some of the new like services like, Citrix and Microsoft's RDMI and things like that are coming out. There's a lot of ways to kind of solve these scenarios. And I'll bring that up because there's a few things you definitely need to know, especially for the exam here. Obviously, we understand it's a secure connection from an individual computer, and it's great for remote worker situations. There's no need for a VPN device or a public IP. We can connect wherever we have an internet connection. OS support is something we have to consider, so it's all Windows support primarily at the moment. Throughput and scale is the big thing, though, that we have to be concerned about. Throughput's up to 100 megabits per second, and this is unpredictable due to the internet, and it just doesn't scale easily. This is difficult to manage. It's really only useful for a few workstations that you might want to connect in this manner. Now, in addition, you also need to know about the different VPN gateway SKUs that are available to you. So if you look at the bottom there, starting with the basic SKU, it has a maximum of 10 tunnels available. For the point-to-site connections, it's 128 across all of the SKUs. But the other big difference, if you look at the basic one, it really has a maximum throughput of 100 megabits a second, so that's not very much. You really have to get into VPN Gateway 1, 2, or 3, where they start at 650 meg, going up to 1 gigabits a second on VPN Gateway 2, 1.25 on VPN Gateway 3, and those gateways allow for the max of 30 tunnels, so a lot more flexibility. If you look at it from a recommendation standpoint, pretty much if it's a production critical workload, you're not going to use the basic. You're just going to pick the VPN gateway SKU that meets your throughput requirements. If it's dev test or proof of concept, then sure, the basic SKU is fine. And then at the bottom there, you can also see we've got the SKU, whether it's basic or the VPN gateways, and just the features on the right-hand side. So if you see a few things there on the basic SKU, policy-based VPN does not support point-to-site. I already mentioned it's kind of 10 tunnels maximum. When we're looking at route-based VPN, the policy-based is only 1 tunnel. And then if we look at the VPN gateway SKUs, again, up to 30 tunnels. Point-to-site, BGP is supported, so that's the Border Gateway Protocol for routing, and you've also got custom IPsec, IKE policies, Express Route VPN can coexist, so we can have like an Express Route connection with a VPN failover as well. So that's kind of just a summary of your gateway recommendations there. Now, if we want something a little bit more dedicated, a little bit more private, better guaranteed throughput, we can move up to something like ExpressRoute. And this essentially is a dedicated circuit between us and Microsoft Azure, and it works in a number of steps. So first of all, we have our network on the left-hand side. We're going to choose a partner to work with who's going to provide that connection all the way across to the Microsoft Edge. And then we have the flexibility of looking at the private services or the public services available to us in Azure. And that's really important. If we look at the private services, this allows us to connect directly to anything we've created like VNets, etc. in Azure. The public services, in contrast, this is things like Office 365, as well as services like blob storage, PAS SQL services, Power BI, etc. These are kind of those services that are publicly exposed in a public address space, and we can choose to have those connected to our circuit, if we want to or not. Now, in addition, you've got some connectivity models that you need to choose between. There's 3 major ones available. One, very common now, is a lot of people have started to use these cloud exchanges in a colo location. That could be like an Equinix facility as an example, and they will provide the cloud exchange for you and connect you into Microsoft Azure. We could do a dedicated point-to-point Ethernet connection that could be set up with our partner, and they would help facilitate that. Or we could do something like an any-to-any IP VPN connection over a MPLS WAN type scenario. If we look at the key benefits of ExpressRoute, and there are definitely many here, but let's just hit on some of the main ones. Well, first of all, this is now providing layer 3 connectivity between our on-premises network and Microsoft Azure's network. So it adds a lot of flexibility in allowing us to share resources between the 2 data centers. It allows connectivity in all regions, so to every Microsoft Cloud service across all regions in the geopolitical region. But in addition, you can add on ExpressRoute Premium add-on, and this allows to Microsoft services across all regions with that add-on, so global connectivity at that point. In addition, we've got dynamic routing, so this uses BGP, so this is the industry standard protocol. So between our network and Microsoft, we have that all built in, and there's built-in redundancy. So in every peering location, Microsoft is ensuring redundancy of hardware at every single point along the way, so we don't need to worry about that in addition. Okay, so you've decided you want to move up to ExpressRoute, but what does it take to get all of this provisioned? Well, there is a bit of a process, and it can take many months sometimes for this to be completed. This isn't as simple as just going into Azure and clicking new service and it's up and running. There's data center work that has to be done. And so there is a workflow. Let's just kind of walk through that. First of all, ensure your prerequisites are met. So you need to have a connectivity provider identified and set up a business relationship with them. Make sure you have your Azure subscription, and you have to set up physical connectivity with your provider as well. Then you go about ordering your express route circuit. You're going to select things like your peering location, your bandwidth, your billing model, and whether or not using the standard or the premium SKU. Next, the service provider is going to provision that connectivity. You're going to provide them with some information. There's a service key you have to give them. They're going to provide you with information and get that connected. You'll work together to establish that connection. And then you can start using your express route circuit, and you can link your VNets to Azure private peering. You can link to public peering. All of that suddenly becomes available to you. Now, in addition, it's worth noting some of the data that you have to collect. And some things are very, very important, because for private peering, public peering, and Microsoft peering, you're going to have to create some /30 subnets for your paths. So for path 1 is a /30, and for path 2 is a /30. That's for private peering. For public peering, it's the same, but you must have a public IP, and same for Microsoft peering as well. So these are pieces of information you have to have on hand in order to be able to establish that circuit. And now it's very important just to know about the /30. Often in the exam, you'll get some questions around space and subnetting, and just knowing around, that those require /30s is very, very important. If we kind of look at one other aspect of this, there's the concept of unlimited versus metered. So if we look at unlimited, first of all, speeds from 50 megabits a second to 10 gigabits a second, you have unlimited inbound data transfer, unlimited outbound data transfer, but you do pay a higher monthly fee for this unlimited option. Now, naturally, if you look at the metered option, well, you still get the same speeds. So you can go from 50 to 10 gigabits a second. You've still got unlimited inbound data transfer, but the big difference is the outbound data transfer is charged at a predetermined rate for gigabyte. Now, there's a lower monthly fee for that, obviously, because you're sacrificing that outbound unlimited data transfer. And, obviously there, if you bring in data in and you're just moving into Azure, metered may be the way to go. But if you foresee a lot of traffic going both ways and just watch for questions on this, then, the unlimited option would be better for you. So to end off, let's just take a look at some of the express route considerations. There's 3 major areas. One, just understand the model. So the difference between unlimited data and metered data. If you're trying to do this in your own data center, understand what model you're using today to accelerate adoption, understand the differences in port speeds, locations, and approach, things like that. Understand the providers and what they offer. And finally, understand the costs. If you think of these 3 things, models, providers, costs, you'll be well on your way to, being able to answer any of the express route questions they might throw at you. And with that, this ends this module. Hopefully this gives you a good background on everything you need to know from a connectivity standpoint. Like I said in the exam, the questions will be focused around you picking probably the right SKUs around the VPN gateway, so definitely know those. Choosing between express route connection versus site to site, when to use point to site, things like that are likely to come up. And with that, that's the end. Thank you. Let's now take a look at routing inside of Azure, and to begin with, let's look at the system routes. Every subnet that you create has a route table that at a minimum contains the following routes. The local VNet, this is the route for local addresses, and so there's no next hop value. On premises, this is the route for defined on-premises address space that you might have in your main data center in your premises, and the next hop will always be the VNet gateway, which traverses the traffic to your on-premises data center. And finally, you'll have your internet route, and this is a route for all traffic destined to the internet, and the internet gateway is always the next hop address here. The default routing in a subnet is as follows, and if you look at the diagram on the right, it gives you the 3 major use cases, but we'll break them down a little further. 1, if the address is within the VNet address prefix, we just route to the local VNet, so we have implicit routing for VNet addresses. If the address is within the on-premises address prefixes or BGP published routes, we route to the gateway, and this is implicit routing for on-premises address on the left-hand side there. If the address is not part of the VNet or the BGP or LSN routes, we route to the internet via NAT. And then finally, we've got 2 more. If destination is an Azure data center address and express route public peering is enabled, it is routed to the gateway. Or if the destination is an Azure data center, but we're using site-to-site or an ER express route again without public peering enabled, it is routed to the host NAT for internet path. However, it doesn't actually leave the data center. Going a little further, we can also define user-defined routes. So if we look at this, this is our typical scenario with system routes that we kind of described before. And you can get more information on this by selecting the link below. But to go a little bit further, let's see what happens if we change something like this, where we have our web servers and our database servers. Currently, they can talk to each other because they're in the same virtual network, so the system route works there between the subnets. But what can we do if we want to route them through, say, a Palo Alto or something like that, or another network virtual appliance? Well, we can input a user-defined route to stipulate that all of the traffic now has to flow through this virtual appliance. And that's effectively what a user-defined route is. We go into the route table section of Azure, we define it, and then we associate it, and we force all the traffic to the appliance. And you'll see that in the upcoming demo. Last but not least, we also have one other trick up our sleeves. When we want to connect one virtual network to another one, we can use something called VNet peering. And what this allows us to do is, say we have the hub of shared infrastructure services on the right-hand side, and that virtual network, we want to be able to route to services in, say, the customer apps VNet or the data services VNet or another VNet, then we can simply peer the VNets. And that's effectively like joining them together so they can route within that same space. And now, the only problem we might have is if we want to go again, we can't daisy chain to a third one. So we can't say do another peer between customer apps VNet and another one beyond that. That won't work. It only works directly between two VNets. So you can't assume that it daisy chains along the line. But that's it for routing and VNet peering. Check out the upcoming demo and hopefully that will solidify all your knowledge in the space. In this demonstration, we're now going to show you where you go in the Azure portal to configure user-defined routes as well as configure VNet peers. So let's head straight over there. Here in the portal, the first thing we're going to do is show you how to configure the user-defined routes. To do that, simply search from the top for route. And you should see something come up called route tables. Go ahead and select that. Once you're in the route tables, by default, unless you've created any user-defined routes, you won't see anything there. Go ahead and select add. And now give your route table a name. So we'll call ours SL UDR test for my example. Choose your subscription and your resource group. And go ahead and select create. That should take about 20 seconds to deploy, and once completed you have your route table. So go ahead and select your route table. And now the way we go about doing this is to go to settings and go to routes, and then create our specific route. For example, we might want to connect to a network virtual appliance like a Palo Alto, so we might say SL NVA Palo route. We choose our address prefix for the hop, so we might say 10.0.0.0/24 for that address prefix, and then we can choose from the next hop type. You won't get an option to choose the IP unless you choose virtual appliance. So you can see there that now I'm able to enter my next hop address. So this could be a hop in a different subnet for that gateway appliance. So 10.0, let's say 5.90, for example, that could be where that appliance sits, and hit OK. And after about 30 seconds or so, that route will get created. Now the routes themselves aren't any use unless you associate them with a subnet. So now that that route's been added, if I just refresh, you can see that route there. It won't actually do anything unless I go into subnet and associate this whole entire route table with my virtual network. So I could select one there and select my subnet as well. So this is just an example for you. I'm not going to do it in this case, but hopefully that shows you that you could design an entire route table and then associate it with multiple virtual networks and subnets that you see fit. Now the second thing we need to do is go back and look at the peering. So if we go to virtual networks, and we see we've got our two networks there. Let's see what happens if we try to peer these. To do that, we can go into 7533-portal, scroll down, and you'll see the section called peerings. And go here and select add to add a new peering, and give it a name. But what you'll notice, let's call this SL test for the moment because it's not actually going to work. If we go down to virtual network, choose a virtual network, and you can see there's nothing it can peer with. And the reason for that is that everything there has overlap in address space, which naturally will not work because we won't be able to route to it. So let's cancel out of this. Let's create a new virtual network. We'll go back to virtual networks, select add. We'll call this one SL-70533-peer. And let's give it an address space. Now watch here, if we type in 10.0.2.0/23, it'll actually tell us already when we build in VNets, which is okay. We could, if we wanted to, build lots of VNets with overlap in address space if we didn't want to, but you can see here it does warn us that there's overlap in address space. So I'm not going to use this one. I'm actually going to use 10.04.0/23 as well. And other subscriptions, use pay-as-you-go, choose your resource group, and scroll down. I've got to create a default subnet for this one, which I'll just choose the first one, /24. I'll put that in the right box, there we go, and then give it a name. And with that, go ahead and create that VNet. Just refresh, probably take a few seconds, there we go. And now if I go into that VNet, into peer, and I go down to peerings, I can now click add, in name again, and I can choose my virtual network, and you will see that portal and my other VNet, the pshell one, are both available because they do not have overlap in address space. And so we'll just select one of those for now, just to show you the rest of the settings available to you here. You've also got things like allow forwarded traffic. And this basically says that I'm going to allow forwarded traffic from outside of the peered VNet. So traffic that's destined for this virtual network, but came from outside the peered VNet. The other two that I've got here is around gateway. So I can allow gateway transit. This allows the peered network to use the gateway in this VNet and essentially use it to traverse maybe to on-premises as an example. And then the other option is use remote gateways. And to use remote gateways, I do have to allow gateway transit. It requires that to be checked, but then allows this network to use the peer's gateway instead. And with that, that's everything you need to know around user-defined routes and peerings. And I'm going to go ahead and close this out, and that's the end of this demo. Okay, so to begin this module, it helps just to do a little bit of a recap on our different connectivity options so you can choose the right type for your scenario that perhaps you'll be given in the exam. And in the previous module, we covered these in more detail. So this is really just a recap. Well, first of all, we have site-to-site VPN again. So this allows us to connect our on-premises data center through a VPN device to a VPN gateway in Azure, essentially extending our network to Azure through that VPN gateway, but it does go across the internet. Same for multi-site. We could do this for multiple data centers connected to the same VPN gateway. Also goes across the internet. Now it is secure via IPsec, it's using that IPsec tunnel, but it's something to consider there. Next, we have ExpressRoute, and when you think ExpressRoute, think of two things that would lead you to this over site-to-site VPN. One is privacy of data, so if you don't want to go over the internet and you want that extra layer of security, this is a dedicated circuit, and you can choose whether to pair with the public services or just the private services in Azure. The other thing is bandwidth. If you want a more reliable, higher throughput, but just more reliable throughput, as opposed to going through the internet, ExpressRoute will give you that. The next type of connection that Microsoft wants you to know about is something called a hybrid connection. And essentially, this allows a web app, say on the left-hand side of the diagram here, to talk to the data in our data center. So perhaps we're using public cloud services in Azure, like web apps and mobile services that need to talk to a SQL server on premises. Well, a hybrid connection is the way we can go about doing this. And a hybrid connection can be shared across web apps and mobile apps. So you can use one hybrid connection there. And all web app frameworks are supported, as you'll see in a moment. Now, if we look at this from a scenario perspective, there's a number here. First of all, you might have a .NET framework that wants to access a SQL server. You could have a .NET framework, access to HTTP services with a web client. We could have PHP access to a SQL server, MySQL server, Java access to a SQL server, MySQL and Oracle, and Java access to HTTP and HTTPS services as well. Now, if you look at all of these are predominantly web and mobile type application frameworks that, again, all need to access some element of data services that they haven't got available to them in the public cloud and need to go back on premises using a hybrid connection for this. The other thing to note is that there is a hybrid connection manager that you saw in the diagram previously, and it can be installed on the following operating systems. So it's Windows Server 2008 R2. Note that you need .NET Framework 4.5 and the Windows Management Framework 4.0 in addition. You also can do it on Windows Server 2012 with the Windows Management Framework 4.0 or higher being required. And finally, you can install it natively on Windows Server 2012 R2. And providing you have all of that set up, then you can set up that hybrid connection. And that's really it for this module. It's a bit of a short one, but the idea is if you've read and listened to everything in the previous modules, it's really about just knowing, okay, when do I use site-to-site? When do I use ExpressRoute? When can I even use point-to-site connection that we covered previously as well? And then when does this hybrid connection manager come into play? And if you just understand the use cases and read the dialogue and the questions, you'll definitely be able to get through it just fine. Let's take a look now at internet access and DNS and how Azure handles that. So for internet access, the first thing is all resources in a virtual network can communicate to the internet by default. The way this happens is the private IP that they're given is source net address translated to a public IP which Azure selects. Outbound connectivity can be restricted via routes, so we could use user-defined routes and redirect the traffic maybe to a network virtual appliance, or perhaps we want to send it back through our internet access through on-premises, or we can use traffic filtering, things like network security groups to restrict access. Finally, if we do want inbound connectivity and we can't use source net address translation, so this is someone coming into us directly from the internet, we haven't made a request out, then we do require a public IP address. But how then do we handle DNS? Well, there's a couple of things that we need to consider. One is Azure provided DNS. So this is the default behavior. Microsoft provides DNS as a complete service to you, so you can resolve all of Azure services. Your VM host names can resolve each other inside the same VNet. And you do have the option also of providing your own DNS server. So this could be something like an infrastructure as a service VM, where you've installed a DNS server on top of that. So it could be Active Directory DNS as an example, or it could be like an Infoblox virtual appliance that you decide you want to deploy out in Azure. Okay, so how do we choose between customer managed DNS or Azure provided DNS? Well, there's a few scenarios that we should cover. The first one being if name resolution is just within the same virtual network, the recommendation is to go to Azure provided DNS. If name resolution between role instances or virtual machines is in different networks, then we should probably think about going to customer managed DNS servers again, whether that's Infoblox or some IaaS type DNS server that you have. Now, when we start to look at on-premises, so if we're trying to resolve on-premises computers and services from role instances or VMs in Azure, we almost certainly want to go to customer managed DNS. And then this DNS will propagate throughout our whole network and we'll be able to resolve host names on premises. And in return, the final scenario, we might have on-premises computers that want to resolve Azure host names. So again, customer managed DNS. And as I mentioned, you can just have your customer managed DNS servers set up a forward on them if you need to forward to Azure-based DNS. So how then do we go about configuring DNS? Well, at the VNet level, you simply select a virtual network in Azure, select DNS from the pane on the left-hand side, and by default, it will be on Azure provided. Just change that to custom if you want to choose your own DNS servers, add your DNS servers, preferably more than one, obviously, and select save. And note this piece here, virtual machines within this virtual network must be restarted to utilize the updated DNS server settings. So keep note of that. If you think things aren't working right well, it's probably because you haven't restarted the virtual machine. The other thing to note is that you can also apply this at the individual virtual machine level as well. So you can go there and update the DNS servers for the network card in that aspect too. One of the core security components for networking in Azure are NSGs, also known as network security groups. And what are they? They're essentially a traffic filter, a network filter that's checking traffic. Think of it like a firewall, and it basically allows or restricts traffic to resources in our Azure network. There are two types of rules. There are inbound rules and outbound rules that you'll see in the upcoming flow that we'll walk through. And finally, they can be associated to a subnet or a network interface card. And it's very important, something I'll reinforce over and over throughout the section. Finally, it is worth noting that in classic Azure, you were able to associate NSGs with the virtual machine itself, but that changed under the ARM model. And now you've got the network interface card and the subnet that you can associate with only. Now, if we look at this from a flow perspective, if we've got some virtual machines in subnet B that wish to communicate with virtual machines in subnet A, we ultimately go through this kind of traffic flow. The virtual machine in subnet B wants to communicate with this virtual machine in subnet A, and the traffic goes out through the subnet NSG in this example. And that NSG is going to check it from an outbound rules perspective. If it's all okay there, then the traffic will continue on to subnet A. The NSG in subnet A will check it from an inbound rules perspective, and then if everything's okay, allow it to talk to the virtual machine in subnet A. Now again, this can be applied at the network interface or subnet level, and the subnet rules apply to all the resources in the subnet. Now think about this from a rule precedence perspective. If the NSG is applied to the network interface card and the traffic is coming outbound, it may never even reach the subnet NSG. That network interface card overrules the subnet policy. The same in reverse. If we're coming into the subnet, and let's say that the NSG associated with the subnet allows the traffic in, it'll get to the virtual machine, and then the network interface card can still deny it. So just think of it from that perspective. It gets denied, outbound first from the network interface card, then to the NSG on the subnet. If it's reversing coming inbound, the traffic is stopped potentially first at the subnet NSG and then again at the network interface card NSG. Now, what are some of the properties that you configure when you create a network security group? Well, aside from just giving it a name, we have to define these things. One is the protocol that we want to allow. For example, it could be TCP or UDP. Second, the source and destination port range. So anything in the range from 1 to 65,535, or we could simply choose a star for all ports. We have our source and destination address prefixes. So this could be our ranges, or we could use default tags, which I'll come on to shortly. We can do our direction, so inbound or outbound. That's obviously a natural property there, and that, as we went through the flow previously, that's going to determine where things are going to be stopped. The priority, which I'll also come on to in a moment, so that's, in what order are these rules evaluated, and then whether we choose to allow access or deny access based on the rule we've just defined. So we set the criteria, and then at the end we say allow or deny. So what about rule priority that I mentioned? Well, rules are enforced based on priority. As you can see there, they have a range from 100 to 4,096, and the lower numbers have the highest priority. So if you've got a rule that's 100, that's going to be a higher priority than a rule that's, lower down the spectrum, closer to the 4,096. So hopefully that gives you an idea there. Now, the default tags I mentioned are also really important because they can make things a little bit simpler when we're trying to restrict certain ranges of IP address. And these are system provided to identify groups of IP addresses that Azure has provided for you. And there are three major ones that you need to deal with. First of all is your virtual network. So this includes all the CIDR ranges defined in Azure for virtual networks. In addition, you've got your Azure load balancer. This is Microsoft Azure's infrastructure load balancer, i.e. this is an Azure data center IP address. And finally, we have internet. So this is all Azure space outside and reachable by the public internet. And this includes all of the Azure-owned public IP space. Now, if you're still unsure what these are for, just remember when we create our rules, we can choose to use service tags instead. So rather than us having to try and figure out all these IPs that we want to deny in these services where there's groups and groups of IPs, we can simply use the default tag instead. And this just makes it a lot easier for us to say, okay, I don't want to allow any traffic to Azure Load Balancer, well, I can use a default tag for that. Now, when we look at the NSGs and we've created one, there are a number of default rules that are created as well. And we've got the inbound and outbound rules on screen for you. And they essentially are the same if you look at the categories across them. So if we look at the top row in both inbound and outbound, which is called allow VNet inbound and allow VNet outbound, this is for traffic originating and ending in a virtual network. And this is allowed for both inbound and outbound directions, as you can see there. Then you have internet on the bottom there. This is allowed by default out, but is blocked coming in. And finally, in the middle row there, we have our Azure load balancer. And this allows the load balancer to probe the health of your VMs and role instances. Now, you can change these rules, but you can't delete them. They have to be there in the network security group. By default, what you will notice is that the priorities are very, very low. So they're not set to a high priority. A lot of the rules you create will be given a higher precedence over these ones. One final thing we just need to cover on networking is around networking limits. And you can see the limits on screen. You can get the latest limits by checking on the Azure website. Now there's a couple I'll just bring your attention to. For one, there's a default limit for network security groups of 100, but this can be increased very easily to 400. NSG rules per an NSG, we're looking at a default of 200, but this can be increased to 500. But the other ones I'll bring your attention to are public IP addresses, which for dynamic ones you can have 60, for reserved public IP addresses 20, and to actually get those increased you have to contact support, and they don't like to increase those very easily. So that's just something to be aware of there as you're thinking through some of your network configurations. In this demonstration, we're now going to create and configure a network security group in the Azure portal. So let's head over there. In the portal, to create our network security group, simply select Create a Resource, select from the Networking section, scroll down, and you will see Network Security Group. Select that, and give your network security group a name. In my case, I'm just calling it SL-NSG. I'm using a pay-as-you-go subscription, and I'm going to put this in our network resource group that we've been utilizing. Go ahead and click Create. This simply creates the shell, if you will, for the network security group. Takes about 10 or 15 seconds. And once completed, we'll go to that resource so we can begin configuring it. So as I mentioned in the tutorials, there's a number of default rules. So you can see them there, the inbound security rules and outbound security rules. But we're going to go ahead and create a new inbound security rule. Let's say we want to deny RDP traffic to a specific subnet. So we would go into inbound security rules. And in there, we click Add. And now we get all of our options. So first of all, we can choose our source. This could be any, could be a specific IP address, or could be one of those default tags we described. I'll just show you that for the moment. If we look at the default tags, we can choose Internet, Virtual Network, Azure Load Balancer, as well as other specific services available in Azure. But if we go ahead and select any, and we'll choose the port range. So in our case, any port could be the originator. The destination could be any, and we're going to say for port 3389, which is the port for RDP over any protocol, deny. And here we can now choose the priority for the rule. So in this case, 100, this is the highest priority. It's going to override everything else. We can give it a name. We'll just accept the default one that's provided to us. If we select OK, this creates the inbound security rule, takes a couple of seconds, and that will appear in your network security group. The next thing we need to do while it's creating that is decide where we want to associate this. So for example, we could associate it with a network interface, and we can go in there, select Associate, and choose one of the network interfaces that's available to us on perhaps one of our virtual machines. Now, as you can see in this example, all of our virtual machines, their network interface cards are already associated with NSGs that were created when they were built, so they're all grayed out. But now maybe I want to associate it with the subnet, so I can select the subnet, choose Associate, and now I select the virtual network first of all. In this case, I'm going to use the only one I've got created currently, followed by my subnet. I'm going to choose subnet A, select OK. And now any traffic destined for subnet A on ports 3389 will be denied. Now, it's very important to remember the precedence of rules associated with NSGs. So inbound traffic coming into that subnet could get denied by the network security group that we created there that's associated with the subnet. Now, perhaps it gets allowed through. We don't have that deny rule for 3389, but we have another network security group associated with the network interface card on the VM. It can further get denied at that level. And in reverse, when we're going outbound, we could have outbound rules attached to the network interface that deny all traffic before it even gets to the subnet rule. And then when it gets to the subnet rule again, we could have an NSG there that's denying traffic or allowing traffic out. So just remember the rule precedence there, especially for the exam. And with that, this concludes this demonstration. Let's now take a look at the Azure load balancing services you're expected to know about for the exam. And first of all, we have Azure Load Balancer. This is the most common one. This works at the transport layer, so think layer 4 in the OSI network reference stack. It provides network level distribution of traffic across instances of an application running in the same Azure data center. Now, in contrast to Load Balancer, we have Application Gateway. This works at layer 7, the application layer. It also acts as a reverse proxy service, terminating the client connection and forwarding requests to backend endpoints. And finally, we have Traffic Manager. Think global scale, globally distributed endpoints. This works at the DNS level, so we might have applications running in multiple regions and users coming in from multiple locations. That's where we would utilize Traffic Manager. Now, in more detail, let's look at Azure Load Balancer first of all. So as I mentioned, it's layer 4. It's important to know that there's basic and standard SKUs now available. Now, the standard SKUs are in preview. They're not required for the exam, so you're only expected to know about the basic one, but just know that's coming out, and we'll certainly update the material when that actually happens. You have something called service monitoring as a feature. This allows Azure Load Balancer to probe the health of various server instances behind the load balancer. When a probe fails to respond, the load balancer can stop sending new connections to the unhealthy, let's say, virtual machines that are behind the load balancer. We have something called automatic reconfiguration as well. So this can reconfigure itself automatically when you scale instances up or down, perhaps when you add new web server instances as an example. Next, we have something called hash-based distribution, and this is how Azure Load Balancer distributes its traffic. And by default, it uses a 5-tuple hash composed of a source IP, a source port, destination IP and destination port, and protocol type to map traffic to the available servers. It also provides stickiness only within a transport session. So this means that if a client comes back, has the same session, they will continue to connect to their same, say, web server behind the load balancer as well. And finally, there's internal and public options. And you'll see some of the examples in a minute, but just know you can configure an internal load balancer for traffic to hit it and then disperse for internal applications, or it could be people coming over the internet and you want to expose a public IP, and then, once they hit that load balancer, then we pass traffic to the servers behind the load balancer. So let's look at some of those examples. First of all, look at an internal example. And in this case, we have our internal load balancer at the top there, which has a private IP associated with it. That can be dynamic or static as well. You can decide how you configure that. And then we could have, say, 2 database servers behind the load balancer. Traffic will hit the private IP and then be sent over to one of either DB1 or DB2. Now let's look at a public example where if we look at the load balancer, which is in the center of the screen, the traffic would come through the cloud at the top there over TCP port 80, and then we would pass the traffic down to one of the 3 available web servers that are behind the load balancer there. Now you're also going to get multi-tier examples as well. So in this case, you might see traffic come in and hit one of the 2 load balancers. First of all, traffic from the public cloud would come in and hit that web load balancer at the top, and then that would pass the traffic down to the web tier. Now those virtual machines that are perhaps the websites would then pass traffic to another load balancer when they want to query the database. So in this case, the second load balancer there goes in front of the database servers, and the web servers just query the database server. Now it's also possible then that people internal could just hit that database server if they wanted to from other applications as well. Could be coming from the website. It opens up a host of options for you there. So let's shift our attention now to the App Gateway, the other load balancer that's available to us from Azure. And first of all, it's layer 7 app load balancing, as I mentioned before. So just keep that in mind the whole time. When we want application load balancing, we need App Gateway. When we want just layer 4 load balancing, we can get away with just Azure Load Balancer. But a couple of unique features as well are important. So cookie-based session affinity, this is a common requirement for many web applications. And this is required so that a user can maintain the same user session on a backend server. It also supports SSL offload, so all those decryption tasks, etc., that web servers would normally have to deal with. They don't have to deal with that now. They can offload that to App Gateway and it can take care of it for them. We also have end-to-end SSL. So App Gateway supports end-to-end encryption of traffic. It does this by terminating the SSL connection at the App Gateway and then applies routing rules to all of the traffic. And then it re-encrypts the packet and forwards it to the appropriate backend based on the routing rules that you've defined. In addition, one of the most popular new features that they added recently was around web application firewall. And this has become a key feature. When you enable this, it provides protection for web applications from a lot of, common web vulnerabilities and exploits. This can include like SQL injection, cross-site scripting, things like that. And you also have URL-based content routing, and this allows us for directing traffic to different backend servers based on the content that the user is actually requesting. A different server can serve that content up. And finally, one very important thing is App Gateway does require its own subnet, and you need to create that subnet before you can create your App Gateway, and you'll see this in the upcoming demonstration. In addition, there's a few things you need to know around App Gateway sizes. In the following table, this shows you an average performance throughput for each application gateway instance, and this is shown with SSL offload enabled. And Microsoft does make a caveat on their website for this. These values are approximate values for an application gateway throughput. The actual throughput depends on various environment details, such as your page size, the location of the backend instances, and the processing time to serve up a page. So just keep that in mind as well. Finally, if we just take a look at a comparison overall, we covered Azure Load Balancer, we've covered App Gateway, and we've covered Traffic Manager just very briefly there. So just think at the top level technology, what am I trying to do? So if I need layer 4, Azure Load Balancer, if I need layer 7, App Gateway, and if it's something more geographically dispersed, think DNS level, think Traffic Manager in that context. As far as endpoint monitoring, it's worth noting at the bottom, it's all supported via probes for Azure Load Balancer and Application Gateway, but Traffic Manager is supported via HTTP and HTTPS GET requests. As far as endpoints go, that's the other different feature there. Azure Load Balancer supports Azure VMs and Cloud Services role instances. Application Gateway supports any Azure internal IP address, public internet IP address, Azure VM, or Azure Cloud Service. And Traffic Manager supports Azure VMs, Cloud Services again, Azure Web Apps, and external endpoints as well. So that's just a brief summary there of all the different load balancing technologies for you. But that's it for this tutorial section. I encourage you to check out the subsequent demos. In this demonstration, we're now going to go about configuring a load balancer in Azure. So let's head straight over to the Azure portal. Okay, and in the Azure portal, just to set the stage for everything, if we go over to virtual machines, you'll notice that I have 3 virtual machines for this demonstration. I've got a jump box that I can RDP into over a public IP address. I've got 2 virtual machines, SL Test VM01 and SL Test VM02. Both of those VMs are running a simple IIS website. So if I just go into, say, Test VM02, and I'll connect in there. And if I open it up and just type in HTTP localhost, on each VM I've just got a basic web page that's been served up and just identifies the virtual machine. So we'll go back to the Azure portal, and let's now go ahead and create our load balancer. So let's go to create a resource, select networking, select load balancer, and we first have to go about creating the front end portion of the load balancer. So in my case, I'm going to call this SL-internal, because we're going to create an internal load balancer -LB. And I can select here between public and internal. So we're going to choose internal, but let me just go back and show you public for the moment. When I choose public, I can choose a public IP address. This could be one I've already got created, and it can't obviously be associated with another machine already or another load balancer already. And if I want to, I can just go in here and create a new public IP, much like I would anytime I created a public IP address. But I'm going to do this internal for the moment. So let's hit internal. And when I do it as internal, I get a choice of the network. So I'm going to choose my VNet, and I'm going to choose my subnet. In this case, I'm going to choose subnet A, and you can see then I can choose how the IP address is assigned. So I can choose to statically assign the IP and just type it in this box, or I can choose dynamic, and Azure will assign one to the load balancer. Then I've got my subscription and my resource group, much like every other service we create. So I'm going to use SL-network for my resource group, and I'm deploying this in North Central. So that's the front end portion of the load balancer. And if I hit create, and we'll fast forward while that creates, should take just under a minute for it to complete. And that's completed, so we'll go to that resource, And now I can start the back-end portion of the load balancer. So you can see the configuration screen. On the left-hand side, if I select front-end IP configuration, you'll see the IP that's been allocated 10007. That's because we made it dynamic. But now I can start configuring these three things underneath: the back-end pools, health probes, and the load balancing rules. And I'll do them in that order. So we'll start with back-end pools. And the first thing we need to do is click Add, and give it a name. So we'll just call this SL Web Backend. And now I choose how I want to associate this. So I can select this drop down, and I can associate it with a single virtual machine or a virtual machine scale set, or in my case, I'm going to choose an availability set that I already have. Select that drop down, we'll select SLAS-web. That's my availability set with my 2 web servers running in it. Select that, and now this is very important. You need to add your target network IP configuration. So you're going to need to do 2 of these, one for each virtual machine. So we'll select this box, scroll down, choose our target virtual machines. I'll do number 1 first of all. You can see it's got one network interface, and if you hit this drop down, select the IP, and then we'll select add again, and now we will do number 2. Select its IP, and go ahead and select OK, and that will now create that backend pool. Just hit refresh. You can see SL Web Backend already there. It's still actually provisioning, so it's got one virtual machine in there now. Refresh again. And there you can see we have 2 virtual machines. If I expand it out, both of those are running and are in the backend pool. The next thing we need to do now is add our health probes, which essentially monitor the virtual machines and check they're healthy and available. So let's go over to health probes, select add, give it a name, and then choose the protocol that you wish to check for. So in my case, I'm actually going to just select HTTP, and then I could select port 80, give it a path, but these parts are really important at the bottom. The interval is the amount of time between probe attempts in seconds. So every 5 seconds, it's going to check health status. And unhealthy threshold, this is the number of failures that have to occur before it considers the VM behind the load balancer unhealthy and will then take it out of the pool. And that's all there is to the probe. Go ahead and click OK. Take about 30 seconds or so, wait for this to update before you go on to the next piece. Okay, and as you can see, our probe is now there. It's still updating, so we'll just give that a few more seconds. There we go. And now we go over to load balancing rules. So in load balancing rules, this is where it all comes together. Select add, and now we give it a name. So we'll just call this SLLB rule. And I can choose my IPv version, so 4 or 6. In this case, we're using version 4. But now I select my front-end IP address. In this case, I choose that one I created previously, 10007. I choose my protocol, so in my case, I'm going to use port 80. And then I choose my backend port, followed by my backend pool. So in this case, I'm using that backend pool that I created, SL Web Backend. If I expand that out, you can see that's the only one I've got there, followed by my health probe, which is for port 80, HTTP. Now, if we scroll down, there's a few more settings. For example, session persistence. This allows me to maintain session state based on either the client IP or the client IP combined with the protocol. In addition, I have my idle timeout, and finally, floating IP. This is really for SQL, always on availability groups that you would use this. But if I go ahead and select OK, this is now going to update the load balancer configuration. So again, we'll fast forward here. It'll probably take about a minute. Okay, and we can see that that load balancing rule was created successfully. Let's go back to the overview and just grab our IP address, in this case 10007, and let's head over to our jump box machine to test it out. And so I'm just going to fast forward here as I RDP into the jump box. It's a VM in the exact same subnet as our test VMs. So we're now in the jump box itself, and let's open up a web browser. And if we type in 10007, and that is all there is to it. Both of those VMs are now successfully in an availability set that we created previously when we built the VM, so they're highly available across 2 fault domains, and they are successfully behind a load balancer as well, so traffic is being dispersed between both of them. And with that, this concludes this demonstration. In this demonstration, we're now going to go about configuring an application gateway in the Azure portal. In the portal, much like with the traditional load balancer we configured, go ahead and select Create a Resource, select Networking, and you'll find App Gateway just below Load Balancer there. Now we need to put in our basic settings, so let's give it a name, followed by our tier, so you've got Standard, and then WAF, which stands for Web Application Firewall. Choose your SKU size, depending on the traffic you're expecting, followed by the instance count. The minimum recommended for production workloads is always 2 to ensure high availability. Select your subscription, and select your resource group. One thing we need to take note of though is our location. In this case, we're selecting North Central US. It has to be in the same location as our virtual network and public IP address. So go ahead and select OK. And now we choose some of the more specific settings around our network. So if we choose our virtual network, we'll choose our SL70533-portal that we've been using, and notice that it only gives me the option of subnet B, and this is because we already have systems configured in subnet A, and it has to be in its own subnet. We then choose our IP address type, so we can have public or private again, and if we want to choose our public IP address, we select it here, and we can go ahead and create a brand new public IP address directly from that screen. Our listener configuration, whether it's HTTP traffic or HTTPS, and again we have the option of selecting whether we want to use the web application firewall, but we need to obviously select that tier for that to happen. And with that, simply select OK, confirm the summary, select OK again. Okay, and after a while, if everything's successful, you'll see your application gateway completed and listed on the application gateways. It does take a while. It can take, 15 plus minutes for this to provision. And if we go into this gateway that's provisioned, you'll see this one is actually still updating. So it's still provisioning some of the configuration there. On the screen, you'll get the overview, much like with any Azure service. There is a monitoring pane. You can scroll down. You can see the throughput for the past hour directly on the screen. On the left-hand side, I'll just point out a few configuration areas that are worth noting. One, you can turn on your web application firewall later on if you wish. You can add your backend pools in this location. So I go to backend pools. This is where I can add those. I've got HTTP settings. So I mentioned this is a layer 7 load balancer and gives us some of that extra functionality. So this is where, for example, in this HTTP setting, I can go in there and I can actually turn on cookie-based affinity for HTTP just by selecting this box on the screen. And so there's a number of settings there. If we scroll further down again, you've got your listeners, your rules, and your health probes. All of that is configurable from the section in the Azure portal. And with that, this concludes this demonstration, and hopefully that gives you some insight into how to create and configure your application gateway. In this demonstration, we're now going to take a look at Network Watcher. So to begin with, let's head over to the Azure portal. Okay, and here we are on the Azure portal, and the first thing I've done, I'm just showing you that I've deployed 3 virtual machines already. I've got VM test 01, 02, and 03, and they're all in the resource group SL-Network Watcher, which I've already created. Now, one thing to note, first of all, in order to use Network Watcher, you do have to install a Network Watcher agent in the machines that you might want to use the connection monitor feature with. So here's an example. If I go to VM test 02 and scroll down on the left-hand side, you'll see the section called extensions, which if you did the AZ100 exam or other Azure training, you will probably be aware of. And this is where you can add different extensions, agents, chef agents, things like that. But one in particular is that Network Watcher extension. You can see it's already installed on this one, and this is a Windows machine. If I go over to VM test 03, this is a Linux machine where we've also installed, then you can see it's operating system Linux here. And if we go to extensions, and you can see again the Network Watcher agent is there. But just to show you how to install that, I'm going to go to test 01 where I haven't installed it yet. This is also a Windows machine. And we'll go down to extensions, click add, scroll down the left-hand side, and you will see Network Watcher agent for Windows. And when you're building your virtual machines for the first time, you can also do it during provisioning. But we'll click Network Watcher agent for Windows, click create on the right-hand side, click OK. And you can see it's initializing that deployment, and it's now deploying that agent. So it's logging into the machine and actually setting up that agent service to run inside the machine. So at this point, we can come out of the virtual machines, and let's focus now on Network Watcher itself. To access it, click All Services, type in Network Watcher, and you'll see it there. It's probably worth favoriting it because you'll probably come back to it periodically. Click Network Watcher, and this takes you into the Network Watcher overview section first of all. Now on the right, you'll see your subscriptions, and you'll see the regions that are supported by those subscriptions. In my case, I've got Skyline's Primary is the one I want to use. If I expand this out, I can see the regions and whether Network Watcher is enabled or not in that particular region. So I've deployed these machines in North Central. I've already actually enabled Network Watcher in that region. Let's say I had deployed them in South Central. Well, I would just go over to South Central US, click these 3 little dots on the right for the context menu, and click Enable Network Watcher, and that will deploy the Network Watcher to that specific region as well. So just be aware of that. That's how you enable it. And you may get some questions on this on the exam itself. So with those enabled, let's take a look first of all at the topology view. So I can click this. This is under the monitoring section, choose my subscription, Skyline's Primary, select my resource group, SL Network Watcher, and immediately it will actually load up and show me, okay, I've got my VNet, my subnet, I've got 3 network interfaces in there, and those are the network interfaces associated with those 3 VMs respectively. So it's quite a nice way to just get a viewpoint of what's going on in your environment, and you can also download that topology if you want to as well. Next, we'll take a look at Connection Monitor. So let's click Connection Monitor on the left-hand side. And what we can do with Connection Monitor is basically track the connection between, say, two of our virtual machines for latency, can they reach each other, etc. So we click the Add button here to create a new monitor, and we'll say from VM Test 02 to VM Test 03. And we choose our subscription and the virtual machine, so we'll choose VM Test 02. And our target machine, VM Test 03. And we'll say port 22, which is our SSH port that we want to connect over. Again, we're connecting from the Windows machine to the Linux machine. We'll click Add at this point, and that will set up the connection monitor for us. Okay, and after a little while, that should complete. If you don't see it, just change the subscription to the one you created the monitor in, and then it should show up for you there. And here you can see the monitor, and if you click the context menu, you can start, stop, or delete that monitor from there. Now, to get the details, you need to click this details pane on the bottom, expand it out, and you might just need to move it up ever so slightly. Then you can scroll down, and now you can see details from that monitor. So we can see, if we scroll down, average round trip time 1 millisecond, so we know everything's working great there. No probes have failed at this point. We can also get some more information, so we can see that VM Test 02 is connected on 10.0.0.5. Its next hop IP address to reach that machine is 10.0.0.6, which is actually the IP of VM Test 03. If we scroll back up as well, you could get metrics on this. You can see the graph, you can sort of change the time, look at the data. And if you scroll down again, you can also create a topology view to kind of look at the connection between those two machines. So in this case, nothing big there. VM Test 02 is going to basically, as its next hop, go into that VNet, which VM Test 03 is in, and it's basically going to connect over 10.0.0.6. So just a great, area for just monitoring connections between machines and just checking the overall health of them as well. So now we've covered Connection Monitor. Let's scroll back over to the left. You'll notice you now have a link for Network Performance Monitor. They recently added this. We're not going to cover details of NPM in this course. We sort of mentioned it in the lecture section, so you need to know what all the NPM monitors are for, but this is where you would add your NPM monitors that are as part of your log analytics workspace at this point. What you do need to know, however, is these things around IP flow verify, next hop, and security group view. So if we start with IP flow verify, this is a way to check if a packet is allowed or denied from a virtual machine. So again, we can sort of go in here, choose our subscription, pick our resource groups, already got it there, SL Network Watcher, pick our virtual machine. We'll take VM Test 01 at this point. It'll automatically select this interface once you've selected the virtual machine, and say, okay, well, what about an outbound flow? So let's say we want to go from VM Test 01. Let's say we want to ping the Bing address as an example. Let's go ahead and type the information in for that. So local port will have 60,000. We'll just put just a random local port there. And for our remote address, this is the Bing IP, which is 13.107.21.200. You could use any favorite website that you have there. And remote port, we know this is going to be on port 80, which is the web port that we want to check against. And at this point, we click check. It'll take a second. If you scroll down, you'll see it says load in. And a minute later, maybe not even, you'll be able to scroll down even further. There we go, it's actually already done. And you can see access allowed, and the security rule that's allowed, and that is the allow internet outbound rule. So very simple way to kind of check things, are working from a connectivity standpoint. And if it's denied, it's going to tell you which rule basically denies it. And at that point, I'm just going to hop over to security group view, click OK to, we don't need to save anything there. And basically same concept. I can click in here, click say Skylight's primary, choose my resource group, choose my network interface. Go select our virtual machine first of all. So we'll click VM Test 01, choose that network interface, and same thing here. You're going to get a list of all the effective rules that are in effect for that particular network interface and where they're coming from. You could, if you want, isolate them down by subnet rules and network interface rules. So you can see there, these are the network interface rules, these are the subnet rules, but these are the, ultimately the effective rules themselves. And you can click in on one of these rules if you want to, like deny internet outbound. If there's any additional information, it would be there. If we scroll to the right-hand side, you can also see the protocol and whether it's denied or allowed here as well. So just a overall viewpoint, instead of going back into the NSG to kind of look at things one at a time, you can just come in here, select the interface you want, and download this rule set if you want to as well. Last but not least, next hop is quite useful as well. You actually get some of this from that connection monitor that you may have seen earlier on. But same thing here, I can click my subscription. I've got my resource group there, I've got my machine, go VM Test 01 again, I've got my network interface, source IP address, and let's say, that next destination, let's say it was the Bing server again. This just tells you what the next hop will be for that particular, website or whatever IP you're trying to get to. So we click next hop after typing that in. Won't take too long, just probably about 10 seconds again, just like before. And as soon as that's done, you can see result, next hop type internet, IP address doesn't really have one there. It's going straight out to the internet itself. Now, if we do 10.0.0.5, which is one of the other machines in that subnet, click next hop, you'll notice again, we're not going to have a next hop specific IP because it's a machine that's in the same VNet, so you should get a virtual network as your next hop. Next hop type, yep, virtual network, no specific IP there. And you can see this is coming from the route table, the system route, the built-in routes that exist in the subnet, itself. Now, if we had something like a Palo Alto or a checkpoint firewall and we'd put user-defined routes in that were redirecting the traffic through a firewall like an IDS IPS device, then we would see that IP address there because we've redirected the traffic into that IP, and then the rule sets would be applied on one of those network virtual appliances. A few other quick things just so to round out the knowledge there. We've got VPN troubleshoot itself. If we're trying to troubleshoot any site-to-site VPN type connections, we can basically do that here. We've got packet capture as well. This is quite useful. You click add, and essentially you can do the same thing. You can select the resource group. We'll select our subscription first. Choose the resource group, choose the machine, give it a test capture. Basically what it will do is capture, whether you want a maximum or minimum is up to you, and how long you want to capture for and any filters you want to put on. But this is essentially a packet capture that will output as a .cap file and store that in a storage account for you. Probably won't get asked anything on the exam around packet capturing, just know that this is where you would go to do it. And then we also have connection troubleshoot as well. Similar, framework here, you've got your subscription, resource group, VM, destination, but here is your probe settings that you would basically put in place. So for a destination port, a specific one, you could use this also as a way to kind of check a TCP connection from a VM to either an FQDN or another IPv4 address. But somewhat redundant in some cases to some of the other checks you've got there. It just depends what you're trying to do. For connection monitor, you do have to have, again, those agents running on both those machines. Some of the other services you don't, basically. So just try to understand what it is you're trying to achieve. If you're trying to monitor the connection between two machines, connection monitor is where you want to go. If you're trying to understand if traffic is allowed and what might be denying it, IP flow verifier is where you would go. If you're just trying to figure out, okay, what's the next hop? What has it got to go to next? The next hop view would be where you'd want to go. And then these others kind of support you as well for other specific things like packet captures, VPN troubleshooting, etc. So just definitely know for the exam the type of diagnostic tool or monitor you would basically use, because those are the kinds of questions you're likely to see out there. And with that, this concludes this demonstration. Let's begin our journey down domain services now by looking at the three major options you have available when you're trying to deal with authentication in Active Directory. To begin with, we have the new service that Microsoft released with Azure and Office 365, which is Azure AD, also known as AAD or Azure Active Directory. This is the primary mechanism now and should be your first choice generally when trying to develop any new services and use their authentication mechanism. If Azure AD is supported, that is the way of the future. Then we still have Active Directory domain services. This is where you might install a Windows Server 2016 or Windows Server 2012. You might already have one running on premises, and you do a DC promo on that server, and it sets up your directory service. So if you're in an enterprise, you probably used to log in on your laptop and you authenticate. You're authenticating against Active Directory when you do this. Then we've got Azure Active Directory Domain Services, AADDS. Now this is a little bit different. This is where we actually have a managed version of Active Directory Domain Services. And we'll go into all three of these in a little bit more detail, but it's very important to be clear about which one you're talking about whenever you're dealing with Active Directory services in Azure. So let's take a look at Azure Active Directory in a little bit more detail. Again, that's AAD and has the icon depicted on the right-hand side. This is the modern AD service built directly for the cloud. It's often the same as your O365 directory. So if you have O365 already, you probably already have Azure AD and a tenant there. That's probably what you're going to use in your enterprise. You don't have to necessarily create a new directory service. It can sync with the on-premises directory service as well. And it's very important, as you'll see when we cover AD Connect Sync shortly. Then we've got Active Directory Domain Services. So again, this is a Windows server with Active Directory Domain Services role installed on it. This is legacy Active Directory since Windows 2000. It's your traditional Kerberos and LDAP functionality that you might need. And it's deployed on Windows OSs, usually on virtual machines. So, it can be still physical in some environments today, but for the most part, most people deploy it on a virtual machine. Then we go into Azure Active Directory Domain Services, AADDS. And this is a managed version of the predecessor we just looked at. So Active Directory Domain Services, if we want that fully managed for us, Microsoft will build that domain controller and maintain it. That's what Azure Active Directory domain services are. It allows you to consume domain services then without the need to patch and maintain domain controllers. So that's the single best benefit of this, is maintaining a whole directory services infrastructure can be quite a bit of work. Yeah, that's taken care of for you. The one thing to note, this does allow then domain join, group policy, LDAP, Kerberos, NTLM, all of that is supported. Again, you don't have to manage it. So this is especially good for people that aren't familiar with Active Directory domain services. They can simply go in and set up AADDS and get that functionality provided to them as a PaaS service in Azure. To begin our journey down identity, let's take a quick look at Azure AD as a whole. And you might have seen this image before, which you can find at the link below, where Microsoft has a pretty good write-up on Azure AD fundamentals. But to begin with, Azure AD is really becoming the center of the identity world. You can kind of see it there in the middle of the picture. On the left-hand side, we have on-premises, because people traditionally had Windows Server Active Directory, sometimes known as Active Directory domain services, on-premises, other directories and things that they may have historically used. A lot of those directories are on-premises, and now in the public cloud, SaaS-based world, we've got all these other solutions running out there, whether it's ServiceNow, Salesforce, etc. And, identity sprawl was just becoming a big problem. People had identities in their business and then had that same identity in another business. Take an example, when you onboard somebody from a customer and you create a new user for them, well, what if you could just trust the identity that they've already got and the authentication mechanisms that they're already using? And so Azure AD ultimately was a solution to that. How do we sync up with our identity on premises, as well as, enable collaboration from a consumer and a business perspective with identities, with other businesses that we deal with and consumers that we deal with. And at the heart of it also is three things: simple connection, self-service, and single sign-on. In fact, if we look at the Azure AD features in a little bit more detail, aside from being that enterprise identity solution, that single identity to keep, users and groups and everything all in sync across your enterprise, that's point number one. Adding single sign-on provides the ability to have single sign-on to apps and services. We don't have to go sign on again and again every time we want to access something. If there's applications we access, we've been given permissions to access them. We've already signed in when we logged in with our laptop, and maybe we use some kind of Face ID and other authentication on top of just a password. That's kind of there for you. And then we've got multi-factor authentication, as I was kind of just alluding to there. It's one thing to have a password. That's something I know. What about something that I have? Maybe that's a cell phone where I get the text message and I can key in that code. Maybe it's some biometrics, things like that. That just enhances sigurity. So when we think of single sign-on and multi-factor, they're both great things, because I've got multiple ways to authenticate. And then once I'm authenticated, I'm signed on, and now I can access all my apps and infrastructure services that I need. And finally, just that self-service empowerment to the users. Nothing more annoying than getting password reset calls day in, day out. We can empower users to do self-service password reset, but also empower them to, access the apps and the services they need. They can go to like a My Apps portal and request what they need. And so all of this comes together and is ultimately why Azure AD is so important, and particularly as it relates to Azure. You're using Azure AD potentially for Office 365 and other things already. When it comes to Azure, now we're able to use that same identity solution and give it permissions in the Azure world. And so you'll see in the upcoming demo, we'll create a new Azure AD tenant and then go from there, show you how to create users, groups, etc. In this demonstration, we're now going to look at creating a brand new Azure Active Directory tenant from the Azure portal. So let's head over there to begin. And in the Azure portal, the first thing to note is on the top right, when you log into Azure, you're logging in with your account, and you can see it's associated with AZ Exam. If I click this other icon, Directory plus Subscription, and I go to the bottom here, I can see all the directories that I have access to with that account. So in my case, this account originally was only associated with this one directory, the default directory, ncollierlive.onmicrosoft.com. If you create a brand new account, you'll see something similar based on your name that you've keyed in. And I've gone ahead and created this additional AD tenant, AZ Exam, which is what I use for a lot of the demos now going forward, as well as other domains that you may have seen in previous demos. But if I go ahead and go over to Azure Active Directory on the left-hand side, and if you don't have it in your favorites bar, the other way you can access it is by clicking All Services and then searching for Azure Active Directory. But in a moment, it'll pop up with our Azure Active Directory menu blade. Okay, and once that's up, you can see, again, azexamdemo.onmicrosoft.com, the domain AZ Exam, and I'm currently using the free tier of Azure Active Directory. And you will notice for some services that you try to do, if you're playing around with them, there's also the concept of these Azure AD Premium P1 or P2 licenses, and you can grab a free trial if you're experimenting with things in there. But for right now, if we want to create a new directory, what I need to do is on the right-hand side, scroll down, and you'll see an area, Create a Directory. If we click that, that allows us to give a new organization name. So perhaps I'm going to call this AZ Exam Test, just to distinguish it differently from the one I already have. And I'm going to call it AZ Exam Test .onmicrosoft.com, and that is available. Now those are globally unique, so if you try to do something that somebody else already has, it's not going to let you do that. It does need to be completely unique on the onmicrosoft.com domain, and then choose the country that we'll create it in, and then go ahead and click create, and that will take about a minute to get that directory created. So we will fast forward here while that completes. Okay, and after a while that notification pops up and the directory is created. Now what I need to do, if I click the directories and subscriptions filter and scroll down, might have to just refresh it if it's not showing correctly. So just refresh your portal and then click that again. And you can see we now have AZ Exam, which is the current one that I'm in, and this new one, AZ Exam Test. Now, something important to bear in mind, if I click AZ Exam Test, it's now going to switch over to that AD tenant. I'll need to log in with my account. And then if I go in here and go down to subscriptions, which I might need to add back, so go back to all services and just add subscriptions back to your favorites and click subscriptions. And what you'll notice straight away is I don't have any subscription yet, because that original subscription I've got is only associated with that other Azure AD domain. Now that's not to say I can't give, additional subscriptions to additional domains. I can certainly have lots of domains with lots of subscriptions, but the subscription has one unique domain that it is associated with. If I want to give somebody access to that subscription from the other domain, they could be a user in this domain. I would need to trust them and grant them access to the other subscription, but I can't reassociate that subscription with this domain. So something, again, just keep in mind of and really, hit home on is subscription is a one-to-one mapping with that Azure AD tenant specifically. The other things to just keep in mind, if we go back to Azure Active Directory, you will see users and groups, which we're going to cover in the next demonstration, but there is a role, an administrator, that is created already for you. If I go down to Global Administrator, this user is created automatically, and this is, my user account. That is the global administrator for that specific domain. That's essentially, the ultimate rights for that domain, and you can, give out additional global admin rights to other people as needed, but that's created for you automatically, which makes sense. The first person to create the Azure AD tenant needs to be the global administrator. Think of that as just as important as if you have legacy Active Directory. That was kind of your AD administrator. You had very few people you'd give those rights to because they, need to be kept very, very secure. But with that concludes this demonstration. If you need to head back, simply click the directory and subscription again, go back to your other domain if you've got one, and then if you want to delete that other domain, just go back there and delete it directly from Azure AD as well. But that's how you go about creating your new Azure AD tenant. In this demonstration, now that you know how to create an Azure AD tenant, it often makes sense to then know how do I create users and groups in that tenant. So we'll head over to the Azure portal to get started. And in the portal, let's head straight over to Azure Active Directory. So we'll click that. If you don't have it in favorites, again, just click all services and type Azure Active Directory and it will come up for you. And you can see we're in azexamdemo.onmicrosoft.com, the short name being AZ Exam. Now I can go ahead on the left-hand side and click users, and this is where I create new users in my directory, and I can see the users that are already in there. So I can go ahead and click new user, and let's call this one John Smith. Very unique, I know, and that can be J Smith at. Now this is important. If you just do azexam.onmicrosoft.com, you'll notice it won't actually work. It'll give us a little error, and that's because if we can go back to the directory, you'll see it's azexamdemo.onmicrosoft.com is the full name for that specific tenant. So if we just add demo to that, we will then get the green check and everything is good to proceed. For profile, this is just work data, first name, last name, job title, department, etc. Properties you won't need to go into. That's just around the source of authority. So in this case, Azure Active Directory, nothing you need to configure there. And groups we'll come back to after we've created the specific user here. And this is important, the directory role. So what role do we want to give them inside of Azure Active Directory? They can be a user, or they could be a global administrator or limited administrator. And you can learn more about directory roles, by clicking the link right here, and that'll get you some more information on the different role types available to you. Then we go ahead and you can look at the password if you're just trying to give it to somebody that's, say, right next to you, or if you're going to email it off. But you can see it there and you can copy it and paste it out to give to that person. They will be prompted to change it after logging in for the first time. But you click create and that goes ahead and creates that user, and then we see John Smith, is there and, ready and available. If I refresh now as well, you'll see the source isn't updated straight away. If we go back into users now, John Smith, you can see the source is Azure Active Directory. And you also see that some other sources can be like a Microsoft account. In fact, if I do a new guest user, I can give an email address here, and I can also say invite somebody, perhaps my Gmail, so nickcollier@gmail.com, come join my AD tenant, and that will actually send an invitation out to me personally at my email address and allow me to log in as a guest user as well. And you'll see that user type then appears as a guest. But that's it for users specifically there. That's how we create them. If we go back to the AZ exam tenant and click groups now, this is where I can go ahead and start to create groups of users. So perhaps I want to create a Azure administrator group. I'm going to create a security group. I'm not going to create an Office 365 group. This is for security access to Azure AD. I'll call this my Azure admins team, all the Azure admins as an example. And then I can go ahead and say this is assigned, click the members, and basically you'll see them all listed here along with other service accounts that are there as well. I can simply type in John and you'll see John Smith is there. Click that name, click select, click create, and that's going to go ahead and create that group and include, John Smith already in there. Well, how do I actually assign permissions to that person? Well, that's all done using RBAC, as you might have seen already if you jumped to that section. So we can go back to, say, our Azure subscription. If I click it down here, go in and select the Visual Studio Enterprise subscription I have, click access control, and then go ahead and add a role assignment. So this is where I assign rights and scope them to specific objects again. So I can scroll through here and I can choose the Azure admins team, or I could still choose John Smith directly if I wanted to. But let's say I just want to assign it to the group. This way, every time I want to give somebody access, let's say this could be subscription owner access. So click the role. I would choose owner. This is, complete rights to the subscription. I'm assigning it to that group, and anybody I put in that group will be given access to the subscription. So certainly something you wouldn't want to just give out, randomly to people. The subscription rights are obviously very, very important, but you also saw from resource groups, you can assign rights specifically at a resource group. You might want to group people by department. You might want to group them by, geography. You might want to group them, by their business division, all sorts of things that you can basically do to, carve out the rights and roles that make, the most sense for your organization. And with that, that concludes this demonstration and hopefully gives you an insight into how you create users and groups into Azure AD. Okay, it's time for us to look at configuring self-service password reset in Azure. So let's head over to the portal. And the first thing you'll notice is I'm not in that same Azure AD directory that we created previously. And that's because you do need a P2 premium trial in order to do this demonstration. I've already used up my trial there, but I do have a P2 license in this particular Azure AD. Now, you can go ahead and just create one trial that should work fine for you. It'll prompt you when you try to do this. But if I go to password reset, in this directory, you can see, first of all, this section is around who do I want to configure self-service password reset for. I can choose none, select it, in which case I select specific groups, or everyone. So I'm not going to do that right now. I want to show you more around just the methods and the options available for it. So this is really, really important because let's say you give somebody the ability to reset their password, well, you can choose the number of methods they're required. So 1 or 2 here, and you can see the options. So mobile app code, it's in preview, and mobile app notification, both need preview options there that work with a mobile app. But the common ones are email, mobile phone, office phone, security questions, and you can say, okay, 1 email is enough, so they'll get the email to click confirm to make sure they're authenticated, or you could require 2, so email and perhaps a text message to a mobile phone. That's what this is all about at this point. In addition, we've got this registration section, so require users to register when signing in, which we would want, obviously, and a number of days before users are asked to reconfirm their authentication information. So you want to make sure that authentication information is up to date. People change email addresses and things like that they might be using for authentication. Phone numbers, all that kind of stuff is really what that's about. And that's really all there is to it. Once we've kind of got that configured, then we have a web page that the users can go to in order to reset their password. Essentially the user will get a prompt when they're trying to log in. They can click the link, or you can simply go to aka.ms/sspr, and that will take them to a page where they can put in their user ID, put in some characters here. It'll prompt them for those questions and allow them to reset their password. Now, flipping back to the portal and clicking properties, you can see here I've enabled self-service password reset, and I want you to see what it looks like when you actually go ahead and do that, and what the user's prompted for the next time. If I go over to this other tab that I've already gone ahead and selected, you can see more information required. And so I'm required to go in here and actually set up authentication. I've already done my telephone there, so I'm just going to blur that out, and I just need to do my email as well. So basically I type in an email address, it'll send me a code, and then I punch that code in here once it comes through on my phone. By phone, I mean I'm receiving an email on Gmail on my phone there, so I'm going to input that code. And then both of those authentication methods are verified, so I click finish. And now I've actually set up self-service password reset for my account. So now I can go to that web page and do the reset, and it will actually work for me. A few other quick settings though, just notifications, notify users on password resets, always a good thing to keep on. And if you're having trouble in particular, with admins or something going on in your environment, you can also notify all admins when other admins reset their password. So if you just want to be in a very high security profile for a while and just know anytime an admin resets, if you're concerned about an attack or something, it might be good to turn that on. Otherwise, it's honestly just a lot of noise otherwise for most people. There is lastly a customization section here, so you can customize that help desk link if you want to, and the help desk email as well. And with that, that concludes this demonstration and hopefully gives you an idea of where you go to do self-service password reset. Before we end off this lecture series, we do need to understand the different editions that Azure Active Directory pricing comes in, and you can use this link on the top of the screen that you can see we're already in, and it will also be noted in the accompanying study guide as well. But it comes in 4 editions: free, basic, premium P1, and premium P2 that you can choose between. Now, the big differences between them that you need to be aware of: first of all, the free version has a 500,000 object limit. There's no object limit in the basic premium P1 and P2 versions. If we scroll further down, under single sign-on, you can note that the free version only allows 10 apps, as does the basic one, 10 apps per user. And the P1, there's no limit, and the P2, there's no limit. So as soon as you get into the premium ones, single sign-on can go more than 10 apps is the way to kind of think about that. If we scroll further down again, you will see that the free version does not give any of the group-based access management provisioning, self-service password reset, company branding, all of that. None of that's available in the free version. And now let's scroll down. You'll see the section called premium features. And you've got things like advanced group features, self-service reset, change, unlock with on-premises write-back. That's that password write-back we talked about in the tutorials. Device objects we talked about in the tutorials. Multi-factor authentication. See, all these features we were going through are mostly premium features. If we scroll further down, and definitely become aware of this list, but I want you to be aware of what's different in P2. And so we have things like identity protection. So this is where Azure is actually using threat intelligence to help protect your identity. Privileged identity management is the big one. And this allows us to give perhaps roles that we want people to impersonate when they want to elevate their credentials. So for example, perhaps we've got an administrator role in Azure, but we don't want to just give that out to everybody as standard. We give them a normal user role that they can't do too much with. And when they have a task that needs a role that gives more permissions, as you probably saw in the RBAC section of the course, well, privileged identity management allows that person to say, okay, I want to be this higher level role, do my work, and then when I'm done, it sets me back to my standard role. And so that's a key one there. In fact, those two are in particular are key: identity protection and privileged identity management, as well as if we need to integrate with third-party MFA partners as well would be another good one to remember for the exam. In the exam, you're going to get a lot of story questions, and they'll generally be around these particular limits. So I'd say look at the object count in particular, and then know the differences between premium and the standard versions, and then know the difference between premium P2 and premium P1. As you saw from the previous module, there are a lot of directory services to think about, and often we already have something on premises. We probably have that on-premises Active Directory controller running on Windows Server 2012 or 2016, and we don't really want to create a whole new source of truth when we move in towards Azure Active Directory. Perhaps we already have started some of this when we do O365, but if we're starting out fresh, we need to make sure they remain in sync, and that's where Azure AD Connect really comes in. And so Azure AD Connect has a number of components. First of all, it has synchronization services. This component is what's responsible for creating the users, groups, and other objects in Azure Active Directory. It's also responsible for making sure identity information for your on-premises users and groups is completely matching the cloud. What we don't want is a complete mismatch there, because then everything gets out of sync and gets very, very complicated. It also has an option for Active Directory federation services. This is optional, and federation really allows us to configure a hybrid environment using an on-premises ADFS infrastructure. And this can be used by organizations to address more complex type deployments, such as domain join SSO, or perhaps we have third-party MFA solutions. MFA is multi-factor authentication that you'll hear about soon. Perhaps with smart card solutions, things like that, that we need to integrate with. We might need to use Active Directory federation services. And then finally, we have health monitoring. This is called Azure AD Connect Health, which you'll see in the third module in this section of the course. And this provides robust monitoring. It provides a central location in Azure for you to view all your health activity and making sure that your domains are all in sync and there's no issues. It helps now to take a look at some of those AD Connect sync features in particular. And first of all, we have the concept of filtering. And this is used when you want to limit which objects are synchronized to Azure Active Directory. By default, all users, contacts, groups, and Windows 10 computers only are synchronized. And you can change this filtering based on domains, organizational units, or other attributes if you want to. We then have the concept of password hash synchronization. And this synchronizes the password hash in your on-premises Active Directory up to Azure AD. So the end user can use the same password on-premises and in the cloud, but they only have to manage it in one location. Since it uses your on-premises Active Directory as the authority, you can also use your own password policy that you decide to implement in your on-premises Active Directory. And this comes up a lot when clients are sometimes using password policies that are in, say, Active Directory domain services from Azure. That's the managed Azure AD domain services, to be specific. It may not give you the same password policy features. Whereas when you use an AD Connect sync, if you've got a password policy on premises, that will carry over to Azure AD. We then have the concept of password writeback, which will allow your users to change and reset their passwords in the cloud, and this will write back to on-premises. We have the concept of device writeback, which will allow a registered device in Azure AD to be written back to your on-premises Active Directory, so it can be used for conditional access. We have prevent accidental deletes, which is turned on by default, and this protects your cloud directory from numerous deletes at the same time. So by default, it allows 500 deletes per run, and you can change the setting depending on your organization size. And finally, great feature, obviously, automatic upgrade enabled by default for all the express setting installations, and this ensures your Azure AD Connect infrastructure is always up to date with the latest release. You don't have to worry about going ahead and updating any of that. Now, before we wrap up, make sure you understand the different password sync options, and there are three major ones. So we have password sync, and this is where we're ensuring that user passwords are the same in both directories, Active Directory domain services and Azure AD. An alternative is we have pass-through authentication. This is where we authenticate, and instead of Azure AD authenticate, it actually passes that request onto the ADDS server, gets the approval, sends it back to the user that way. So essentially a single source being ADDS. And finally, we have ADFS, which is using Active Directory Federation services to fully federate across ADDS and Azure AD, along with other services. So perhaps you might have ServiceNow as an example, as a SaaS service a lot of people use for ticketing, things like that. Perhaps that's using ADFS and is federated with your Active Directory domain service. So just make sure you understand these three. And with that, this concludes this part of the module. Let's take a minute now to talk about single sign-on, which you probably use a lot in your everyday life, particularly in your IT world. And in Azure, this is provided by Azure AD Connect for users using password sync or pass-through authentication. It does require a company device with a modern browser in order for this to actually work. But essentially what it's allowing you to do, if you turn this on, is you can authenticate to your laptop with your Active Directory domain services credentials, and then you're no longer required to authenticate with Azure AD. It's associated that Azure AD account with your ADDS account. And so when you're in your browser already knows, okay, this person's already logged on locally onto the machine. I don't need to prompt them again in the web browser. I can just pass through that authentication. Now, it's important not to confuse single sign-on with multi-factor authentication, as they serve two different purposes. Single sign-on is about signing on once and then being allowed access to all of my services. Multi-factor authentication is about checking to make sure I am who I say I am. And it works by requiring two or more of the following verification methods. So your common one, something you know, like your password. You go to a website, you type your password in, that's something you know, that's something you remember, and that authenticates you. But that's not necessarily enough on its own. In fact, in modern security practices, we just assume that passwords will get compromised at some point. So we move on to something else. Something you have is one example. So perhaps a cell phone that you have on you where you can get a text message or a phone call, or perhaps something you are. So biometrics are a really good security mechanism here, where perhaps you use a fingerprint reader and that verifies you are who you say you are. But one alone is not enough. Multi-factor authentication is all about what it says, multi-factor. So you might have your password plus the biometrics, or your password plus the text message, and then that will authenticate you onto the system. And then you're signed on. Now you have access to all of your services via single sign-on. It's important then to understand the different verification methods available. First of all, we have a phone call. This is where a call is placed to the registered phone number of the user. They might be required to enter a PIN or just press pound on their phone to verify they are who they say they are. That's one option there. Text message, again, the common one we talked about, Google being classic example, sign in, get the text message, enter the code, move on. Mobile app notification, this is a great one where you might, instead of getting a text message, just go onto an app, approve the request, and everything moves forward. Mobile app verification code, this is where the mobile app, which is running on a smartphone, displays a code that changes every 30 seconds, and the user finds the most recent code and enters it on the sign-in page. So a little bit different to the text message. The app is actually spinning through, and every 30 seconds it shows you a different code, and then you put that code in, and then finally this third-party solutions you can integrate with as well. So with that, this concludes this section on MFA and single sign-on. I definitely encourage you just turn on MFA in the portal and it'll show you very easily how it works, and you can set it up to just get a text message on your phone when you're signing into Azure, and that should make it pretty clear for you. It helps to also understand some of the other mechanisms for securely authenticating users. And these could be from a business to business perspective or business to consumer perspective. And we'll start here with the business to consumer. And this is where a user tries to log into, say, an application. Perhaps you've designed a new web app, but instead of requiring, a whole new identity to be created, you might still offer that, but you could offer them, log in as Google, log in as Facebook. Those are things you've probably seen as you browse the web. Well, Azure AD B2C is the mechanism by which you do this. It's a cloud identity solution built for web and mobile applications, and it's highly scalable to hundreds of millions of identities. It works by enabling authentication for social accounts and enterprise accounts. And so you can bring those accounts into Azure AD B2C and then associate them with your application. So you can use those authentication mechanisms you see on the right-hand side without you having to manage, that user saying they are who they say they are. You rely on those services to do it. You then decide what the user can access once they've authenticated with one of those services. And that's B2C. So that's a consumer-driven option. Then we've got B2B, which is business to business. And this is a little bit different. And this really allows us to work with other partners. So it allows us to collaborate with partners outside of our organization. Users basically receive an email with a confirmation link upon invitation. And then imported users are Azure AD external user objects. So that's the difference. The authentication is all happening at the other, company's Azure AD, but now there are external user objects that we've imported in because we've got this trust relationship with our partner. And then they have access to shared apps, resources, documents, etc., whatever we decide once they're authenticated. A little bit similar to the B2C option, but again, we're using a partner relationship here to do it. Partners access with their own credentials. So again, we're not managing that identity. They own the credentials, we don't, but they get enterprise level security because it's still Azure AD. They're still using Azure AD on their side. We still have the ability to decide what they can do once they're in our system. And that's B2B and B2C in a nutshell for you. So in the previous demos, we looked a lot at Active Directory domain services, which we traditionally set up on a Windows VM, essentially in an IaaS configuration. But what if you need the features of legacy type domain services but don't really want the effort of managing a domain controller? Well, to some extent, Azure has a feature called Azure Active Directory Domain Services that includes probably about 80 to 90% of the features that you'll probably need from the legacy AD domain services options. And this is essentially that managed service that Azure provides for you. So instead of us having the VMs that we have to provision and build the domain and then sync those users up, we're going to do something slightly in reverse here. We're going to take our Azure Active Directory and create Azure Active Directory domain services from that. So to begin with, let's head over to the portal and take a look around. And in the portal, the very first thing we need to look at are our networks. So if I go into virtual networks, you'll see I've just got one VNet, but if I go into that VNet, you'll see there's a default subnet. If I go down to subnet, and I've got the default subnet, and you can see I've already created one for domain services. So I've got a 10.0.4.0 /24 for all of my VMs I'm using for this demo, and then for domain services 10.0.5.0 /24, and that's because it's recommended that you put Azure AD domain services in its own subnet. This is all going to be managed all directly from Azure, so they like it to be there. So to get started, I've got a VM that's just built. So if we go to virtual machines, you'll see we have generic VM01, which is the VM we will join to the domain once we provision Azure AD domain services. But to get Azure AD domain services up, I simply select create a resource, and we'll type in Azure AD. We can see Azure AD domain services are there. Let's go ahead and select create. And we're going to use an existing resource group, which we have for identity, and put that in central US, and go ahead and click OK. Select our network. So we've only got the one network, and then we will select that domain services subnet that I've already created. Click OK. Administrative group. So if we select this, you can see this is the AADDC administrators group, and they will have privileges to manage this domain. So if I click this one, you can see I've got myself in there right now. I'm going to be the member that has the domain admin rights to the domain. So we'll click OK on that, but I could add additional members if I wanted to. But with that, that's everything I need to type in, and I can go ahead and click OK, and it will go ahead and start provisioning that managed domain services environment for me. And I'll fast forward here while that completes. Okay, and after 20 minutes or so that's completed, that domain is provisioned. The last step you do need to complete is grab these DNS servers. I've got 10.0.5.4 and 5.5, and we just need to go over to our virtual network and update those DNS servers. So I can click configure DNS servers, go into custom, and go ahead and put the first DNS server in there, put the second one in, and click save. And that's now saving and updating the network. So DNS for those networks will point to these domain controllers. And that's it for setting up AD domain services. The last thing we need to do is simply go over to a virtual machine and join it to the domain. Okay, with the tutorials out the way, now we want to actually go ahead and connect a Active Directory domain services forest to Azure Active Directory. So to set the stage, let's go over to my domain controller that I've already created. So let's RDP into that. And you can see that we're RDP'd in here, and I've created a new user in this domain called student demo. So first name student, last name demo, and that's all running in here, and I'm just RDP'd into the domain controller. Setting up a domain controller is outside of scope for this course, but if you are having trouble with that, simply search for Active Directory domain services. You'll basically build a Windows server, and then you'll do what's called a DC promo to create your new Active Directory forest on that particular server. So let's go ahead and now and do AD Connect. So let's go over to Google Chrome on this machine, and you can see here in Azure, and I want to now synchronize those users from my on-premises Active Directory up to this Azure Active Directory. So to do that, let's scroll down on the left-hand side, and you'll see a section called Azure AD Connect. Select that, and you can see that sync status not installed, but we can go ahead and click Download Azure AD Connect. Okay, that download's complete, so let's go ahead and run that. Okay, and after a little while that pops up. If we click this icon on the bottom, you'll see the wizard, and you can see there, welcome to Azure AD Connect, run this installation tool on the server where the synchronization service component will be installed. So I'm already on my domain controller. I accessed Azure through Google Chrome on that domain controller, so I downloaded it straight to the machine I want. So I agree to the license terms and privacy notice, click continue, and you can see that because I've only got a single Windows Server Active Directory forest, I can use express settings for that, and you can see that it's going to configure synchronization of identities in the current AD forest. So we'll go ahead and click use express settings, and then I need to give a global administrator. So this is a user in Azure AD, that's a global admin. So I created one before as well in this new domain called John Smith, so we will key him in here. And once complete, simply click Next. If there's any problem, it will let you know straight away there if that user isn't authenticated. And now I need to give some credentials for a local user that's a domain admin on the local machine, the domain controller itself. Again, click Next once you've inputted that. Now when we get to the screen, you can see we have Azure AD sign-in configuration. So I'm going to continue. I'm going to say, yep, I want to continue without any verified domains. Go ahead and click Next, and everything will continue and start synchronization as soon as configuration completes. We'll check that and click Install, and everything will go ahead and install now, and then it will begin synchronizing those users. So I should see that student demo user appear in Azure Active Directory when all is complete. Okay, and after 5 or so minutes that completed successfully, and I'm going to go ahead and click Exit, and let's take a look now at Azure AD Connect in the portal itself. Let's do a refresh here, so let's go back up to the top. Scroll back down to Azure AD Connect, and we can see that sync status is enabled. Last sync was less than an hour ago. Password sync is enabled as well. And you can see user sign-in though, federation disabled, seamless single sign-on disabled, and pass-through authentication are disabled. Now if I go over to my users in Azure AD, I should see that new user. There it is. Yep, student demo is now available in Azure Active Directory. And you can see the source there, which is Windows Server AD, as opposed to these other user accounts which were created directly in Azure Active Directory. So you can see very easily, installing AD Connect, great way to simply synchronize all your users from Azure Active Directories that you might already have on premises, or even ones that you may provision directly in the cloud because perhaps you have some legacy applications that rely on Active Directory domain services and they don't fully support Azure AD domain services or Azure Active Directory. So with that, this concludes this demonstration and hopefully gives you that good insight into AD Connect. In this demonstration, we're going to now take a quick tour of Azure AD Connect Health so we can get status on our sync and our domain controllers that we're syncing with Azure AD. So to begin with, we'll head back over to our domain controller that's connected to Azure AD via AD Connect. So here we are in that domain controller again, and we're still logged into Azure through our Chrome browser on that domain controller, and you can see our sync status is still enabled. Our last sync less than an hour ago, so everything's still in working order there. But if we want to get some more detail, we can scroll down and see at the bottom there's this feature called AD Connect Health under Health and Analytics. And this allows us to do two things. It allows us to monitor the synchronization service as well as the on-premises infrastructure as well. So if we click AD Connect Health, This will take us to the dashboard, and you'll see there this quick start item that we'll go to in a minute, but also here's the status of our Azure Active Directory Connect sync. So providing we did that AD Connect that we did, we get in status there, and if anything is wrong, we'll be notified at this point. If we had federation services, we would need to install an additional item, and that would give us results and analytics around AD federation services. And same for Active Directory domain services. If we want more information, we do need to install an additional piece for that. At the bottom, there are some other settings like general settings for auto update and users and groups as well. From a role-based access control perspective, you can get here also. But if we go back to Azure AD Connect Health and scroll to the top, and let's hit this quick start item, and on the right-hand side, you'll see, if we scroll further down, this option to download and install Azure AD Connect Health agents so we can get health and usage information for our on-premises services. So first one, download Azure AD Connect Health for ADFS. We're not going to do that in this demo because we don't have ADFS configured. We've already done the download of Azure AD Connect, which we used when we did the sync, but we can go ahead and grab this one, download Azure AD Connect Health for ADDS. So let's grab this one. That will now download, and we'll go ahead and run that. And click Run, and click Install. It'll validate all the prerequisites are there. Okay, and that setup is successful. Let's go ahead and configure it. You'll see a bunch of PowerShell scripts execute. We will get an authentication window for us to sign into Azure. So we'll go ahead and do that again. And then once complete, you should get this message at the end, started agent services successfully, and then agent registration completed successfully. And so that's all now in working order. So now if we go over to Azure AD again, let's close these down and have a look at Azure Active Directory. Go down to AD Connect. Okay, everything's still synced there, and scroll to the bottom, select AD Connect Health. And if we scroll to the bottom now, we can see we also have health status for our Active Directory domain services as well. And if we click into that one, we just get some details. We've only got the one for us, and we can see things like replication status, operations, alerts, etc. We can go and click into alerts. If there were any there, they would appear over here, and then we can give a time range. And if we want to send notifications out, we can do it from this notification section as well. So as you can see, AD Connect Health, really three things to it. Monitors the AD Connect sync, Active Directory Federation services, and Active Directory domain services. It can give us health for that as well. And with that, this concludes this demonstration. Now that we have a good understanding of the Active Directory services and how AD Connect works, let's take a minute now to just look at the design decisions associated with authentication. And let's have a very quick review of the cloud authentication options first of all. Well, you have cloud only, which means if you exist completely in Azure and perhaps you don't have any on-premises infrastructure to worry about, you could completely start with Azure AD. But most of your questions are going to focus more around what do you do in a hybrid identity scenario where you have on-premises as well. And for on-premises, you have a couple of options in the cloud authentication mechanism. You have the password hash sync plus seamless SSO, or pass-through authentication plus seamless SSO. So password hash sync, so this is the simplest way to enable authentication for your on-premises directory objects in Azure AD, because the users can use the same username and password that they use on premises without having to deploy any additional infrastructure. Some premium features of Azure AD like identity protection do actually require the password hash sync no matter which authentication method you use. So even if you do use pass-through authentication, but you want to turn on things like identity protection, you do need to have password hash sync. Then we have pass-through authentication. So this is a simple password validation for Azure AD authentications, but it uses a software agent that runs on premises. And so at sign-in, your authentication is passed through to that agent, which in turn, validates, with your domain controller. So the validation doesn't happen in the cloud here. It actually happens, on premises. In addition, you also have your federated authentication option. So when you choose, this method, Azure AD hands off the entire authentication process to a trusted, separate authentication system, such as on-premises AD federation services, and they will validate the user's password. And this can provide, a lot of additional advanced authentication requirements, smart cards, things like that are examples there. And it could be, again, ADFS or third-party providers. But let's take a look at hybrid identity with password hash sync in a little bit more detail first of all. Well, essentially, what you can see here is that, a user's coming in and wants application access, maybe to a SaaS application, maybe to one of the Azure services, where RBAC controls are applied. And so they basically need to authenticate with Azure AD. So the user goes ahead, says, hey, I want to sign in. And that authentication happens, right away, in the cloud itself. So the user can sign in and authenticate right there. The way that happens, though, is that periodically, every 2 minutes, the Azure AD Connect agent is doing a directory query with Active Directory, and it syncs up those password hashes for the identity up to Azure AD, and that's how the authentication can happen completely in the cloud. Now, if we look at this in a little bit more detail, we have some considerations here. So the effort, this is the least effort required out of the two options between password hash and pass-through authentication. It's part of the AD Connect sync process, as I mentioned, that runs every 2 minutes. So very easy to set up. You just have to install AD Connect and you're basically good to go. From a user experience, you can deploy seamless SSO, eliminating any unnecessary prompts after the user signs in, so they can just sign in once and then they're authenticated with all of the Azure AD services that are associated with that account. And then from a business continuity aspect, this is great too, because this is highly scalable as the cloud service itself scales with Microsoft Data Center. So Azure AD is highly available by design. You can rely on Microsoft's SLAs there. You can, if you want to, though, deploy an additional AD Connect server in staging mode in a standby configuration. So in the event something goes wrong with that AD Connect server, you could quickly get another one up, but not critical. You're still going to be online while you get that machine up and running. From a consideration perspective, though, the only thing is there's no immediate enforcement, in on-premises account state changes. So you can consider, if you're doing a bulk set of updates on premises and maybe you're disabling a whole set of users, maybe just do an immediate sync after that to make sure everything gets synced up successfully. So, Azure AD is aware of that. Then we move on to pass-through authentication. So it works a little bit differently. The user still goes in, signs in from their perspective. It feels the same. But what actually happens, though, is it passes the authentication through to these authentication agents that run on premises and have to be connected to your Azure, your Active Directory domain controller itself. So they need, no boundaries with their network access. They need to be able to connect to AD on premises whenever they need to. The identity is still synced. So Azure AD Connect is doing that identity sync and does the directory queries to do that. But when we actually do the authentication itself, that is passed through. Now, naturally, there are some considerations here. From an effort perspective, you do need one or more agents installed on existing servers, and it's recommended that you have 3 to make sure from a business continuity perspective you're okay, but there is an effort to installing and maintaining those. You must have access to on-premises AD controllers, and those agent servers need outbound internet access. So make sure that you consider the security implications of pass-through authentication on those agent servers that need to run, and you don't just put them out in a DMZ or something like that. In addition, from a user experience, same as the other authentication, deploy seamless SSO, and it's going to feel great for the users. For business continuity, just mentioned, you recommend to deploy those 2 extra pass-through agents for redundancy. Now, you can also deploy password hash sync as a backup method. So even if you want to mainly focus on doing pass-through authentication, maybe you've got some requirements on that, you want to enforce some policies or things perhaps on premises immediately and, have that take effect as soon as they sign in. That's one of the considerations, because pass-through authentication enforces on-premises account policy at the time of sign-in, but you could deploy password hash sync as a backup method as well. And then last but not least, we have that Azure AD hybrid identity with federated authentication. So again, the user is still going to go into AD, but they're going to get redirected. And when they get redirected, they hit a federation proxy, which runs typically in a perimeter. So if you're using ADFS as your federation service, you'll have federation proxies that run at the perimeter, and then on premises, you have your ADFS servers. ADFS is what's basically checking in with AD and saying, hey, let me do the authentication check here. It's basically checking those identities and passwords, making sure everything's good. But Azure AD Connect, same thing still going to have it running. It'll do a directory query to AD to make sure those identities are synced up, so everything knows about each other. But this is, again, you might go over to a third party to actually, do that sign in and authentication, and, you can customize pages and sign in pages and things like that as well. With that, how do we begin choosing between all of these, different authentication methods? And Microsoft kindly provides this diagram, and we'll start from the top and go through a few scenarios here. So first of all, do you want Azure AD to handle sign-in completely in the cloud? So first of all, if the answer is no to that, then you've got to decide is, do I want to integrate with an existing federation provider? If I do, then I'm basically going to be down the federation, methodologies on the right-hand side. If the answer to, do I want Azure AD to handle sign-in completely in the cloud is yes, then I've got to decide, am I able to get all the security policies I need? So do I want to enforce user level Active Directory security policies during signing. Well, those policies come from on-premises. So as soon as I choose that option, I go to the right, and now I come down the tree that's going to hit pass-through authentication plus seamless SSO, or password authentication plus seamless SSO with password hashing. Now, why are both of those there? You might ask. Well, if you want to use identity protection, one of the services in the P2 license, which is checking for leaked credentials out in the dark web, you do need that because Microsoft needs to be able to look at those credentials in order to basically scan for them. So that's essentially what that particular option is there. Now, on the left-hand side, again, if we go back, do you want to enforce user-level Active Directory security policies? If the answer is no, then I have to decide do I have a sign-in requirement not natively supported by Azure AD? Well, as long as the answer is no, I really should go password hash sync plus seamless SSO. Simplest method, easiest one to install. I install my AD Connect, I choose password hash sync, and that's the route I go. If I do have some sign-in requirement not natively supported, then I do have to sort of look at the federation options. And then again, the question, whenever I want to determine if I need to use password hash sync even with federation, you can see again, do you want sign-in, disaster recovery, or leaked credential reports? And it says leaked credential reports where Microsoft has to scan for you, and using that identity protection service, they can let you know if your users have been compromised. And that just requires that password hash sync. So that's the thing to look for all the time. If you want identity protection, you're going to need password hash sync. If you have certain customizable requirements that are not natively supported, you're probably going to be looking at federation. If you want to enforce on-premises policies that you have in your Active Directory that aren't in Azure AD, you'll probably just go through pass-through authentication, and then you can use those on-premises policies. And ideally, if you can just keep it simple, just go with password hash sync plus seamless SSO. But this is a big decision. It's really, really important because it's a decision that you will make that is very hard to change later on. It affects the way the users log in and all the services they have available. So it's important to try to really think through this, and I can guarantee you will get questions around choosing these methods on the exam itself. Okay, so now that we have a basic understanding of the Azure Resource Manager model, let's take a look at ARM templates themselves. These are the things we really care about from a deployment standpoint. And the first thing to think about is ARM templates are really the mechanism that we apply infrastructure as code. So the example on the screen there, don't worry too much about the code yet, we'll get into that later, but we define a JSON file full of code that says, hey, this is how I want my infrastructure to be deployed, and then ARM is the mechanism by which we do that. We download templates from the Azure portal if we want to, so if we've built something manually in the UI, we can download a template from everything we deployed. If you go into your resource groups, you'll actually see your deployments there that you can grab the code from. In addition, you could simply author new templates. If you're pretty comfortable with the language and you know to go to the providers like Microsoft.storage, Microsoft.compute, certainly could author new templates from scratch once you're pretty comfortable. However, you'll probably find it's much easier to start with quick start templates provided by Microsoft as a quick way to get going. And quick start templates are available in the two links below. You can see there we have the azure.microsoft.com resources templates link, and then we have the GitHub link as well. And I'm going to go to the GitHub link first of all. And if we select this one, you can see on the GitHub page, if we scroll down, loads and loads of examples for us. Azure Container Service, Application Gateway, Azure DNS. Almost every single Azure service created, somebody has probably created an ARM template for it, and it's available on GitHub. So there's plenty here to actually choose from. The next thing we need to know are what are the different types of files that we will use with ARM. Well, we have our ARM template file itself. This is the main file that describes the configuration of our infrastructure in JSON syntax. If we want to, we can also have an optional parameters file. This allows us to separate out parameters that we want to pass into the template. So rather than typing them in as we deploy the template, we can simply create a file full of those parameters. And finally, we have our deployment scripts. So these are things like PowerShell, etc., that can actually take the ARM template, or it could be that we deploy the ARM template via REST API, but this is our mechanism for taking the infrastructure as code and applying it to Azure. Next, we have our ARM template constructs. So as you'll see in the demos, when we open up an ARM template, we have a number of sections. For one, we have the parameter section. This allows us to define those inputs that we want, and again, we can pass them in at the time of creation or via a parameters file. We also have variables, so these are values that you can use throughout your template. So if there's something that we use over and over again, it doesn't really make sense to type it in every section of code. We can simply declare it as a variable and reuse over and over again. Then we have our resources. This is the main part really of defining the resources we wish to construct in Azure, so we'll use resource definitions for that section. And finally, we have outputs, which are also optional, and these are values that are returned after the ARM template deployment is completed. For example, perhaps we want to output a public IP address or something like that, then we would output those from the ARM template. So that gives you a brief overview, and I encourage you to just check out the subsequent demonstration. That will guide you through ARM templates, creating a basic one, and working through the various pieces that we've covered here. In this demonstration, we're going to build upon the overview we just covered on resource providers and use PowerShell and the Azure CLI to query resource providers in our subscription. So first of all, we're going to head over to the Azure portal and bring up a bash shell. Here we are in the Azure portal, and we're going to select the Cloud Shell at the top, and immediately it will request a bash shell for us that we can run our Azure CLI commands against. Okay, that's connected and we're signed in. And the first thing we can do is simply type this command AZ provider list. And in order to make it a little bit more readable, we'll do -- out table. And this immediately will now bring up all of the different providers, whether they're registered or not, to our subscription. The other thing we can now do is if we want to say just get details for a specific provider, we can go ahead and clear the screen and do AZ provider show. Select our namespace. In this case, I'm going to use Microsoft.compute. Add a query. Resource types. .resource type, and we'll also output this as a table. Okay, and as you can see, the big difference is now we're getting a whole bunch of resources listed out as opposed to just the providers, and everything we're seeing on screen is related to Microsoft.compute. So for example, you can see virtual machines at the top and virtual machine scale sets. And this just gives you an idea of some of the queries you can run if you're trying to do some querying directly on providers to find out what's possible, what resources are available in them. These are the commands that can help you from a CLI perspective. Now flipping over to PowerShell, and I've already connected to my Azure subscription, we're going to do the same thing but just using PowerShell commands. So the main command to know here is get -azure rm resource provider. And then we can say list available. And then we want to select some items from there, so we'll say select object. And in our case, we want the provider namespace and the registration state again. Hit that command, and same thing appears. We can see all of the providers, whether they're registered or not. And then if we want to just get the details of Microsoft Compute again, we can do get Azure RM resource provider again, followed by the provider namespace. In our case, Microsoft.compute. Hit enter. And there we go. Similar to the CLI commands, we can see all of our compute resources, whether they're registered or not, and the various locations. And that concludes this demonstration. Not too much you need for the exam there, but just making sure you know, okay, the resource providers, Microsoft.compute. Hopefully this kind of solidifies some of your knowledge around how you would query this using CLI or PowerShell. In this demonstration, we're now going to go about creating and deploying ARM templates. And to begin with, we're going to start out in Visual Studio Code. Okay, so we're in Visual Studio Code, and we can see the basic layout of an ARM template that I've got on screen at the moment. And if you look at it, you can see there's 6 major sections, 4 of which we covered previously, but notice the syntax for each of them. So for the schema, we simply reference the deployment template.json schema that's available from Microsoft. If you're unsure where to get this, if we head over to the Microsoft Azure website, and we can see here under Resource Group Authoring Templates with the link on screen that the schema is listed there, and this is the location of the JSON schema that describes the version of the template language that we're using. And if you ever want to grab the latest template format, you can go to this link and grab it from there. But we'll head back over to Visual Studio. Next we have our content version, so we could simply give this version 1.0.0.0, and it's always 4 numbers that we need to put in there, and this is up to us to version if we want to. And then we have those 4 major sections. You'll notice parameters use the open curly braces, the variables use the same, resources are defined in the square brackets there, and then outputs, same in the curly braces. But let's actually go ahead and look at an actual example. So I've opened up an Azure ARM example that we can see, and this is one you can get from those quick start templates that I referenced earlier in the tutorials. And again, we can see we've got our schema, our content version. I've not declared any parameters or variables yet. Everything I'm doing, I'm declaring in the resource block that you can see in the middle of the screen. So let me just walk you through the section one at a time. So the first piece I've got is the name of the resource. So in this case, I'm going to concatenate, so that's add storage, plus a unique string related to the resource group ID. So this is going to create a new storage account name directly for me. The type, this is the resource provider we're utilizing. So again, I'm using Microsoft.storage as my provider, and I'm using the storage account's resource type from there. Then I've got my API version. So this helps because as Microsoft evolves their services, they will update the APIs, and you're able to reference those by using the API version in this particular area. Then we have our SKU. So these are some of the things that are required as I provision my storage account. So in this case, I'm using standard LRS for locally redundant storage. My kind is storage. That's the type of account. This particular piece related to storage, and you probably saw that in the storage accounts section of our tutorials. And then the location I want to put it in, so North Central US. Any tags, I haven't declared any at the moment, and any additional properties. And that's basically the entire ARM template, and I've saved it as armexample.json. So let's go over to PowerShell and see how we would deploy something as basic as this, which is to create a storage account. Okay, so I'm over in PowerShell now, and the first thing I need to do before I can use the PowerShell commandlet, which in this case will be new Azure RM resource group deployment, so feel free to Google that now if you want to. But before I can use it, I do need to create a resource group. So in this case, let's create a brand new resource group. So I'm going to declare it as a variable, so $rg equals, and I'm going to do a new Azure RM resource group with the name sl-arm demo in the location North Central US. Okay, so that's created. If I do $rg, I should see I've got my sl-arm demo resource group name there. And now let's go ahead and do our deployment. So in this case, I'm going to do a new resource group name. Now this needs to be the string for the resource group. So what I can do is reference the variable $rg period, the resource group name, followed by the name of our deployment. So this could be any name you want to give it, so we can just call this deployment 1. And then the last thing I need is my actual template file, so I reference this with -template file. And you can just tab through these if you want. So in my case, armexample.json, hit enter. And that will go ahead and start deploying. And what we can do now is go over to the Azure portal, go over to our resource groups. You can see our sl-arm demo there, and refresh a few times. And after a little while, we can see our storage account has been created. Okay, but now we decide we want to take that same ARM template and we want to make the SKU name for the storage. So, we used standard LRS before. We don't want to declare it in the ARM template. We want to offer it up as a parameter. So let's go back over to Visual Studio Code. And what we need to do first of all is take a look at our area in the bottom here where we've got SKU name standard LRS. Now, instead of us declaring it directly there as a string, we're going to reference it as that parameter I mentioned. So first we need to do is eliminate this and say we want to reference a parameter. So quote parameters, and then we'll call the SKU name the parameter we're going to reference. And we'll just give that a capital N so we can see it more easily. And that's the parameter we're going to reference, but nothing's obviously going to work yet because we haven't declared this parameter. So let's go up to the parameter section and let's add a new parameter right here. So let's call it SKU name, followed by a colon, and let's open up our curly braces, and let's give this type string. And that is it for this file itself. Now, we know we want to pass that parameter in, but how do we do it if we want to declare it in a file as well? So let's go ahead and create a new file. And let's go ahead, and the first thing we need to do is copy the schema across. So we can go back over to our ARM example. Let's grab the top section, put that in there. I'm just going to set this to JSON. And now, if we change something at the top, we know the template is deployment template. Well, in this case, it's actually going to be deployment parameters. We can leave the content version as is. We can leave the parameters initial section as is. But where we've got the SKU name, all we need to do now is change this to value. And now we can give it the different SKUs that we want. So in this case, we're going to say standard, and let's do LRS again. So we'll deploy a new account with standard LRS, and we can add one more. So we don't need this comma here because we don't have another parameter we're adding, but let's get rid of that and check everything through. That all looks good. So let's save that. So let's call this Azure deploy parameters.json. I've actually already got one in there, so I'm going to override that. And we've got that saved. Let's just make sure we save our ARM example. And we're ready to go ahead and deploy now. So let's go back over to PowerShell. And same thing, but with a few variations that we need to incorporate. And I've just cleared the screen. And what we need to do is if we reference our previous deployment, we can still see there with the ARM example.json. But the only thing I'm going to add is a template parameter file. So we use dash template parameter file. And now if I tab through, I can see all my different JSON files, but I'm going to use my Azure deploy.parameters.json and hit enter to deploy that, and I should see a second storage account get deployed also with standard LRS, but this time I haven't declared it in the resource body, I've declared it in this parameters file. And last thing we just need to do before we hit enter is go over to Azure and just delete the previous storage account we created because we gave it a unique name of storage combined with the resource group ID, so it's not going to be able to succeed. It'll think we're talking about the same storage account. So let's go ahead and delete that first of all. Okay, and back over to PowerShell. Let's go ahead and hit enter now. And let that deployment go off. And now back to the portal into our resource group. And let's refresh. We can see on the right hand side it's currently showing one deploying, one succeeded, so we should see it any moment. And after a little while, there we are. We can see that our storage account has appeared with the same name because it's still using that unique string with the resource ID, combined with, if we go into deployments, we can look through here and look at deployment 1 again, and we can see our template and look at everything that was inside our ARM template, as well as look on the left under parameters. We can expand that out and see that we used the parameters file and we included the SKU name that way. And hopefully that gives you a good background on ARM templates. That concludes this demonstration. For the exam, just know that you need to be able to sort of read and interpret ARM templates. And in some cases, they'll give you questions where you have to kind of take pieces of code and choose which one makes the most sense for the question. Okay, so by now you know how to create ARM templates or start with the quick start templates from Microsoft and massage them to get your result. But what happens when the templates become really, really large, and what if you want to share things between teams? Well, the answer to that is linking templates. So you might start out with your main template and then have like an optional resource template for, say, virtual machines that you want to add. Then you might have a shared resource template for things like maybe your network or storage you want to share amongst other templates. And perhaps you have member resource templates that you want to consume. These might contain reusable scripts or custom scripts in them. But how do we actually go about achieving this? And linking templates is done in a couple of ways. Your inline method, which is where you create an entire ARM template in the body of an existing template. So your main template's there, and then you just start a new ARM template right inside the body. Alternatively, you can use the external method, where you link to an external template. This could be located somewhere else, could be on GitHub, for example. And what you do here is you can have your parameters still inline as you link to the external template, or you can still link to an external parameter set. So just think about that for a moment. You could have an external ARM template you're linking to and an external parameter set, or an external ARM template you're linking to, but you declare your parameters inline. Just from an inline example, if we look at it there from the properties perspective, we immediately declare a new template resource and immediately start with another schema, content version, parameters, variables, resources, etc. Again, we're just creating an ARM template inside of our main template. Just from an external example, very similar, but if we look at our properties section at the bottom there, we have a template link to a URI where we've located our next template. So in this case, I've got a new storage account.json template stored in blob storage there. And then I've also chosen to use my parameters as another external link. So I'm referencing an external parameters file as well. So pretty good stuff from a linking and ARM management perspective. Another thing to keep in mind are some of the key ARM functions, and you're expected to know these for the exam. So for example, you need to be aware of the copy function. This enables us to declare a a resource, then just say, hey, we want to copy it 3 more times, and we'll see that in a subsequent demo. We also have copy index. This is a way of us saying, okay, well, we want to name something, and we want to name it according to the iteration that's going through the loop of our copies. You'll see this in the demo again, but know that copy index, could be used to concatenate against a string and make it unique by copying that index value in there. And finally, we've got the depends on function as well, and this just tells us that a specific variable depends on another one or another piece in the ARM template that we've created. But again, I advise you to kind of check that out in the subsequent demos. It will kind of bring that home for you. Just know about these functions for the exam. In this demonstration, we're now going to use the ARM copy function to create multiple copies of the storage account that we created in our previous demonstration when we created the storage account via an ARM template. So let's begin by going over to Visual Studio Code. Okay, and the first thing we need to do is go in and look at our resource block, and you can see this whole section that I'm going to highlight is the section we want to copy again. And let's say we want to do it actually 5 times. We want to say create 5 new storage accounts, but we don't want to type this code in 5 times. We don't want to paste it there again and again and again. So the first thing we need to do is, if we just look at the name, we are going to run into a slight issue because our unique string, which is based off the name storage plus the unique string based off the resource group ID, is only going to be unique 1 time. So we want to do it 5 times. So the first thing we need to do is add in a function at the beginning, and it's called copy index. So we'll add a parenthesis, copy index, and put in our brackets and put a comma in as well there. And that's now going to take the index for the count, which we'll get to in a second, add it in front of the word storage, and then I'll still add our unique string as well. Our parameters, we haven't changed anything there. They're still being passed by the Azure deploy.parameters.json file. That's for the SKU name, where we define standard LRS as the SKU for our storage. But we do need to add our count now. So this goes ahead and iterates, let's say 5 times. So we go down to properties at the bottom, let's put a comma after that so we can declare copy, then put our colon in, our curly braces, and let's give this a name. So we'll call this storage copy, and then we're going to give it the count, which we said would be 5 times, and that is it. So let's go ahead and save that. And what I've done, if we go over to PowerShell, and I've already created a new resource group, so I'll show you that with the variable. So $RG, you can see I've got a new one called sl-arm counts, which we'll look at in the portal in a minute. And I'm going to go ahead and use the exact same command in PowerShell to go ahead and deploy that. The only thing I've changed there is the deployment name to count deployment, but everything else is basically the same. So let's go ahead and run that. Now, if you get an error like the one on the screen, just go back over to Visual Studio Code and check you've got all your commas in there. We added some variables. In fact, I can see it already there in the copy function. We forgot the comma after storage copy, and so we'll save that again and try one more time. And we can see that's going off now. So we'll go over to the Azure portal, and we'll go into our resource group sl-arm counts. And looks like 1's already there, so it's gone through the loop 1 time. Let's refresh. So 2 and 4 are there as well. And if we refresh again, we can now see all 5 are there. So 0, 1, 2, 3, 4. Because the loop starts at 0 and we counted 5 times, that's why we've gone from 0, 1, 2, 3, and finally 4. And with that, this concludes the demo. Hopefully this gives you a good indication on how the count loop works. Look for it in the exams and some of the ARM code that they give you on screen. One of the really cool features Microsoft has added is our ability now to save deployments as ARM templates, and they've added this to the curriculum as well. So let's go over to the Azure portal, and in the Azure portal, let's just find a resource group. We can actually take this one, sl-storage, that we used for some of the other demos, and you can see here, if we scroll down on the left-hand side, we've actually got a few things in this resource group. We've got storage accounts, VMs, etc. But if we, on the left-hand side, if we click automation script, you actually see it generates the ARM template. You can see on the left all the resources, the VMs, these sections in the ARM template, network interfaces, all of it is here, parameters, etc. And we can essentially download this ARM template, copy it from here, deploy directly from it again. But notice that 2 resource types cannot be exported yet, are not included in the template. And you can click this to see those error details. And you can see it's because file sync service, file shares that do sync in, storage sync service it's also known as, are not yet supported by this automation script download capability. So if we back out of that again, you'd still be able to download it, but you wouldn't get those services in there. But now think about the benefits of this. You can go ahead in the portal, deploy things manually, and then if you want the ARM template to see what it would deploy, if you try to do it more automatically, you could click download and get it. You'll probably have to do some massaging of the template, but essentially that gives it to you there, so you can use, as you probably saw in the other ARM template modules. So with that, pretty cool feature, and you just need to know where to do it on the exam. You'll probably get a question on, downloading it, and then they might even give you some code to kind of look at that came from a download. So just make sure you're familiar with ARM template templates as well, and not just the ability to download them from the portal. In this demonstration, we're now going to go ahead and look at implementing runbooks with Azure Automation. There aren't too many questions on the exam specifically around Azure Automation, but it is important to understand how you would set up an Azure Automation account and know about some of the runbooks that exist, and certainly you can expand upon this and create your own runbooks as well. Runbooks are really nothing more than automated workflows, so various tasks that you want to occur in a sequence, that's where the runbooks come in. So to get started, let's head over to the portal and go ahead and create our Azure Automation account. So in Azure, the first thing we need to do is select Create a Resource, scroll down to Monitoring and Management, and select Automation on the right-hand side. Go ahead and give your account a name. Select your subscription, and use an existing or create a new resource group. Next, you'll need to choose a location. Note that not all the regions are available here. So if you're in the US, you'll predominantly use East US 2, which is there for you. So go ahead and select that. And this part is very important. You have the option of creating an Azure Run As account. So this essentially creates those service accounts for you that you will use to execute and run your various runbooks. So runbooks don't really run as a user. You would generally run them in the context of another account. And by selecting yes to this creates that account for you. So generally speaking, you simply want to select yes for this unless you've already, built service principals and accounts, using another method in your enterprise. But with that done, go ahead and click Create. That will initialize the deployment, and within a minute or two, that automation account should be ready for you. Okay, so we're notified that that completed successfully. Now we can go ahead and go to our automation account. We just type automation in the search at the top and select our automation account. And here we are. And a few things to point out, first of all, on the right-hand side, we've got a typical overview pane, various job statistics. So this is around the workflows that might be running, workflows that have failed, workflows that have completed. But to begin, let's scroll down on the left-hand side and take a look at some of the runbook options. So if we look at runbooks, we can see, this is where we can add a runbook. We can browse gallery. There's some runbooks already published here from the tutorial section for us. We can go to the runbooks gallery and take a look at, various runbooks that have been published. And you can choose here from the source. So you can choose between the PowerShell gallery or Script Center. You can filter by PowerShell script if you want to look at graphical runbooks or PowerShell workflows, as well as if you just want to restrict your filtering to Microsoft published ones or include community ones as well. So a lot of people in the community build Azure Automation runbooks and they publish them up to the gallery, and then you can simply take them from there and begin to use them. So if you do want to use anything from the runbook gallery, simply select it. There are a lot of them in there for starting and stopping VMs, scheduling and doing it in all different ways. Let's say you wanted this one, you'd simply select it, and then you would go ahead and import that into your library basically, and you can give it a different name if you want to. You can also then go ahead and edit it and change things around if you want to as well, but this is a good way to get started pretty easily. What we're going to do though is go ahead and just create a very basic runbook to begin with. So I'm going to go back to the automation account, go over to runbooks, and go ahead and click add a runbook. And we're simply going to click the quick create option, create a new runbook, and give it a name. So we'll do a Hello World runbook in this example. And then for our runbook type, we will choose PowerShell. And you will notice that they've recently added this Python 2 option here. So if you do want to author runbooks in Python, that's a new option that's currently in preview. But for now, we'll simply select PowerShell as our option, and you can give it a description if you want to. Then click Create. And then what you'll notice is that the runbook is created, and you'll see the Edit PowerShell Runbook page that opens up. And on the left-hand side, you can see we've got various commandlets. So if we want to pull from PowerShell commandlets, Azure RM compute commands, they're all in here. We can kind of expand them out and use these commandlets to kind of build up our script as we want to. So it's just an easy way to kind of get around if you don't want to kind of go looking up PowerShell commandlets. But for right now, we're going to do something very basic. We're just going to go in on the right-hand side and type in param. So we're going to declare a parameter that we're going to ask the user for, and we'll put in the first parameter. We'll make sure it's not required, so we'll set a default parameter. Okay, and then we'll do the parameter as type string, and we'll call it name. And so if we go down below, we can simply put our script to say hello $name with an exclamation point at the end. And we can go ahead and save that, and then if we want to, we can publish it. But for right now, let's just go ahead and test it out. So we'll hit the test pane, and on the right hand side, we can put in a parameter if we want to. So you can see, because we've got that input parameter, it's asking for the name, but I can go ahead and run it without. But One thing to point out, as you can see, so first thing, when you run a runbook, it has to be queued up. So it waits for a cycle of compute that it can then, put this runbook script on and then run. In this case, it's completed already now. But if I wanted to put, hello students, we could do that. And go ahead and hit start again. It's queued up, waiting to execute. Completed, and you can see hello students. So definitely, if you're familiar with PowerShell, this should be right at home for you. Otherwise, just go ahead and look at the gallery, take some other runbooks from there and utilize those, until you kind of get familiar and get what you actually want to do. A lot of people do use these as automation runbooks as a response to events. So there's a lot of new services like Event Grid coming out too, where you can say, okay, when this event happens, fire off this runbook, or you can also just, from other monitoring alerts, fire off runbooks as well. Like, let's say you had low disk space on the C drive of a Windows machine, and it's because you had a bunch of logs that you put there and you probably shouldn't. You could have a runbook go in there and actually just kind of remove those for you periodically or in response to that event. Speaking of periodically, if we go back to our runbook itself and go ahead and publish this runbook. So that's one thing you do have to do before it's available to use. So let's go ahead and publish it. This allows you to also do some element of versioning control as well. But you will see that you have this option that appears now where you can now view the code, edit still, go back into that screen we were just at. But the schedule option is also available to you. So you can select schedule and you can link a schedule to this runbook. So we can click that and create a new schedule as well. So if we wanted this runbook to just occur at a periodic period of time, like maybe every morning at 9 a.m., that's where a lot of people do like these startup VM ones, like 6 a.m. before everybody comes in. They make sure everything's powered on and ready to go, and then shut down for developers, at 5, 6 p.m. whenever they go, depend on different time zones, etc. But this is a way you can schedule it to run, when you decide to do it. And with that, this concludes this demonstration and hopefully gives you a good overview of Azure Automation and how to implement runbooks. In this demonstration, we're now going to build upon what we discovered in Azure Automation and extend it to Azure Automation DSC. If you remember from the Virtual Machines module, we created a desired state configuration module in PowerShell for installing IIS. Well, Azure Automation allows us to automate the installation of these DSC modules across multiple machines and also check that they remain in a consistent state. So let's head over to the Azure portal to begin. In the Azure portal, as you can already see, we're in our automation account that we created in the previous module. And if we scroll down, we can see we have these options under configuration management for DSC nodes, DSC configurations, a gallery again in preview currently, and DSC node configurations. So the first thing we need to do is add one of our configurations. So we go to DSC configurations and we can go ahead and add a configuration. And in this example, I'm simply going to select the one we used in the virtual machines module. So I've got the Skylines IIS.ps1. In fact, if I right click it and edit it, that opens up and you can see we have our configuration called Skylines IIS. We have our node of localhost where we simply are enabling the Windows feature IIS, and we're going to enable ASP.NET 4.5 as well. So we can close that down. We're not going to make any changes to our DSC configuration. We simply want to apply it now from Azure Automation DSC instead of going to every single VM and putting it into that VM extension like we did in the virtual machine module. So I can select the PS1 file here and go ahead and select that, and it will populate this name. This has to match the configuration. So you can see in that PS1 file, my configuration name was also Skylines IIS, and I can give it a description as well. If I go ahead and click OK, that will create that configuration, and now I can select that configuration and I can choose to compile it. So I have to do this before I can put it onto one of my servers. And you can see it says, are you sure you want to compile this configuration? Any node configurations generated will be automatically placed on the Azure Automation DSC pool server. And this is the server that's going to essentially connect to the virtual machines and make sure all those configurations remain consistent. So we're going to go ahead and select yes to this, and that's going to compile that configuration. You'll see a job get queued up at the bottom here, and we'll fast forward a little bit. It takes a few minutes for all this to complete, and then we will have our node configuration ready for us. Okay, and as you can see, that compilation job is completed, so we can exit the screen and go now to DSC node configurations, and you'll see that we have Skylines IIS.localhost. That's the configuration that we compiled. Now all we need to do is associate it with virtual machines that we want to apply it to. So I've got a test virtual machine all ready to go. If we go over to DSC nodes, you can see there's no machines already in there. We can simply select add an Azure VM, and it is possible to also add non-Azure VMs as well, but in my demo I'm going to choose Azure VM, and then we'll go ahead and select Windows VM 01. Select this one and choose to connect it, and you can see it's actually deallocated right now. So first thing we need to do is go ahead and power that machine back on. So let's go over to virtual machines, go to Windows VM 01 and start that machine up. And again, I'll just fast forward here while that comes up and then head back to Azure Automation. Okay, that machine has successfully started back up, so let's go ahead and try that again. Let's hit Add Azure VM, select Windows VM 01, and we now have the option to click Connect. So we'll select Connect, and this connects it to this node configuration that we select in this drop-down. So I'm going to choose Skylines IIS.localhost. I can choose how often I want to refresh. I can choose the configuration frequency, and I can choose the configuration mode. And this is very important. You can see the option here of apply and monitor, apply only. So that means it just pushes the configuration, as opposed to apply and monitor, which pushes it and will check it for consistency. And then a big one, which you need to be ready for, certainly a lot of people will start with apply and monitor, but apply and auto correct means if somebody logs into the server, changes a setting manually that conflicts with the DSC configuration, when Azure Automation DSC goes and checks the configuration against the pool server, it'll say, nope, this isn't correct. I'm going to override what the person did manually and set the configuration back to how we set it here in Azure Automation. But I'm going to choose apply and monitor in my example, and a few other things here. You've got allow module override. If you select this controls whether new configurations downloaded from Azure Automation DSC pool server are allowed to override the old modules already on the target node. So if you've got old modules that you've already put on from a different version and you want to override them with this one, then that's something that you would select as well. Reboot if needed. That's if some of your configurations require that reboot, then it can execute that and then continue configuration. The last thing to mention is just that you do have this option of primary and secondary key. So there is the concept of keys in Azure Automation to basically know which Azure Automation is registered to and authenticated to run against those machines, and you can rotate those keys much like any other key. I'm not going to show you that just yet because I want to complete this configuration, but if you go back to Azure Automation, you'll have a section there called keys. You'll have your primary key and your secondary key, and you can rotate them. So you would basically then use your secondary key before you push and change your primary key, basically. If we go ahead and select OK, that now connects that VM in and will apply that DSC configuration. So again, I'm going to fast forward here because it does take about 5 or 10 minutes for that IIS and ASP.NET configuration to apply, and we'll come back once we've got some data to show you. Alright, and after a little while, we can now see that that VM is now connected, and you can see it's connected, and there's an extension version there as well, so it's using the DSC extension to get connected in. And if we go back to Automation DSC now, if we go back to the account, and if we select DSC nodes, which we're actually already still on, you can see our Windows VM on the right-hand side with status compliant. If we select this, we can now see, if we scroll down, status compliant, different times it's checked. These are the initial checks going on there, consistency in progress. And what you'll notice is every 15 or 30 minutes, depending on what you set your time interval at, you will see that these reports come in to say whether or not this VM is compliant with the configuration. And so this is the true power of Azure Automation DSC, because not only can we define a node configuration for our virtual machines, we can assign it to multiple virtual machines all in one go, and then we can continuously validate whether or not they are compliant. And this can also help with login, auditing, etc. And it can also all be fed into log analytics as well, which you'll see in the other modules. And with that, this concludes this demonstration and hopefully gives you a good sense of Azure Automation DSC and what you can do with it. Hello Cloud Gurus. First of all, just a huge congratulations for completing this course. There is so much information to cover and it's always changing, so you should feel proud of yourself right now. You've now learned everything you need to move on and take the exam. I would suggest though, take some time to familiarize yourself with the Azure console and get some more hands-on experience before going into the exam, as this will really help to cement your knowledge. I wish you the best of luck and invite you to come back to share your experiences with the exam in our forums. You can also check out all the other Azure content available to continue your journey to becoming a Microsoft Azure Master. Keep being awesome, Cloud Gurus.